Hey guys, welcome to the Introduction to Cloud Computing video. Cloud computing has been at the forefront of technological advancements for the last decade, and also it has revolutionized the way companies used servers. So in this particular session, we'll be looking into the fundamental concepts of cloud computing, starting from what is cloud computing, the benefits and use cases, and also the future of cloud computing. Then we'll be looking into the deployment and also the various types of service models. So before moving on with this particular video, make sure you subscribe to our channel and also leave a like if you enjoy our content. And also leave a comment down below if you have any queries and we would be addressing them all. Now let's get started. So what is cloud computing? So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So to put it even simply, so it's basically you're getting resources, especially IT resources over the internet, and you only pay for what you have used. For example, a very simple one, which is Google Drive, you're going to pay per GB, you're going to pay for the storage. You're not paying for the application itself. You're not paying for the code itself. You're only paying for the storage you're using up. You're not paying for the application. So basically you're paying for what you are using, and that is one form of cloud services. So we'll be looking into the different types of cloud services. I'm just giving you an example of one type of cloud service, but essentially the IT companies started using cloud services which help them scale up and scale down, which helps them to host their applications, which helps them to deploy complete data pipelines on the cloud without any hassle. So those are infrastructure services. Again, we'll be getting to that, but these are some of the examples, and the IT industry was revolutionized once the cloud providers came out. Okay, so also instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases. So basically, instead of the companies buying data centers and setting up a complete physical data center by buying all the hardware, hiring professionals, hiring security and network professionals, which will obviously cost a lot, they don't have to put in any capital. They just have to select the cloud vendor they are going to use and directly use the services they are going to provide. So if you look at this image, so you can see cloud computing. So using a cloud computing provider, like let's say AWS or Azure, they provide you services such as networking services, and they provide you software applications, security services, data storage, BI services. So you can also basically deploy your BI applications, your software applications on the cloud, and you can basically have one central portal from where you can access all of this. So that's exactly what cloud computing is providing to you. All right. So on-premises versus cloud computing. So on-premises is more of the thing which we are talking about, that is a company's own data center. They have their own data center where they have their own physical hardware, where they have to set up and configure everything. They have to hire professionals in order to basically maintain and upgrade them every single day. So for that, if you can see to the left side of this particular image, so customization and implementation, the hardware, the IT personnel who are required, the maintenance, the training for new personnel who are coming in. And so basically the ongoing costs are a lot. For example, when there is a downtime, let's say when your data center goes down, when there is a power outage, rewriting integrations, customizations. If there are applications which are dependent on other dependencies, then in that case, you'll have to upgrade them every single time when the dependency is also updated. And then the maintaining of hardware, whenever a new set of hardware comes out, you have to upgrade and maintain your network and your security so that there is no breaches, so that there are no unauthorized person who are trying to get into your data center. And basically it will cost a lot. So these are the ongoing costs in an on-premise data center. But when it comes to cloud computing, so ongoing costs are the subscription fee. Okay, so basically you put in the money on the subscription fee because everything is already set up by the cloud service provided for you, and you just have to pay the subscription fee to use it. And the implementation, customization, and training. So basically you'll have to train your employees on the cloud service, or they should be already trained in it before you hire them. There are certifications which we can take and get accustomed to that particular cloud provider. And then implementation and customization is again will be done by those cloud professionals. So to put it very simply, cloud computing is a lot cheaper than setting up a complete data center because obviously you'll have to do a lot of work and also put in a lot of capital investment upfront. In cloud, there is no upfront cost. You just pay the subscription fee and you pay as you go. That is, every single month you pay it as a bill. All right. The top cloud service providers. So we were talking about cloud computing service providers, right? The subscription fee. So the top three ones are AWS, Azure, and GCP. So AWS is owned by Amazon. They started in 2006. They started off with two services, EC2 and S3, and they basically changed the way IT companies started using servers. And then came Azure in 2010. Google Cloud launched in 2011. So, and then these guys have been at the forefront of cloud advancements, and they are the top three cloud providers in the world even at the moment. Okay, so the next thing we're going to look into is the cloud deployment models and the cloud different types of cloud services. So the three models are basically public cloud, private cloud, and hybrid cloud. So the public cloud, these basically are owned and operated by a third-party service provider while delivering their computing resources like servers and storage over the internet. So public cloud, to be very simple, so these three are all public clouds. So they are a third-party cloud vendor who provide you resources over the internet, which you are accessing it through the portal, and you're going to pay them at the end of the month for whatever services you have used. So these are public cloud service providers. Also, private cloud also can be given by AWS or Azure or Google Cloud. But again, a private cloud is basically cloud computing resources used exclusively by a single business. When it comes to public cloud, let's say there is a data center. That data center, let's say there are 100 customers and 100 customers are using this particular cloud provider. So that data center will have the servers, the storage, the other services of all those customers running in that one data center. So it's not exclusive for one particular customer, but so other customers can't access the resources, even though in one physical hardware there can be many servers running which can be of various customers. But when it comes to private cloud, you would be provided dedicated hardware. Even though it's not your hardware, you are renting it, but you will be provided dedicated hardware. Let's say you have been dedicated 10 servers. So in those 10 servers, only your company's servers and your company's resources can run. Also, a private cloud can be physically located on the company's on-site data center. Also, one more thing, in this case, a private cloud can also be set up by a public cloud provider like AWS or Azure. You can also basically purchase a private cloud subscription from them, which will give you basically a dedicated hardware, and nobody else can basically run their resources on those particular set of hardwares. It will be exclusively given to your business. And finally comes the hybrid cloud. Hybrid clouds combine the power of the public and the private clouds, bound together by technologies that allows data and applications to be shared between them. This is again pretty simple. Let's say your company wants to have an application. So the application's front end, the mission critical data, not the mission critical data and the mission critical code. So they just want to put the front end of the application in the cloud, in the public cloud, which is internet facing. People should be able to see your website, right? And then they want to put the database, which is the data, mission critical data, and the code, which is really essential for the application to work, in their own on-premises data center, that's their private cloud, so that the data is not stolen or their code is not stolen. Okay, so now the public cloud has the front end running and the private cloud has the back end and the database running. So in this case, there should be a connection between these two. So normally, if you want to make those connections, if you're separately using a public and a private cloud, you will have to use a VPN tunneling or create a peering network. So that will take some time. Instead, you can just use a hybrid cloud model, which will combine the power of both, so that you can keep whatever you want in the public cloud, and very mission critical and sensitive data and information can be kept in the on-premises data center. And many companies also use this particular cloud computing model, which is really essential. Okay, so these are the three different types of models, guys. Now let's move on to the next topic, which is the cloud computing services, the different types of cloud computing services. So software as a service, platform as a service, and infrastructure as a service. So software as a service, I already gave you an example at the beginning, which is Google Drive. So Gmail, Google Drive, all of these are software as a service. You may ask why? Because they are providing you a software over the internet. You're not doing anything, right? You're not going to code that application. You're provided the software over the internet. You're able to use the software over the internet using any device. And that application's code can be running on any remote server. That application's data can be stored on any remote server. The software is running on a remote server and you are getting that software. It's not running on your local desktop. So Gmail, if you open mail.google.com, it opens up the Gmail website, the Gmail application. So you do not know where that particular thing is running, but you're given that application, you're given that software as a service so that you can use it over the internet. So that's basically software as a service. Next comes platform as a service. In this case, application development and deployment. So basically platform as a service, they'll give you a platform in which you can, let's say there is a platform called Elastic Beanstalk in AWS where you can upload your code and it will automatically host the website for you. For example, let's say you have a Python application and you want to host that Python application. So in this case, if it is a regular one, then you'll have to launch a server, and then in the server you'll have to install all the softwares and upload all the dependencies and then deploy your application in that particular server to make it run. But if you do not want to do that, if you just want to concentrate on the code and you want to make your application better and secure enough, and you do not want to worry about the server and the infrastructure part, in that case you can go with a platform as a service, in which case basically you just select the platform, for example Python, and then upload your code and it will automatically host your website and deploy your complete application for you, and you don't have to do anything else. You just have to concentrate on the code and make sure it is compatible with the platform you are uploading or deploying it to. Okay. Next comes infrastructure as a service. So in this case, servers, storage, operating systems, database engines, any kind of infrastructure you're getting over the internet is infrastructure as a service. For example, you can launch a server and you can start basically upgrading your server. You can start installing whatever software you want in that particular server. You can basically use it like your own computer, and then you can basically terminate it whenever you want to. It's not like once you start a server, it should be running for a certain period of time. You cannot terminate or delete it. It's not that case. Let's say you want to use the server just for 3 minutes, you can do that over the cloud provider. So the main difference between a platform as a service and the infrastructure as a service is the control you get over what you're going to do. In platform as a service, you only get the control over the application which you are building. You're just deploying the code and the cloud provider will make sure to launch a server and host your application inside of it. You're not going to be given access to the operating system level. But when it comes to infrastructure as a service, you will be given software and operating system level control so that you can install and upgrade your server according to your needs. It's more of, you can configure it more. If you just want to host your application, in that case, go with a platform as a service. If you want to configure your server in order to make sure that every single part of your application is working and it's properly deployed, then you can go with an infrastructure as a service method. But it's not just servers, even storage. For example, there is something called S3 in AWS, there is blob storage in Azure. So all of these are infrastructure as a services where you're given storage over the internet, where you're given servers over the internet, where you're given database engines over the internet. Okay, so these three are the main services. These three are the main cloud computing services. And so at the beginning, learning these three are more than enough. All right. Okay, so to give you a more understanding about these services, I'll just brief about these on this particular image. So on-premises is completely managed by you. So every single part, every single aspect of the on-premises data center is managed by the company itself. So the applications which you are deploying on it, the runtime, the middleware, the operating system, the virtualization of the servers, the storage and networking, everything is managed by the on-premises, the company. Okay, and then there is infrastructure as a service. So in this case, if you see over here, the applications, the data, the runtime, the middleware, and the operating system is managed by you. Okay, so because you are creating the application and you are uploading the application, and the data which the application generates, and the runtime, for example, the runtime is basically, let's say you create a server and you are installing Python inside of it, and so that you can deploy your Python application. So it's a Python runtime, so that is maintained by you. You can upgrade it or downgrade it according to your need. The middleware is what makes the application run, the middleware, the logic, and the softwares you're using for it. And the operating system, it could be Windows, it could be Linux, it could be any Linux distribution, or it could be Mac. So all of this would be managed by you. And the virtualization, the deployment and provisioning of servers, the provisioning of storage, the management of networks, everything will be managed by the cloud vendor, AWS, Azure, or GCP, whoever you're using. Coming to platform as a service, so everything except the application and the data is managed by the vendor. As I told you while explaining in the previous slide, it basically makes sure that it creates the servers, it creates the runtime, everything for you, and it is already set up, and your application will be directly deployed into the existing setup which it created for you. So everything else is managed by the vendor except the application you've created and the data generated by the application. And finally, software as a service, as I told you, let's say Gmail, you don't own anything, everything is managed by the vendor, you don't have to manage anything, you just use the application. So that is software as a service. All right, so now moving on to the next topic, which is benefits and use cases. So first, let's just understand the benefits of cloud computing. So we've seen the cloud computing models, we've seen the cloud computing services. From that, you could understand what kinds of benefits cloud computing provides. So to just summarize and brief that, I've created this slide. So first of all, reduced IT costs. So the first thing any company wants to do is basically try to reduce their operations and IT costs, right? So that's exactly why they are trying to shift from an on-premises data center to cloud computing, so that they could cut costs and make it even more profitable. So in this case, they could easily reduce IT costs because their on-premises data center, they have to pay for the IT and the networking and the security professionals. They have to pay for the hardware. Let's say if some hardware is broken, they have to maintain and repair it, they have to upgrade it, and they have to pay for that. So there are so many hidden costs as well in running a data center. If there is a downtime for 1 hour in the data center, that will again cost them. So all of this will eventually lead to very high operation costs. But when it comes to cloud computing, you're not doing any of that. You're only paying the subscription fee, and everything else is managed by the cloud provider for you, which will significantly reduce the IT costs. You'll only have to pay for the services and the resources you're using on the cloud provider. All right. Next comes scalability. So this is really important. When it's an on-premises data center, let's say you have 1,000 users, and your application could handle 1,000 users at a time. And let's say your application has 10 servers in your on-premises data center. So now let's say each server can handle 100 users. So in this case, your application could handle 1,000 users. And let's say your application has become viral overnight, and there are 10,000 users using your application right now. So in that case, if you have only 10 servers running, it cannot accommodate all the 10,000 users. It could accommodate only the 1,000 users, which will be a significant loss for you. So in this case, if it is an on-premise data center, and if you only have 10 servers running or 10 servers available at the moment, you cannot do anything else. You can basically buy more servers and configure it and upgrade it and set it up. But again, that will take a lot of time, and that will also have to you'll have to put in a lot of capital to do that. But when it comes to cloud computing, let's say 10 servers are running, you can set up a policy which will check the traffic, which will check the CPU utilization of these servers. If they are utilized completely, it will automatically launch more servers in order to accommodate the incoming users. So let's say there are 10,000 users, and so 1,000 users can be handled using 10 servers. So now there would be 90 more servers created so that it could handle the incoming 10,000 users at that particular point of time. So let's say after some time, it's basically after midnight and people are logging out of your application. So now there are 5,000 users, there are not 10,000 users. When it again in cloud computing, so it will automatically notice the reduction in the CPU utilization in the servers, and it will automatically reduce 100 servers into 50 servers, which could handle 5,000 users. Okay, I think I'm pretty clear in the scalability part. You can scale the number of servers up or down according to the needs. You don't have to basically have to keep running certain number of servers all the time, which will cost you more. You can cost optimize your servers using basically scaling options. And then global infrastructure, let's say you have your application in India and you want to globally make it available. Let's say you have a customer base in US as well. If it is not in on-premise, then you'll have to get a space in US and you'll have to set up the complete data center all over again. But if it is cloud, they have an established global network all around the world, and you just have to deploy your application. You'll just have to duplicate your application into the US data centers, and that is more than enough for you to make sure the application is going to be available for your US customer base. And then up to date. So up to date is basically, again, they make sure it's updated, the hardware, the software, everything is updated. And one more point in up to date is that, so whenever there is a new groundbreaking AI application or an ML application is available on the so basically when it's coming out, so the first people who are going to adapt it are the cloud service providers, because they want to provide the latest innovations to the customers, basically either to retain them and to show them that they are constantly improving, because that will help their business model. So whenever there is a new technological advancement coming in, the cloud providers are going to adapt it and going to provide it to you. So you don't have to do any other work. They'll already create a service for you and provide it to you. You'll just have to use it. And then finally, reliable data backup and disaster recovery. They already have failovers set up in cloud service providers. You will just have to use those data backup services. You'll just have to use those data disaster recovery services in order to make sure your application is running all the time without any crash. So that is, let's say your application is running in one data center, and let's say there is a power outage in that complete area. So if you have not duplicated it into another data center, in that case, your application will be down until the data center comes back up. But if you have a disaster recovery failover set up and you have a standby application running in another data center, so whenever one data center fails and your application is not running in that, the standby application will automatically start running, and the incoming customers will be redirected to the application which is running on that particular data center, which is a different one. All right. So this can be done very easily using cloud computing. So these are some of the benefits. There are even more benefits in cloud computing. And then some use cases, big data analytics, video streaming platforms, for example, YouTube. So YouTube is one big example of cloud computing. And then also Netflix. So Netflix entire architecture. So Netflix went all in AWS. That basically means everything they use, that is the storage, that's the servers, the database engines, the data warehousing tools, the analytical tools, everything is running on AWS. Netflix completely went on AWS, and you can know how fast Netflix is if you have used it. And Netflix is also pretty lightweight, and also it is the biggest video streaming platform in the world, the premium video streaming platform. YouTube is the biggest video streaming platform, but with a premium, there is a paid streaming platform. Netflix is the biggest one. And in this case, they went all in AWS, and you can basically shows how big cloud computing is and how major impacts it's going to make in the upcoming future. And then disaster recovery, we already discussed it. Serverless computing. So you don't have to worry about the servers. You can just upload your code and deploy your applications without even having to provision servers by yourself. Again, we discussed it in platform as a service. And then AI and ML as a service. So this is one important thing which right now it is making strides in the IT industry. So cloud providers already have this ML ops setup. So ML ops is basically machine learning and operations, where you can create a complete machine learning pipeline using the cloud itself. You don't have to set up anything specifically. You can use the inbuilt services in cloud. For example, if you talk about Azure, there is a service called Azure Machine Learning, which will help you set up a complete machine learning operations pipeline. And again, when it comes to AWS, even they have EMR, they have code pipeline, they have their own operations and DevOps setup, which you can use directly in order to deploy your machine learning or artificial intelligence models onto the cloud computing providers. Okay, so again, these are some of the use cases. The cloud computing is used in so many different industries, and these are some of the examples which I'm giving you, because these are some major industries, and these are some of the major use cases which cloud computing is used for right now. And finally, we're going to look into the future of cloud computing. Okay, first of all, I just wanted to give you a brief about edge computing, which is going to be the future of cloud computing. So it's not cloud, edge computing is not cloud, but edge computing is like a local cloud computing network. So over here in this image, you can see cloud. We already explained over here. So this is the cloud part. So let's say this is AWS. This is the cloud computing provider. And then there comes edge. So edge nodes. So let me put it very simple here. For example, let's say you have a supermarket, and the supermarket every day it's generating 1 terabyte of data, and you want to analyze that data. So let's say you want to analyze it every single day. You want the analysis to be done every single day. In that case, when the data is generated, you're going to upload it into cloud, and then it's going to be analyzed in the cloud, and that analyzed data is going to be sent back to the local data center, the small data center which you'll be having in the store itself in the supermarket, and then you'll be using it to further analysis, right? But what if you can analyze the generated data right there in your location itself? So that basically is edge computing. You can set up a smaller analyzing system, so basically a smaller node in your local supermarket itself, which will basically speed up the process of analyzing. So as soon as your data is generated, you can basically analyze it in your own edge node, and that analyzed data would be right there in your own supermarket. So you don't have to upload or download or wait for it uploading or downloading, because obviously terabytes of data will take some time to upload, right? And yeah, so that could be done using edge computing. So service delivery, computing offload, IoT management, storage and caching. So it'll be much faster than cloud computing. So edge computing is already being implemented in various places. Even the major cloud providers like AWS, Azure, they are setting up local edge locations, and they are trying to make sure the data retrieval and the transfer of data and the services, basically it's much faster than it being on cloud. Okay, so they're already investing into it. So edge computing would be the next big thing after cloud. Okay, so the final thing is that the size of the cloud computing market. So this is according to Statista, and according to them, $146 billion is the size of the cloud computing market right now, and it is always in the increase. So it would be around $320 billion by 2025. So the size of the cloud computing market will never stop. It's going to be increasing until and unless every single company has moved to cloud, and companies are willing to move to cloud. And according to Gartner, 75% of the companies they surveyed have told that they have a cloud first approach. That is, they want to shift completely into cloud as soon as possible. So this is according to Gartner reports. Okay, and then 10.6 zettabytes cloud data center traffic. So again, so this shows that how much data has been uploaded to cloud, how much data is being analyzed in cloud. So the volume of data is going to show how big of an industry is. And if 10.6 zettabytes of data is in the global cloud data center traffic, that basically shows how massive cloud computing has grown since the first major cloud provider AWS has launched in 2006. And then 17% increased demand for public cloud services. So again, as I told you, every single company is using cloud right now, and the increase is not anything new. It is increasing every single quarter in every single year. So that is every single year, if you compare the previous quarter, there is a significant rise, about 30% every single time, in the spending in public cloud services. So this is nothing new. So basically, this is the future of cloud computing, guys. So if you are looking to learn cloud computing, this would be the right time to go for it. So you can choose any cloud provider, but AWS, Azure, and GCP are the top 3 cloud providers. After that, there is IBM Cloud, there is Ali Cloud. There are so many other cloud providers which are available, which you can choose from and start learning from. And yeah, so these 3 are the major ones. So I hope I've provided you all the basic fundamentals and all the basic information about cloud computing, where it is being used, the future of cloud computing, what are the different types of cloud computing models and services. So that's it for this particular video. Guys. I hope you all like this video, and make sure to subscribe, like, and also share the video if you really liked it. And also leave a comment down below if you have any queries, and we would be addressing them all. So thank you.
Hey everyone, I hope you all are doing good and staying safe. My name is Shashank Mishra and I'm working as a data engineer at Amazon. In today's video, I'm going to talk about the most important thing nowadays in the IT industry, that is cloud. And it is the most important skill set for any of the development profile. And if you don't remember, in my previous video, I talked about the AWS part and its important services. So if you haven't watched this video, here would be the link. You can just go and check that video. And before starting the main cloud computing video, I would ask you to like this video and share it with your friends. And if you are new to the channel, then make sure to subscribe and press the notification icon so that you are updated with all amazing videos on this platform. Alright, so now we will talk about the cloud computing, and before starting the actual component and the actual agenda of cloud computing, I just want to let you know guys that this is something which is really important nowadays. If you are in a software development or if you are even choosing any of the career profile, this is something which is really important because most of the companies, they are shifting from the on-premises thing to the cloud side. So let's say whenever you will be interviewing for different job profiles, they will definitely treat it as a plus. Like if in your past employees you have worked on the cloud components, or if you have a good knowledge about the cloud part, this is going to be treated as a plus. And even if you have mentioned these things in your resume, you will stand apart from the crowd. And yeah, that's why it is really important to know. And I will basically talk about the cloud computing from the very basic and not going to deep dive into every single aspect, but talking more about why cloud and different categorizations of it. What are the big companies which is using the cloud, and who are actually working as a cloud service provider. So we will be talking about that one. But सबसे पहले जो हम एक पार्ट देखेंगे वो ये कि क्लाउड कंप्यूटिंग है क्या. हम सब इसके बारे में इतना बात करते हैं कि क्लाउड कंप्यूटिंग. सो इसकी बेसिक डेफिनेशन को पहले हम जान लेते हैं. व्हाट इज क्लाउड कंप्यूटिंग? सो क्लाउड कंप्यूटिंग इज ऑन डिमांड एक्सेस वाया द इंटरनेट टू कंप्यूटिंग रिसोर्सेज, application servers, like it could be physical servers, virtual servers, data storage, development tools, networking capabilities, and more, hosted at a remote data center managed by CSP, that is cloud service provider. So that definition, this technical definition itself suggests what is cloud computing, that you have something which is located at the remote location, ठीक है, जिसके बारे में हमें कुछ नहीं पता है, बट जब भी हमें कोई भी ऐसा कंप्यूटिंग रिसोर्स चाहिए, वी कैन जस्ट गेट इट ऑन डिमांड, जस्ट अक्रॉस द इंटरनेट. क्योंकि आज के इंटरनेट के टाइम में हर चीज को हम वेब एप्लीकेशंस पे एक्सेस कर सकते हैं. सो सिमिलरली इवन नाउअडेज इफ यू नीड द कंप्यूटिंग रिसोर्सेज, यू कैन एक्सेस इट अक्रॉस द इंटरनेट. सो दैट्स वाई कोई ऐसी चीज जो कि इटसेल्फ कहीं रिमोट जगह पे लोकेटेड है एंड हम उसको एक्सेस कर पा रहे हैं बाय सिटिंग इन फ्रंट ऑफ आवर लैपटॉप यूजिंग दी वेब एप्लीकेशन, सो दैट इज इटसेल्फ अ क्लाउड. कि एक ऐसी चीज जिसके बारे में फिजिकली हमें नहीं पता है कि वो कहाँ पे लोकेटेड है, क्या पता है, बट हम क्या कर पा रहे हैं, स्टिल उन चीजों को एक्सेस कर पा रहे हैं जब हमें जिस भी तरीके की नीड है. तो क्लाउड पे केवल कंप्यूटिंग हम क्यों बोलते हैं? क्योंकि आप कोई भी सिंगल चीज परफॉर्म करते हो, कोई भी आपको एक ऑपरेशन परफॉर्म करना है, इट विल बी ट्रीटेड एज अ कॉम्प्यूटेशन. ठीक है, उसको परफॉर्म करने के लिए आपको बहुत सारी चीजों की जरूरत हो सकती है. अगर हम एक सिंपल सी वेबसाइट की बात करें, ठीक है, कि एक हमारी वेबसाइट बनाई हुई है ई कॉमर्स की, सो व्हाट वी विल बी डूइंग, वी एक्चुअली नीड दी एक वेब सर्वर जहां पे कि हम अपनी एप्लीकेशन को होस्ट कर सकें, एंड that will be executing on the web server. And apart from that, we need a database which will be storing the data, right? And we need the DNS जो कि host वगैरह के लिए है, and we need the load balancers. So these kind of components we actually want. And ये सब क्या है कि अगर let's say हम खुद से बना रहे हैं, मैंने नॉर्मल सी एक वेबसाइट बनाई एंड मैं उसको अपने लैपटॉप पे रन करना चाह रहा हूँ, ठीक है. सो हम क्या करते हैं उसके लिए, जैसे मैंने डेटाबेस बनाया, तो डेटाबेस के लिए MySQL वगैरह हम इंस्टॉल कर लेते हैं, एंड फिर उसके बाद जैसे वेब सर्वर वगैरह के लिए हो गए तो लोकल होस्ट पे ही हम एक्सेस कर पाते हैं जो भी हम जिस पोर्ट पे रन करते हैं अपनी सर्विस को, एंड उस वेब पेज को, होम पेज को हम एक्सेस कर पाते हैं. एंड फिर बैकएंड में जो APIs लिखी होती हैं, इट यूज टू इंटरेक्ट विद दी डेटाबेसेस, एंड सब कुछ काम हो रहा होता है तो ये सब करने के लिए हमें क्या करना पड़ा, हमने एक अपने लैपटॉप पे सेटअप कर लिया। बट अब एक बड़ी एप्लीकेशन की बात कर सकते हैं विच इज एक्चुअली सर्विंग टू मिलियंस ऑफ कस्टमर्स, सो ऑब्वियसली उसका एक स्केल बहुत बड़ा होगा, उसको बड़े लेवल पे डिप्लॉय करना पड़ता है, जहां पे यू नीड मल्टीपल कमोडिटी हार्डवेयर्स एंड इट शुड बी लाइक अवेलेबल 24/7। आपकी चीजें अवेलेबल होनी चाहिए, कभी भी ऐसा नहीं कि हाँ किसी भी रैंडम रीजन से एप्लीकेशन बंद हो गई है और ये सारी आपके सामने ब्लॉकर्स आ रहे हैं। तो क्लाउड इन्हीं सब चीजों को रेक्टिफाई करता है एंड एक स्मूथ आपके लिए एक ऐसा प्लेटफॉर्म है जो कि इंटरनेट पे आपके लिए अवेलेबल है, जहां पे आप कभी भी आपको कुछ चाहिए कंप्यूटिंग से रिलेटेड, यू कैन गेट इट वेरी वेरी इजीली। सो दैट्स दी थिंग जो कि यहाँ पे भी मेंशन है कि आपको सर्वर्स चाहिए, चाहे वो फिजिकल वर्चुअल सर्वर्स, वी कैन जस्ट लाइक गेट इट ऑन डिमांड। हमको डेटा स्टोरेज चाहिए, कोई भी NoSQL डेटाबेस, कोई भी ट्रांजेक्शनल डेटाबेस, कोई इवन लेट्स से डिस्ट्रीब्यूटेड फाइल स्टोरेज सिस्टम, सो हमको वो भी मिल सकता है। हमको कोई नेटवर्किंग कैपेबिलिटीज चाहिए, लाइक कोई सबनेट्स वगैरह बनाने हैं, सो वो भी हमको यहाँ से मिल सकता है। तो इस तरीके की जितनी भी पॉसिबल चीजें वी कैन गेट इट फ्रॉम दी क्लाउड। एंड नाउ लाइक दी CSP क्लाउड सर्विस प्रोवाइडर्स मेक्स द रिसोर्सेज अवेलेबल फॉर अ मंथली सब्सक्रिप्शन फी और बिल्स देम अकॉर्डिंग टू यूजेस। एंड ये एक बहुत बड़ी ब्यूटी है किसी भी क्लाउड प्लेटफॉर्म की कि यहाँ पे हमको क्या करना पड़ रहा है, हमको किसी चीज का लेट से ऐसा नहीं कि लाइसेंस हमको हर साल चाहिए, हमको उसका रिन्यूअल कराना है, ठीक है। आप पूरे साल की फी पे कर रहे हो, डजेंट मैटर कि आप उसको पूरे साल में केवल 1 घंटे यूज करते हो, बट स्टिल आपको उतने पे करना ही करना है, ठीक है। तो ये एक ड्रॉबैक्स हैं जो कि हमारे ऑन प्रीमाइसेस सिस्टम्स के साथ में होते हैं, बट क्लाउड में इसी चीज की एक ब्यूटी है कि जितनी देर के लिए आप चीजों को कंज्यूम कर रहे हो उतनी देर के लिए ही आपको क्या करना है, उसकी पेमेंट करनी है। जितना आपने कंजम्पशन करा, जितना रिसोर्स ऑक्यूपाई करें, जितनी कंप्यूटेशन करी एंड जितनी देर के लिए चीजें रन हुई, बस उतने पार्ट के लिए ही आपको पेमेंट करनी है। आपको कभी इस चीज के लिए कंसर्न नहीं करना यार इतना बड़ा क्लस्टर लेना है मुझे, भले हम उसको थोड़ी देर के लिए यूज करें साल में, लेट से 2 महीने 4 महीने केवल, बट हमको पे पूरे साल के लिए करना है। तो ये एक बहुत ही बड़ा एडवांटेज है। नाउ हियर यू कैन सी इन दिस डायग्राम की क्लाउड कंप्यूटिंग आज के टाइम में अक्रॉस दी इंटरनेट हम बात करें, आप टेलीविजन वगैरह देख रहे हो, स्मार्ट टीवीज वगैरह हैं, उस पर बैठ के कुछ भी एक्सेस कर पा रहे हो रिमोट सर्वर्स पे। सेम एप्लीकेशन सर्वर्स हो गए, कोड डिप्लॉयमेंट की हो गई बात, आप यहाँ पे हो अपने किसी भी क्लाउड प्लेटफॉर्म पे कोड डिप्लॉय कर दिया एंड उसके बाद मशीन बंद एंड इट इज जस्ट गेटिंग एग्जीक्यूटेड देयर, आपको कुछ भी उसकी टेंशन नहीं है। सिमिलरली लाइक लैपटॉप, मोबाइल, PC, डेटाबेसेस सब जगह से एक्सेसिबल हैं क्लाउड प्लेटफॉर्म्स एंड इवन जो भी आप सर्विसेज यूज कर रहे हो ओवर द इंटरनेट एंड जो कि मोस्टली hosted है on the cloud platform, so you can see the visibility how this entire cloud part is working together. Now we will actually look at the very important comparison, right, with the on premises and like how this comparison actually works between the on premises and the cloud platforms, because sometimes it's a kind of debate as well. बहुत सारे enterprises हैं जो कि आज भी on premises infrastructure चीज़ों को prefer करते हैं and why, क्योंकि उनके लिए वो यूज केस ऐसा है। सो फॉर एन एग्जाम्पल कोई भी फाइनेंशियल सर्विसेज की कंपनी है, फॉर एग्जाम्पल वीज़ा, राइट। तो हमको पता है कि वीज़ा एक है कि फिनटेक के डोमेन में आता है एंड दे यूज टू हैंडल लाइक मिलियंस ऑफ ट्रांजेक्शंस एवरी डे। सो फॉर देम द डेटा प्रिवेसी एंड डेटा क्रिटिकलिटी इज वेरी वेरी इंपॉर्टेंट पार्ट एंड उस चीज को किसी भी तरीके से मैनेज करने के लिए आज भी वो क्लाउड पे मूव ना करके उन्होंने सब कुछ अपना ही बनाया हुआ है। लाइक इवन दे हैव, जैसे कि क्लाउड प्रोवाइडर्स हमारे काम करते हैं किस तरीके से, उनके अपने बड़े बड़े डेटा सेंटर्स होते हैं जहाँ पे कि वो सारी चीज़ों को और जो भी हमें इंफ्रा चाहिए या जो भी रिसोर्सेज चाहिए वो उनके पास अवेलेबल होते हैं एंड वी जस्ट लाइक हमको एक रिक्वेस्ट रेज करनी होती है एंड उसके बाद हमें वो चीज़ें अवेलेबल हो जाती हैं। सो सेम तरीके का डेटा प्लेटफॉर्म और क्लाउड प्लेटफॉर्म उन्होंने अपने पास ही बना रखा है जो कि उनके थ्रू ही मैनेज है, कोई भी थर्ड पार्टी या कोई थर्ड पार्टी क्लाउड प्रोवाइडर इन बिटवीन नहीं है। तो उनके लिए ये इंपॉर्टेंट इस वजह से हो गया क्योंकि वो किसी भी कंट्री में अगर आप ऑपरेट कर रहे हो, गवर्नमेंट की बहुत प्रोटोकॉल्स होते हैं इन टर्म्स ऑफ दी डेटा प्रिवेसी एंड ऑल। सो क्लाउड एक ऐसी चीज़ है जो कि अक्रॉस द ग्लोब अवेलेबल है, तो गवर्नमेंट्स बहुत ज़्यादा रिस्ट्रिक्शंस वहाँ पे भी पुट करते हैं कि आप नहीं क्लाउड प्लेटफॉर्म्स पे नहीं रख सकते, आपका अपना ही होस्टेड चीज़ें होनी चाहिए एंड उस स्पेसिफिक कंट्री का डेटा उसी के ही डेटा सेंटर्स में आपको लोकेट करवाना है, समथिंग लाइक दैट। सो इन दैट केसेस ऑब्वियसली दे वोंट बी गोइंग थ्रू वाया दिस क्लाउड प्लेटफॉर्म एंड ऑल। जो भी वो बनाएंगे ऑन प्रीमाइसेस के थ्रू ही उस पर कुछ रैपर्स लिखेंगे, इट विल वर्क लाइक अ क्लाउड एंड डू द डिप्लॉयमेंट, एग्जीक्यूशन, एवरीथिंग। So that's how things work in the on-premises side. So इसके भी specific use cases है, but एक definitely good comparison है between the cloud part and the on-premises. So we will look at it. So first is lower IT cost. Means cloud lets you offload some or most of the cost and effort of purchasing, installing, configuring, and managing your own on-premises infrastructure. So when we talk about the on-premises infrastructure, definitely you need to take care the things by your own, whether it is about the purchasing the machine and deciding about their configurations. And let's say something happens, you purchase your machines and after some time you realize no, this configuration is not going to work. You again need to do the purchasing for the good capacity of hardware and something like that. And these are the biggest blocker and lots of manual effort needed in between, and these things are actually costly, right? So configuration part हो गया, चीज़ों को मैनेज करने की बात हो गई, मशीन्स को परचेज करना है, या इस तरीके से जितनी भी चीज़ें हैं ऑन प्रीमाइसेस में हमको करनी पड़ती हैं, विच ऑलवेज लाइक इंक्रीजेस द कॉस्ट. जो भी आपकी एक प्रोडक्ट आप बिल्ड कर रहे हो उसकी जो भी कॉस्ट होगी इन्हीं सब चीज़ों की वजह से काफ़ी ज़्यादा इंक्रीज कर जाती है. बट वहीं पे अगर हम बात करें क्लाउड पार्ट की, सो जैसा कि आई वॉज टॉकिंग अबाउट इन द प्रीवियस पार्ट दैट इफ यू have the cloud section, then you will be paying for the time of execution or the thing which you are using for that computation. So वही चीज हेल्प करती है कॉस्ट को मिनिमाइज करने में if we are going through with the cloud solution. So that is the good part. आपको कॉन्फ़िगरेशन की कोई टेंशन नहीं लेनी है, आपको इस चीज की टेंशन नहीं लेनी है, ओ लाइक आई थिंक आई बॉट सम रॉन्ग हार्डवेयर और समथिंग लाइक दैट. And even its installation part, everything is just configurable. You just need to pick the things from the like drop down menus according to your use cases, and like within fraction of minutes it will be ready for you, whatever infrastructure you want for your product. Next is like improved agility and time to value. With cloud, your organization can start using enterprise application in minutes instead of waiting weeks or months for IT to respond to a request, purchase and configure supporting hardware, and install softwares. Cloud also lets you empower certain users, specifically developers and data scientists, to help themselves to software and support infrastructure. So agility and time to value, यहाँ पे इसका मतलब यही है कि जब आप क्लाउड का यूज कर रहे हो तो आपको अपने टाइम एंड एफर्ट्स को वेस्ट करने की नीड नहीं होती है इन दी लाइक इंफ्रास्ट्रक्चर सेटअप. ठीक है कि यार हमको इतना सारा इंफ्रास्ट्रक्चर बिल्ड करना है, वेदर इट इज अबाउट द फिजिकल सर्वर्स और इंस्टॉलिंग द इम्पॉर्टेंट सॉफ्टवेयर्स in those servers, and even the managing configuration part, everything you don't need to worry about it. You only need to spend your time for the productive things. Means the product you are building, जो उसका logic and development, let's say back end उसका part create करना, front end part create करना, whatever is the main core logic for that application, you will be working on that rather than like wasting your time on these things like building up the infrastructure, thinking about the cost, configuration, installation and everything. So that's the very very important and very very I would say meaningful point of the cloud, because आपकी चीज़ों को एंड जो आपकी टाइमलाइंस, जो आपकी डेडलाइंस होगी किसी भी प्रोडक्ट को डिलीवर करने की, यू कैन मैच इट वेरी वेरी इजीली. एंड एजाइल डेवलपमेंट की जहाँ पे हम बात कर सकते हैं कि जहाँ पे कॉन्टिन्यूअस इंटीग्रेशंस होते हैं, कॉन्टिन्यूअस डेवलपमेंट होते हैं, तो अगर हर एक स्प्रिंट में हर एक चीज़ में हम उन्हीं चीज़ों पे ज़्यादा फोकस करें, इंफ्रास्ट्रक्चर एंड ऑल, ऑब्वियसली वी विल बी इन्वेस्टिंग लेस टाइम ऑन द इंपॉर्टेंट थिंग विच इज लॉजिक डेवलपमेंट. Next is the scale more easily and cost effectively. This is again very very important part. Scalability. Scalability means the two type of scalability, vertical and the horizontal. So normal जब हम on premises की बात करते हैं, on premises systems की, so वहाँ पर mostly vertical scaling ही होती है. लाइक आपने कोई एक मशीन परचेज कर ली एंड लेट्स से उसमें अभी जो रैम है वो 16 GB है एंड धीरे धीरे लोड आपकी मशीन्स पे बढ़ रहा है. नाउ यू आर थिंकिंग दैट हाउ टू इंक्रीज इट्स कैपेसिटी सो दैट और लोड हम हैंडल कर सकें. तो हम कॉन्फ़िगरेशन चेंजेस कर सकते हैं, वो एक्सटर्नल हार्ड डिस्क में भी हो सकता है एंड रैम वगैरह लेट्स से 64 वगैरह कर दी. सो ये तरीके की स्केलिंग जब हम करते हैं सेम मशीन्स पे तो उसको कहते हैं वर्टिकल स्केलिंग. बट इसकी भी एक लिमिटेशन है. यू कैन नॉट गो बियॉन्ड सर्टेन लिमिट that okay we can scale this machine to like any infinite level. No, this is not doable with the on premises system, and here comes the cloud in picture. आपको कभी भी कुछ भी स्केल करना है अपने सिस्टम को यू कैन जस्ट डू इट इन अ फ्रैक्शन ऑफ सेकेंड्स। आपको कुछ भी नहीं करना, एक्स्ट्रा मशीन्स, एक्स्ट्रा स्टोरेज, जस्ट एक रिक्वेस्ट रेज करनी है एंड उतनी चीज़ आपको फटाफट अवेलेबल हो जाएगी, ठीक है। एंड आपके ऊपर लेट से जो एप्लीकेशन आपने बनाई है, एंड समटाइम्स व्हाट हैपेंस कि अभी तो आपका बिजनेस ग्रो कर रहा है, बट लेट से आफ्टर 50 डेज 100 डेज आपका बिजनेस इतना ज़्यादा ग्रो कर गया कि ट्रैफिक काफ़ी ज़्यादा बढ़ गया है वेबसाइट पे या एप्लीकेशन पे। तो उसको हैंडल करने के लिए आपको अपने इंफ्रास्ट्रक्चर को बड़ा करना पड़ेगा, उसको स्केल करना पड़ेगा। सो हॉरिजेंटल स्केलिंग इसी को ही बोलते हैं कि जो भी लोअर एनवायरनमेंट या इंफ्रास्ट्रक्चर है उसमें किसी भी स्पेसिफिक टाइम पे हम एक्स्ट्रा कमोडिटी हार्डवेयर या एक्स्ट्रा जो कंप्यूटेशन है उसको ऐड कर सकें एंड हमारा जितना भी एप्लीकेशन है स्मूथली एग्जीक्यूट हो सके विदाउट एनी इंटरप्शन। सो दैट इज स्केलेबिलिटी एंड इट कैन बी अचीव्ड very easily with the cloud part. So here this is a very, you can say, precise pictorial representation of the difference between the on-premises and the cloud part. So low hardware cost and high maintenance cost, right? So this is the actual part, and backup and recovery cost. So these things are involved in the on-premises की मेंटेनेंस आपको करनी है, आपको एक टीम, इंफ्रास्ट्रक्चर टीम चाहिए जो कि पूरा आपके क्लस्टर्स को, आपकी कमोडिटी हार्डवेयर्स को मेंटेन करेगी, ठीक है। तो उस पे टीम पे इन्वेस्ट करना है। सिक्योरिटी कंसर्न्स काफ़ी ज़्यादा होते हैं क्योंकि आपको बहुत एक ब्रेनस्टॉर्मिंग करनी है उस पर एंड बहुत तरीके की चीज़ें फॉलो करनी है इन ऑर्डर टू सिक्योर योर सिस्टम, ठीक है। एंड यू वॉन्ट इवन बिलीव कि बहुत सारी कंपनीज में स्पेसिफिक सिक्योरिटी टीम होती है, साइबर सिक्योरिटी टीम, एंड नॉट इवन साइबर सिक्योरिटी टीम, जो भी लाइक आईटी टीम होती है जो कि इंफ्रास्ट्रक्चर पे काम कर रही है, उसको बहुत सारा काम करना पड़ता है जब भी कोई भी डिप्लॉयमेंट होता है या कोई भी इस तरीके का क्लस्टर प्रिपेयर करते हैं ऑन प्रीमाइसेस सिस्टम पे। तो जब इस तरीके की चीज़ें होती हैं तो दैट मीन्स कि वहाँ पे हमको बहुत ज़्यादा इन्वेस्टमेंट करना पड़ता है सिक्योरिटी वाले पार्ट पे, एंड स्टिल बहुत सारे लूप होल्स रह जाते हैं जिसकी वजह से प्रॉब्लम्स आती हैं। हेयर ऑन दी क्लाउड पार्ट, जहाँ पे कि हमारी जो हार्डवेयर कॉस्ट है वो काफ़ी ज़्यादा डेफिनेटली लो होती है। आपको उतनी चीज के लिए ही पे कर रहे हैं जहां पे कि आप केवल जो चीजों को यूज कर रहे हो, आपको कोई लाइसेंस फी साल भर के लिए पे नहीं करनी है, लाइक लैक्स ऑफ मनी, यू डोंट नीड टू पे फॉर इट। एंड सिक्योरिटी पार्ट, दैट इज रियली गुड हेयर। चीजें आप लाइक सिक्योर बहुत अच्छे लेवल पे कर सकते हो। इवन दी क्लाउड सर्विस प्रोवाइडर्स दे यूज टू सेंड द रिकमेंडेशन एंड वो ऑडिट करते रहते हैं आपकी इवन एप्लीकेशंस को, एंड उनको कहीं पे लगता है कि सिक्योरिटी फ्लो है तो उनकी तरफ से रिकमेंडेशंस आते हैं एंड इंपॉर्टेंट नोटिफिकेशंस आते हैं दैट इस तरीके का आपको सिक्योरिटी इंप्लीमेंटेशन करना है। एंड सिक्योरिटी कंप्लाइंस दैट आई वाज टॉकिंग अबाउट, कि ये काफ़ी ज़्यादा इंपॉर्टेंट रोल प्ले करता है जब भी आपको सिक्योर करनी चीज़ें, चाहे वो डेटा की बात होगी, चाहे जितना भी अक्रॉस दी क्लाउड डेटा ट्रांसफ़र या जो भी पैकेट्स ट्रांसफ़र हो रहे हैं, वो क्लाउड सर्विस प्रोवाइडर्स इस तरीके से ही उसको डेवलप करते हैं अपनी सर्विसेज को कि इन बिटवीन क्लाउड ट्रांजिशन ही काफ़ी ज़्यादा सिक्योर होता है। एंड बैकअप वगैरह है, हर चीज़ जो डेटा सेंटर से, ऐसा नहीं है कि आपने जो चीज़ डिप्लॉय करी वो एक ही जगह पे अवेलेबल है, इट यूज टू गेट रेप्लिकेटेड सो दैट किसी भी टाइम पे कुछ आपको ऐसा एप्लीकेशन टर्म्स में लॉस नहीं हो सकता। So far if you are liking all the basic aspects of cloud computing, then please make sure to like this video and subscribe the channel. Now we will talk about the different categorizations of cloud. So in cloud we have actually three kind of categorization. First is SaaS, which is software as a service, then platform as a service, third is infrastructure as a service. So first we will look at the SaaS part. So SaaS, it actually means that software as a service, कि आप एक जैसे क्लाउड सर्विस प्रोवाइडर हो, यहाँ पे आपने क्या करा है, यहाँ पे एक सॉफ्टवेयर है, उसी को ही आपने एज अ सर्विस प्रोवाइड कर रहे हो किसी भी थर्ड पार्टी को या किसी भी अपने क्लाइंट को, ठीक है। तो जब इस तरीके की चीजें या इस तरीके की एप्लीकेशंस को हम डिलीवर करते हैं तो वहां पे जो क्लाउड वाला पार्ट है उनको हम SaaS इनेबल्ड थिंग्स बोलते हैं या SaaS प्लेटफॉर्म्स बोलते हैं। तो अगर टेक्निकल डेफिनेशंस की बात करें, also known as cloud-based software or cloud applications, is application software that's hosted in the cloud and that you access and use via a web browser, a dedicated desktop client or an API that integrates with your desktop or mobile operating system. तो यहाँ पे वही मतलब हो गया कि उन्होंने पूरा जो आपका सॉफ्टवेयर है, ठीक है, वो उनके क्लाउड प्लेटफॉर्म पे होस्टेड है एंड आप बस क्या कर रहे हो, आपको प्रॉब्ली एक इंटरफेस प्रोवाइड हो जाएगा, एंड लेट्स से कोई एग्जीक्यूटेबल एपीआईज हो जाएंगी जो आपको प्रोवाइड हो जाएंगी, आप सिर्फ उनको यूज कर रहे हो और वहां पे सब कुछ चीजें आपकी रन हो रही हैं एंड उस सर्विस को, उस सॉफ्टवेयर को ही आप एज अ सर्विस यूज कर पा रहे हो यूजिंग दैट इंटरफेस, जो कि प्रॉब्ली क्लाउड डेस्कटॉप के फॉर्मेट में हो सकता है या फिर कोई भी एपीआई के थ्रू आप उस चीज को एक्सेस कर सकते हो। तो सॉफ्टवेयर हमारे इसमें पास नहीं है, सॉफ्टवेयर क्या है उनका ही बनाया हुआ है क्लाउड सर्विस प्रोवाइडर्स का, वो उनके ही एंड पे होस्टेड है। दे जस्ट गिवन यू द इंटरफेस और द एक्सेस सो दैट आप उसको एज अ सर्विस यूज कर पा रहे हो। In most cases, SaaS users pay monthly or annual subscription fee. Some may offer pay as you go pricing based on your actual uses. तो सेम चीज जो हम बात कर रहे थे कि जितनी देर के लिए, जितने टाइम के लिए आप चीजों को यूज करोगे आपको सिर्फ उतना ही पे करना है। सेम गोज विद द SaaS पार्ट। SaaS is the primary delivery model for most commercial software today. There are hundreds of thousands of SaaS solutions available from the most focused industry and departmental applications to powerful enterprise software, database and AI software. तो जो हम इस तरीके की चीज़ों की बात कर रहे थे आज के टाइम में, we have lots of categorization, lots of domains, right? The AI part, ML part and the like software में we have multiple applications related to different domains. So for an example, you are someone that आपने कोई अभी एक अपना बिजनेस एक स्टार्ट करा है, ठीक है, एंड you don't have much capabilities or enough resources or enough time or money to invest on कि पूरा इंफ्रास्ट्रक्चर सही से बिल्ड करें, टीम बिल्ड करें एंड हम क्या करें कि फिर अपना प्रोडक्ट एक खुद बनाएं फिर उसको लॉन्च करें, ठीक है। आपके पास एक बिजनेस आइडिया है एंड यू जस्ट वांट टू पुट इट इनटू द मार्केट। तो उसके लिए बहुत सारे क्लाउड सर्विस प्रोवाइडर्स हैं, ठीक है, एंड इवन लाइक कंपनीज हैं जो कि इस तरीके के मॉडल्स पे काम कर रहे हैं जहाँ पे कि वो सॉफ्टवेयर बिल्ड करते हैं, एक जेनेरिक सॉफ्टवेयर बनाते हैं एंड या कह लो कि बेस्ड ऑन द क्लाइंट रिक्वायरमेंट दे यूज टू बिल्ड सॉफ्टवेयर, ठीक है, जो कि उनके एंड पे ही होस्टेड होता है। दे एक्चुअली जैसा भी एग्रीमेंट हो, क्योंकि अगर एग्रीमेंट है कि हाँ आप सॉफ्टवेयर बिल्ड करके हमें ही दे दो एंड सारा मैनेजमेंट पार्ट हम उसका खुद देखेंगे, खुद ही हम डिप्लॉय करेंगे एंड आगे की मेंटेनेंस और ये सब कुछ, तो वो आप कर सकते हो। या जहां पे कि एज अ सॉफ्टवेयर की ठीक है हमको ये सॉफ्टवेयर चाहिए, ये हमारी नीड है एंड वी जस्ट वांट टू एक्सेस इट, सब कुछ हमारे वाया ही राउट होगा, तो वो सब कुछ बिल्ड कर देते हैं सॉफ्टवेयर वगैरह एंड इट विल बी होस्टेड एट देयर एंड मेंटेनेंस, फर्दर डेवलपमेंट एंड वॉट एवर न्यू थिंग्स, जो भी मेंटेनेंस कॉन्फ़िगरेशंस के पार्ट हैं दे विल टेक केयर ऑफ इट। सो दैट्स हाउ द एक्चुअल SaaS मॉडल वर्क, कि आपने पूरा एक प्रोडक्ट एक सॉफ्टवेयर बनाया, इट इज होस्टेड एंड द पार्टी इज जस्ट यूजिंग इट। सो हेयर यू कैन सी इट, राइट। आज के टाइम में लाइक चैट एप्लीकेशंस हो गई या हमारे पास कोई भी ई-कॉमर्स एप्लीकेशंस हो गई, या कह लो कि हमारे पास जैसे वी टॉक अबाउट दी लाइक गूगल डॉक्स, सो इट इज व्हाट, इट इज एक्चुअली अ सर्विस, राइट, जो कि हमारे पास जैसे हम जीमेल वगैरह यूज करते हैं तो उसके साथ ऑब्वियसली वी कैन यूज इट। सो एक एज अ सॉफ्टवेयर ही है जो कि एज अ सर्विस हम यूज कर पा रहे हैं, वी हैव द इंटरफेस, हम जाके उसको कंज्यूम कर पा रहे हैं, हमको अपनी तरफ से कुछ उसको मेंटेन करने की जरूरत नहीं है कि हाँ पहले हमें गूगल डॉक्स इंस्टॉल करना पड़ेगा अपने सिस्टम पे, फिर कुछ भी न्यू चीजें होती हैं तो हमें ही टेक केयर करनी, नो, नथिंग लाइक दैट। नाउ वी विल टॉक अबाउट द PaaS, which is platform as a service. So what does it mean? PaaS provides software developers with on-demand platforms, hardware, complete software stack, infrastructure, or even development tools for running, developing, and managing applications without the cost, complexity, and inflexibility of maintaining that platform on premises. So platform as a service, this name actually suggests or it actually defines it meaning कि प्लेटफॉर्म को एज अ सर्विस दे देना, ठीक है। सो प्लेटफॉर्म की अगर हम बात करें, जैसे कि लेट से आपको एक सॉफ्टवेयर डेवलपर हो किसी कंपनी में, तो जब भी आप कोई प्रोडक्ट बनाओगे या कोई एक एप्लीकेशन आप बनाओगे तो आपको उसको क्रिएट करने के लिए, उसको होस्ट करने के लिए एक पर्टिकुलर प्लेटफॉर्म चाहिए, चाहे वो फिजिकल सर्वर्स हो सकते हैं या कोई भी एक आपका कस्टमाइज सॉफ्टवेयर स्टैक हो सकता है विद बिल्ड टूल्स, वॉट एवर इट इज। तो ये तरीके की चीजें जब आपको चाहिए होती हैं आपके रिक्वायरमेंट के लिए फॉर योर एप्लीकेशन एंड फॉर योर डेवलपमेंट, सो दिस इज बीइंग कॉल्ड एज अ प्लेटफॉर्म एज अ सर्विस, लाइक दैट क्लाउड सर्विस प्रोवाइडर एक्चुअली गेव यू द प्लेटफॉर्म एज अ सर्विस, कि ठीक है हम आपके लिए इंफ्रास्ट्रक्चर, हम आपके लिए लेट से सबनेट्स वगैरह या VPC वगैरह है या जो भी डेटा स्टोरेज से रिलेटेड चीजें हैं, इस तरीके की चीजें हम आपके लिए रेडी कर देंगे, आप उन पे अपना डिप्लॉयमेंट वगैरह, आप उन पे अपना जो भी एप्लीकेशंस वगैरह बना सकते हो, उनकी डेवलपमेंट स्टार्ट कर सकते हो. सो wherever this kind of use case, we call it as a platform as a service. With PaaS, the cloud provider hosts everything that I was talking about, कि चाहे वो नेटवर्क की बात हो गई, चाहे सर्वर्स की बात हो गई, स्टोरेज, ऑपरेटिंग सिस्टम्स हो गए, एंड मिडिलवेयर एंड डेटाबेसेस, जो भी इस तरीके की चीजें हो गई, वो सारी क्लाउड सर्विस प्रोवाइडर ही होस्ट करता है अपने एंड पे, एंड यू डोंट नीड टू वरी अबाउट इट. आप बस उसको यूज करते हो एंड अपनी डेवलपमेंट एंड डिप्लॉयमेंट को स्टार्ट करते हो. Developers simply pick from a menu to spin up servers and environments they need to run, build, test, deploy, maintain, update, and scale applications. So here, like on the cloud side, it is just a matter of seconds. You just pick the things which you want in terms of, let's say, servers, server configuration. You can quickly provide even for the storage, whatever you want, what kind of query engine you want. So you can just select these things and मेक इट रेडी फॉर योर सेल्फ. तो जो इस तरीके की चीजें हैं एज अ प्लेटफॉर्म, वो सब क्या कर रहा है, क्लाउड आपको ही प्रोवाइड कर रहा है, होस्टेड उनके एंड पे हैं. आप अपना कोई भी जो एप्लीकेशन डेवलपमेंट है वो उस पर स्टार्ट कर सकते हो. सो फॉर एन एग्जाम्पल, जब कोई क्लाउड प्लेटफॉर्म हमको इस तरीके की सर्विसेज देता है, लाइक ऑपरेटिंग सिस्टम ऑन अ सर्वर एंड होस्टिंग पार्ट, सिक्योरिटी मैकेनिज्म एंड सिक्योरिटी सर्विसेज, कोई इवेंट सॉफ्टवेयर एंड डेटाबेसेस एंड नेटवर्क एक्सेस, right? So this is comes under the platform as a service. So it is definitely a bit different from the software as a service, because वहां पे complete software हमको मिल रहा था. वहां पे we were even not concerned about how we gonna deploy, how we gonna create, and पूरा सॉफ्टवेयर के बारे में हमको कुछ भी नहीं सोचना था. हमको फॉर एन एग्जाम्पल एक चैट एप्लीकेशन चाहिए, वो हमने रिक्वेस्ट करी, जिस भी हम वेंडर के साथ में कनेक्टेड हैं उन्होंने वो चैट एप्लीकेशंस बनाई, सब कुछ उनके एंड पे होस्टेड है. दे जस्ट गिवन यू इंटरफेस कि हाँ आप ऐसे यूज कर लो. यहाँ पे इन्होंने क्या कर दिया, आपको प्लेटफॉर्म दे दिया. जो रिक्वायर्ड चीजें हैं एंड एग्जीक्यूटेबल थिंग्स बनाने के लिए वो इन्होंने आपको प्रोवाइड कर दी, बट यहाँ पे एक्चुअल एप्लीकेशंस पे बनाने का जो काम है वो हमको ही करना है. इसीलिए दिस इज नोन एज द प्लेटफॉर्म एज अ सर्विस. नाउ infrastructure as a service. So IaaS provides on-demand access to fundamental computing resources, physical and virtual servers, networking and storage over the internet as pay-as-you-go basis. So यहाँ पे it is kind of similar to the platform as a service, but कुछ ना कुछ differentiations जरूर हैं, जो कि आने वाली स्लाइड्स में मैं बताऊंगा कि इन तीनों में क्या ऐसे एक कोर डिफरेंसेस हैं जिससे कि हम डिफरेंस कर सकते हैं. ओके, दिस कम्स अंडर द इंफ्रास्ट्रक्चर एज अ सर्विस एंड दिस कम्स अंडर द प्लेटफॉर्म एज अ सर्विस, बिकॉज दिस PaaS पार्ट एंड द इंफ्रास्ट्रक्चर एज अ सर्विस पार्ट इज लिटिल बिट सिमिलर, बट infrastructure as a service is a like more broader concept where we actually focus on the physical side, right? Physical servers, physical storage, and like physical, you can say, machineries and hardware side, right? These kind of things will be like coming under into the infrastructure as a service part. So IaaS enables end users to scale and shrink resources as needed basis, reducing the need for high upfront capital expenditures or unnecessary on-premises or owned infrastructure, and for overbuying resources to accommodate periodic spikes in uses. So यहाँ पे infrastructure की जो बात होगी तो इसको हम इस तरीके से और बोल सकते हैं कि जब हम on-premises की बात करते थे तो वहाँ पे हमने इस चीज़ की बात करी थी कि हमको सब कुछ खुद ही लेके आना है, ठीक है? हमको मशीन जो परचेसेस करनी है, उनके कॉन्फ़िगरेशन, इंस्टॉलेशंस, इन सबको हमें ही टेक केयर करना पड़ता था, ठीक है? सो यहाँ पे जितना भी फिजिकल रिसोर्स मैनेजमेंट वाली बात होगी वो क्लाउड सर्विस प्रोवाइडर है, वो ही इस चीज़ को इनेबल करता है, एंड इट एक्चुअली हमारे जो बर्डन है उसको रिड्यूस कर देता है काफ़ी एक लिमिट तक, जहाँ पर कि हमको हार्डवेयर और फिजिकल रिसोर्सेज के बारे में इतना सोचने की नीड नहीं है. इन कंट्रास्ट टू SaaS and PaaS and even newer PaaS computing models such as containers and serverless, जैसे कि हम बात कर रहे थे कि जो containers हो गए या serverless computation services हो गई, these actually comes under the PaaS part. Infrastructure as a service provides the user with the lowest level control of computing resources in the cloud. So that is what I was talking about कि PaaS जो हो गया वो एज अ प्लेटफॉर्म हो गया कि वहां पे एक प्लेटफॉर्म उन्होंने आपको होस्ट करके एक दे दिया. दिस इज समथिंग राइट बेस्ड ऑन our analysis and based on your user requirement. This could be a platform or the required things which you need to develop your things, and you can just use it and you can just try to deploy and develop your things. बट जहां पर कि आपको और एकदम लोअर लेवल पे कि नहीं हम खुद ही सर्वर फिजिकल सर्वर्स या उनकी जितनी भी कंप्यूटेशन या कुछ भी कॉन्फ़िगरेशन रिलेटेड चीज़ें उन पे हमको कंट्रोल चाहिए. एंड उस तरीके की जब हमको सर्विस प्रोवाइड करता है कोई भी क्लाउड सर्विस प्रोवाइडर, सो वी कॉल इट एज अ इंफ्रास्ट्रक्चर एज अ सर्विस. तो यहाँ पे अगर डायग्राम में देखें तो चाहे वो स्टोरेज की बात होगी, डेटा सेंटर्स की बात होगी, शार्डेड रिसोर्सेज, फायरवॉल्स, होस्टिंग प्लेटफॉर्म्स या कुछ भी इस तरीके का चाहिए. सो यहाँ पे हम खुद देख सकते हैं कि हमें काफ़ी लोअर लेवल पे भी एक्सेसिबल चीज़ें हैं जिनको कि हम मैनेज कर सकते हैं. सो दैट एक्चुअली कम्स अंडर द इंफ्रास्ट्रक्चर एज अ सर्विस. सो it is definitely different from the like PaaS and SaaS part. Now we will look at it who manages what. So this is actually important to know. So here whatever is in the green color, that means we or the client will itself manage these things. Whatever is in the blue, that means it will be managed by the provider or the cloud service provider. So if you have like traditional IT or if you are talking about the on-premises part, so on-premises means everything is going to be taken care by you or the client or the third party itself. Whether it is the application like development, deployment, anything, data, runtime, OS, virtualization, servers, storage, networking, party will be the owner of it and they will be managing it. Now if I talk about the infrastructure as a service, so here applications like that will be taken care by the client itself, data same, and runtime, middleware, these are the important things which doesn't come under the infrastructure as a service part and will be taken care by the client itself. Now talking about the operating systems, right, virtualization, physical servers, storage, networking like creating the subnets, VPC, domains, DNS, these things. So that comes under the infrastructure as a सर्विस. एंड जहां पे कि हमको इन चीज़ों पे ज़्यादा कंट्रोल चाहिए होता है तो हम ये सारी चीज़ें वहां पे मैनेज करते हैं खुद ही. एंड और जो क्लाउड सर्विस प्रोवाइडर है वो इन सब चीज़ों को हमको एज अ सर्विस प्रोवाइड करता है एंड वी एक्चुअली गेट दी मोर कंट्रोल. हमें कंट्रोल मिल जाता है क्योंकि हम एज अ सर्विस ले रहे हैं उस इंफ्रास्ट्रक्चर को. वहां पे हमारा ऐसी कोई भी डील नहीं है कि ठीक है आप ही इस चीज़ को मैनेज करो, हम ज़्यादा उस पर कंट्रोल नहीं चाहते हैं. नॉट टॉकिंग अबाउट द प्लेटफॉर्म एज अ सर्विस. So like data part and the application obviously like it will be managed by you, क्योंकि यहाँ पे जैसा मैंने बताया था कि प्लेटफॉर्म हमको मिल गया है, अब हमको क्या करना है, डेवलपमेंट अपनी स्टार्ट करनी है एंड अपना एक्चुअल एप्लीकेशंस को क्रिएट करना है वहाँ पे. नाउ रन टाइम, वॉट एवर वुड बी द रन टाइम, मिडिलवेयर, what are the layers and the operating system, virtualization, servers, storage, networking, these things will be taken care of by the cloud service provider. So here you can see this difference, right? The runtime part and the middleware part, this is something which is like not provided by the infrastructure or not provided as the infrastructure as a service. So we can skip this serverless part. This is SaaS. It is important. So here everything you can see, right, is blue or it is actually managed by the cloud service provider. So complete software, सब कुछ उन्होंने बना दिया, आपको कोई भी टेंशन लेने की जरूरत नहीं है. Everything is like ready made for you. You just go to the market and buy the thing. Like you just enter into a shop. That shop is kind of interface, or even let's say in any e-commerce platform, you just use it. You just buy the clothes of your fitting, something like that. So सब कुछ बना बनाया है, आपको बस कंज्यूम करना है. So that comes under the SaaS प्लेटफॉर्म, जहाँ पे कि हमको नेसेसरी चीजें चाहिए डेवलपमेंट के लिए, अपनी एप्लीकेशन को डेवलप करने के लिए विद लेस कंट्रोल, नॉट ऑन दी लाइक फिजिकल साइड, that will be like under the platform as a service, but where we are more concerned toward the physical side of the infrastructure and we are using those services with more control, that comes under the infrastructure as a service. So far if you are liking all the basic aspects of cloud computing, then please make sure to like this video and subscribe the channel. Now cloud use cases, we will be talking about the use cases कि कहाँ पे हम देख सकते हैं कि हाँ एक्चुअल में क्लाउड का यूज हो रहा है. With 25% of organizations planning to move all their applications to cloud within the next year, means this is actually going on and companies are working really hard on it to move most of the things from the on-premises to the cloud part. It would seem that cloud computing use cases are limitless, and that's true. Like whatever you can imagine nowadays and you think is executable, and the component which is actually required for that product mostly will be available on the cloud side, and you can use it and you can make your product as a cloud agnostic solution. But even for cloud companies not planning a wholesale shift to the cloud, certain initiatives and cloud computing are a match made in IT heaven. That is true. Like whatever we'll be talking about the next, we actually call it as a like match made in heaven कि हाँ ये use case specifically cloud के लिए ही बना है. Anything that involves storing and processing huge volume of data at high speeds and require more storage and computing capacity than most organization can or want to purchase and deploy on premises. So जहाँ भी इस तरीके की use cases होंगे where you need high data computation techniques and like high volume storage services, so जहाँ पे भी इस तरीके के यूज केसेस होंगे क्लाउड विल कम इनटू द पिक्चर, क्योंकि ये चीजें ऐसी हैं जिनको एक ऑर्गेनाइजेशन एक लिमिट तक ही मेंटेन कर सकती है, राइट. एक बहुत मैसिव स्केल पे अगर हम इसको मेंटेन करने जाएंगे, सो इट इज गोइंग टू बी डिफिकल्ट इन टर्म्स ऑफ द मेंटेनेंस, सिक्योरिटी एंड इन टर्म्स ऑफ द कॉस्ट. सो जहां पे भी इस तरीके की यूज केस आपके सामने आ गए, डेफिनेटली वी कैन ट्राई टू pick for the cloud as an option. So the very important and most popular use case nowadays, the big data analytics, right? So big data analytics, even I am a data engineer, so I know how extensively I've been using the cloud services for any big data solution. So this is something we don't do on the on-premises side regularly. We have like amazing services provided by the different cloud providers in order to make good like big data solution for any of the use case. So अगर हम बात करें कि हमको कोई like distributed storage service चाहिए, तो cloud providers ने वो भी दे रखी हैं. अगर हमें कोई transactional database चाहिए and NoSQL database चाहिए, CSPs like the cloud service providers have these things as well. And even if we want distributed computation engine, they have well managed and curated services which is kind of wrapper with all the open source frameworks which is actually being used as a distributed computation engine. And you don't need to worry about how I'm going to install the things, because how I started in the beginning, like I was just doing whole setup on the machines, even on a very mini cluster kind of thing. I found it really challenging. But when you work on these cloud services, you actually mean your time. Whatever time you have, you mostly invest it for the actual development rather than like hustling through the setup part and the installation part. Next is the Internet of Things, like IoT. So IoT is something, let's say I have my mobile phone and whatever is being tracked, not only mobile phone or any device, right, जहाँ पे कि चीज़ों को हम कलेक्ट कर सकते हैं, जहाँ पे हम डेटा कनेक्ट कर सकते हैं, चाहे स्मार्ट टीवीज हो गए एंड स्मार्ट डिवाइसेस हो गई. सो इनमें हो क्या रहा है कि जो भी चीजें हैं वो ऑपरेट हो रही हैं क्लाउड पे ही, वो चीजें होस्टेड हैं. आपके पास क्या है, आपके पास सिंपली मशीन पे वो चीजें, लेट्स से स्मार्ट वॉच है, आप सब चीजें उस पर एक्सेस कर पा रहे हो. तो कैसे हो पा रही हैं, दैट इज बेसिकली जो सर्विसेज परफॉर्म हो रही हैं वो क्लाउड पे ही एग्जीक्यूट हो रही हैं, वहां से ही एक्सेसिबल हो रही हैं. तो इंटरनेट ऑफ द थिंग इज डेफिनेटली अ वेरी गुड यूज केस फॉर द क्लाउड पार्ट. Next is the artificial intelligence, particularly machine learning and deep learning applications. Actually, these applications are something which actually needs very high computation thing, right? Whether like the high data volume and in terms of the computation, because these algorithms are pretty complex and they work on a heavy data and they actually need a good computation power in order to process that complex model on a high volume of data. So that's why like doing these things in the on-premises part is going to be really difficult, and cloud is the best fit for the AI kind of applications. For development teams adopting agile or DevOps to streamline development, cloud offers the on-demand end user self-service that keeps operations tasks such as spinning up development and test servers from becoming development bottlenecks. So cloud जो एक यूज केस कि हम यहाँ पे बात करें कि कहाँ पे और बेस्ट फिट हो सकता है, सो क्लाउड एक ऐसी चीज होगी जो कि ये सारे बॉटलनेक्स जो हैं इनसे आपको बहुत ही दूर कर देता है। तो आप ऐसा यूज को खुद ही सोच सकते हो कि आप एक ऑर्गेनाइजेशन हो एंड आप इन सब चीजों में अपना टाइम वेस्ट नहीं करना चाहते, लाइक कि कैसे सर्वर सेटअप करना है एंड कैसे मशीन्स लेके आनी है, कैसे सब कुछ एक क्लस्टर को क्रिएट करना है, वॉट एवर इट इज। इफ यू जस्ट वॉन्ट टू गेट अवे फ्रॉम इट, दिस इज गोइंग टू बी द बेस्ट one. Like cloud is the awesome one, and I think you can even see how it is being used. These are the simple use cases, but like any of the massive platform you talk about nowadays, let's say any streaming platform or any big e-commerce application, so they are definitely running on the cloud side because they are serving to millions of customers. And if you work with the millions of customers and if you serve your things to the millions of customers, that means you probably cannot handle these things with the on premises part. You definitely need the cloud for the lower cost, for better security, for better backup, and for the best user experience with scalability. Because वहाँ पे चीज़ें जो होती हैं 24/7 अप होती ही होती हैं। हाई अवेलेबिलिटी क्लाउड सर्विस प्रोवाइडर्स हमेशा प्रोवाइड करते हैं अपनी सर्विसेज के साथ में। So here you can see in this diagram, like this is our cloud service provider and we will be getting everything, whether like the service, infrastructure, and like the platform, big data analytics, and everything like just running and evolving around the cloud. And cloud service providers are someone who is the owner of it, and they are providing all these best and super important services to run our business and to run our applications smoothly. Now we'll be talking about the cloud computing characteristics. So self-service provisioning. End user can spin up compute resources for almost any type of workload on demand. That means कि आपको किसी भी टाइम पे जो भी स्केल करनी है अपनी चीज़ों की, horizontal scalability just based on your requirement, you just need fraction of seconds to spin up your things. Like self-service, आपको जब जैसे जो भी चाहिए आप क्या कर सकते हो, वो चीज़ें ले सकते हो क्लाउड सर्विस प्रोवाइडर से। जितने टाइम के लिए आप यूज करोगे यू ओनली नीड टू पे फॉर दैट। इलास्टिसिटी, कंपनीज कैन फ्रीली स्केल अप एज अ कंप्यूटिंग नीड्स इन इंक्रीज एंड स्केल डाउन अगेन एज डिमांड डिक्रीज। कि अगर आपकी ऐसा नहीं है कि हम स्केलेबिलिटी की बात करें सो वी कैन ओनली इंक्रीज और वी कैन ओनली इंक्रीज द कैपेसिटी। व्हेन यू थिंक दैट okay, let's say for a couple of months my business would be like something like halted, or you think like there will be less interaction from the customer side on the platform. So obviously during that period you don't need the big cluster, or you don't need like lots of commodity hardwares in order to handle that scale. So if you know it, then definitely you can like reduce the cost, you can even save some cost. And how you can do it, you can just even decrease the cluster size. So that's why here elasticity, like even you can increase it, you can decrease it. So जब भी जैसी भी नीड है, अगर आपको बेस्ट कस्टमर एक्सपीरियंस देना है एंड अवेलेबिलिटी या इस तरीके की चीजें चाहिए एंड एप्लीकेशन पे लोड बहुत ज्यादा है, वी कैन स्केल इट हॉरिजॉन्टली। एंड जब आपको लगता है कि हाँ आपको इस टाइम के लिए चीज़ें मिनिमल रहेंगी एंड इम्पैक्ट उतना नहीं होगा, यू कैन लाइक जस्ट स्केल इट डाउन कि हाँ इतना मिनिमाइज कर देंगे सो दैट रेस्ट ऑफ द चीज़ों के लिए मेंटेनेंस या रेस्ट ऑफ द चीज़ों के लिए कॉस्ट हमको पे नहीं करनी है। नाउ पे पर यूज़, सो यहाँ पे जितना भी जो चीज़ें हम यूज़ करेंगे, जितनी देर के लिए यूज़ करेंगे, we only need to pay for that. We don't need to worry about heavy licensing fee or something like that. Workload resilience. Cloud service providers often implement redundant resources to ensure resilient storage and keep users' important workload running, often across multiple global regions. So that is actually very, very important, and that's how cloud service providers actually guarantees for the high availability and like zero data loss part. Because whenever you host your solution onto the cloud part, they actually try to create its multiple copies into different regions. Because let's say somehow same thing is replicated in same region and something happens with the data center which is specific to a region, all the things will be vanished, right? But if one of the replication is made into a different region, so let's say this region data center is down, they can definitely point it to that one so that your service is up and running. And same goes with the data storage part. They used to create multiple copies of it and in the different regions so that like at any particular point of time, you are not losing your important data. Migration flexibility, organization can move certain workload to or from the cloud or to different cloud platforms as desired or automatically for better cost savings or to use new services as they emerge. So migration flexibility is also very important characteristic कि आपको कभी भी कोई चीज माइग्रेट करनी है फ्रॉम वन प्लेटफॉर्म टू अनदर प्लेटफॉर्म एंड इवन वन cloud provider to another, or even let's say on premises to the cloud parts. So the access of those services is quite easy, like they have created APIs and application programming interfaces which you can actually use from your application, and things will be smoothly deployed to the cloud part. Broad network access, a user can access cloud data or upload data to the cloud from anywhere with an internet connection and using any device. So that's the important thing. It is very easily accessible. But when you talk about the on-premises, so if the public access is definitely not given, then probably you have to be in the same network of your company, and then you will be able to access those on-premises thing. Multi-tenancy and resource pooling. Multi-tenancy lets numerous customers share the same physical infrastructure of the same applications, yet still retain privacy and security over their own data. So this is really great part. I mean, when you talk about a cloud service provider, so don't think that they have one, let's say you ask for 2 or 3 servers and this is the server which is actually dedicated to you. No, it's actually not like that. So the way they are using it, like it is, the backend part is definitely quite complex, but the way they are managing it, whatever the infrastructure they have, at a time they are serving multiple users and multiple customers. Probably things will be shared, right? Let's say the infrastructure or let's say the commodity hardwares will be shared, but privacy is maintained, things are isolated, right? So let's say this piece which is being hosted or which is being owned by a customer X, so only you will be able to access it, and same goes with the Y. And although we know the infrastructure is shared here, so that's how the resource pooling and multi-tenancy work with the cloud, and it is a great way to create. Being a cloud service provider, this is the most optimized way in order to serve multiple customers with like limited infrastructures or the available infrastructures. Cloud features and characteristics which are definitely listed here: automation and orchestration, cost of management, performance monitoring, governance and compliance, security. Everything is provided by the cloud providers. So whole and soul, you can say you don't need to worry about each and every thing, whether it is the monitoring part. Okay, let's say I have the cluster in the on-premises system. I need to create some matrices so that I can keep an eye on the cluster. Okay, when it is breaching the maximum CPU utilization, so that we can look at the heavy computation processing and all. This is part performance monitoring, so we can set the alarms, and orchestration tool भी हमारे पास provided होते हैं, and बहुत सारी important services जो कि एक स्मूथ यूजर एक्सपीरियंस प्रोवाइड करते हैं एंड बहुत कुछ मेंटेन कर लेते हैं अपने ही एंड पे, जहाँ पे कि आपको अपने मैनुअल एफर्ट्स नहीं लगाने. यू जस्ट नीड टू वैल्यू योर टाइम फॉर द एक्चुअल development, and you actually need to think about your actual product idea. So far, if you're liking all the basic aspects of cloud computing, then please make sure to like this video and subscribe the channel. Now, which are the big cloud computing companies? So we will talk about this one, that nowadays what kind of cloud service providers in the market, and based on their market cap and share, which one is more popular. So here you can see this presentation. So here, based on the market cap, definitely AWS, which is actually created by the Amazon. This is most demanding one, and most of the companies are using services from the AWS. And then we have Microsoft. They have their cloud platform named as Microsoft Azure. And then they have the IBM, they have their own cloud platform like IBM Cloud. And we have the Google, who is also have built a cloud platform which is named as GCP, Google Cloud Platform. Like whatever services you need, you can even use AWS, you can use Microsoft Azure, you can use IBM, you can use Google GCP. Next 10, I mean, these are the some important like companies, somehow they have created their own cloud part, and they are also working as a cloud service providers for like certain business use cases, and like few of the companies are using them as a cloud service provider. So we have like Alibaba, Fujitsu, Entity, Oracle, and Rackspace, Salesforce, and many more. Rest of the market combine this percentage of share. So overall, we can definitely say the biggest part, which is actually acquired by the Amazon, like the AWS side, and that is the most popular one. And even for me, like it's been almost 4 years, I've been working with the AWS more closely for the big data solutions. Yep, so that was all about the cloud computing part. I hope you would have enjoyed this session, and after watching this video, at least on a higher level, you would be able to understand about the basic aspects of cloud computing. What are the different categorization, whether it is software as a service, platform as a service, infrastructure as a service, what are the characteristics, different use cases, and now you can even understand the importance of the cloud computing. So after watching this video, definitely you should actually target any of the cloud service provider and just start looking at it, how you can work on the cloud services. Nowadays it is a very important skill set required for any of the development profile. So it will definitely add a big plus in your resume and in your skill set, and it will even help you to become a good developer as well. So if you like this entire presentation for the cloud computing, then definitely like this video. And if you have any queries and any thoughts related to the cloud computing part, please put it in the comment section. We will address all the queries and comments. And if you want more content like this, then definitely make sure to subscribe the channel and press the notification icon so that you are updated with all the latest videos on this platform. So I will see you guys in the next video. Till then, just stay safe. Hey everyone, my name is Shashank Mishra and I'm working as a data engineer at Amazon. For me, it's been almost 4 years in this IT industry, and इन 4 सालों में मैं बोलूँगा कि काफ़ी कुछ सीख लिया है इन दिस डोमेन ऑफ बिग डेटा, क्योंकि जैसे मैंने अपना करियर स्टार्ट करा था 2017 में आफ्टर डूइंग माय मास्टर्स फ्रॉम NIT इलाहाबाद. आई स्टार्टेड एज अ सॉफ्टवेयर इंजीनियर इन अ सर्विस बेस्ड फर्म, एंड वहाँ पे इन चीज़ों का एक्सपोजर बहुत लेट मिला, और कॉलेज में ऑब्वियसली वॉजंट दैट मच अवेयर कि हाँ रिसेंट ट्रेंड्स क्या चल रहे हैं IT इंडस्ट्री में, इन सब का पता हो, ऐसा कुछ हुआ नहीं. So somehow I got to know about this big data domain and I actually started exploring it. And जब मुझे वो चीज़ इतनी fascinating, इतनी interesting लगी, तो I opted it as my career profile, and that's why I'm working as a data engineer. So prior to that, I have worked with companies like Paytm, McKinsey & Company, and now finally working at Amazon. So पिछले 4 साल हैं, इसमें काफ़ी कुछ सीख लिया है, चाहे वो बात हो सॉफ्टवेयर इंजीनियरिंग प्रैक्टिसेस की, चाहे वो बात हो ओपन सोर्स टेक स्टैक यूज़ करने की, चाहे वो बात हो क्लाउड रिलेटेड टेक्नोलॉजीज़ और टेक स्टैक को जानने के बारे में. सो बेस्ड ऑन दोज लर्निंग्स इसी चैनल पे इसी ही मोटिव के साथ आया हूँ, सो दैट आई कैन टॉक अबाउट दीज थिंग्स. आई विल ट्राई माई लेवल बेस्ट टू पुट सम लाइक लाइट ऑन इट, लाइक बहुत ही बेसिक लेवल से कि यार किसी चीज़ के बारे में जान सको आप लोग कि ये होती क्या है, राइट. सो जो आज का टॉपिक है वो बहुत ही ज़्यादा इंपॉर्टेंट एंड बहुत ही ज़्यादा क्रूशियल है. जब आप IT इंडस्ट्री में आप किसी भी चीज़ पे, किसी भी सॉल्यूशन पे काम कर रहे हो, यू विल हेयर दिस टर्म क्लाउड, राइट, एंड डिफरेंट क्लाउड प्रोवाइडर्स लाइक AWS, Azure, GCP. So these terms will come again and again in front of you. So in a very simple language, I will try to explain about the AWS and why someone can choose the AWS part, what are the different services available in the AWS, like just giving you the overview and with some practical examples, right. So ये आज का एजेंडा है, and after this video I can guarantee and I can assure you guys, if someone will ask you that, hey, do you know about the AWS, what are the different services, can you explain about these important services, you will be able to explain it to that person, right. So before deeping dive into the main topics or the main agenda, I would just ask you to like this video and just subscribe the channel as well, because we will keep on bringing such amazing content here. And if you have any question, if you have any query, feel free to put it in the comment section. We will definitely answer your questions as well. Okay guys, so here we are with our main topic, that is Amazon Web Services, AWS. But do you really think if I am jumping directly on the AWS without explaining the cloud part? Obviously that's not a good idea. So first what I'll do, I'll just explain you about the cloud कि क्लाउड होता क्या है, एंड हम जब कंपैरिजन करते हैं कि ऑन प्रीमाइसेस एंड क्लाउड, तो ये जो वर्ड्स मैं बात कर रहा हूँ अभी पहले उनके बारे में बात कर लेते हैं. सो व्हाट इज क्लाउड? The cloud refers to servers that are accessed over the internet and the software and databases that runs on those servers. So आज के टाइम में क्लाउड को अगर एक तरीके से समझे, एक प्रैक्टिकल और बहुत ही लेम वर्ड्स में समझने की कोशिश करें कि कोई एक ऐसी चीज़ जो एक तरीके से आपको पता नहीं है, लाइक यू डोंट नो एनीथिंग अबाउट इट, बट इट इज़ लोकेटेड एट समवेयर एंड यू आर जस्ट रनिंग योर थिंग्स लाइक अक्रॉस द इंटरनेट. सो आज के टाइम में जो इंटरनेट का टाइम है, सब कुछ आप बहुत ही ईजिली एक्सेस कर सकते हो ओवर द इंटरनेट. आपके पास एप्लीकेशंस हैं, चाहे वो एंड्रॉयड एप्लीकेशंस हों, iOS एप्लीकेशंस हों, वेब एप्लीकेशंस हों. सो वहाँ पे हो क्या रहा होता है, आप कुछ URL हिट करते हो, आपके पास कहीं से कोई रिस्पॉन्स आता है, आप कहीं से कुछ ना कुछ चीज़ एक्सेस कर रहे होते हो. सो इफ़ बहुत सिंपल वर्ड्स में बोलूँ तो जो क्लाउड है दैट इज़ लाइक योर कंप्यूट मशीन्स, योर स्टोरेज थिंग्स, वॉट एवर यू हैव, दैट इज़ जस्ट लाइक ओवर द इंटरनेट. जो कुछ जहाँ पे है वो बैक एंड में कहीं तो स्टोर हो रहा है, ठीक है. आपको फिजिकली उसको मेंटेन करने की कोई ज़रूरत नहीं है. यू डोंट नीड टू नो एनीथिंग अबाउट इट, बट इट इज़ गेटिंग स्टोर्ड समवेयर, इट इज़ गेटिंग कंप्यूटेड समवेयर एल्स, राइट. सो बहुत ही सिंपल वर्ड्स में इस तरीके से आप क्लाउड को समझ सकते हो. एंड बाय यूजिंग क्लाउड कंप्यूटिंग, यूजर्स, companies don't have to manage physical servers themselves or run computer applications on their own machines, right? So बहुत ही सिंपल सा एक्सप्लेनेशन है यहाँ पे कि जब आप क्लाउड के बारे में बात कर रहे होते हो तो आपके पास कोई भी आप बिजनेस रन कर रहे हो, आपने कोई एक प्रोडक्ट बनाया हुआ है, तो आपके पास दो ऑप्शंस होंगे. या तो आप उसके लिए जितनी भी चीज़ें हैं वो खुद से ही सेटअप करोगे. जैसे आपको कुछ एक बनाना है, आपको कोई एक सॉफ्टवेयर बनाना है, एक आपको वेब एप्लीकेशन बनानी, तो ऑब्वियसली आपको एक मशीन चाहिए, एक लैपटॉप, एक कंप्यूटर, कुछ तो चाहिए जहाँ पे आप कोड कर सको, जहाँ पे आप कुछ डिप्लॉय कर सको, जहाँ पे आपकी एप्लीकेशन रन कर रही होगी. यू नीड समथिंग लाइक दैट. बट in the case of cloud, you are not someone who is going to maintain these things. So instead of you, there will be someone. So यहाँ पे हम बात करें तो वो cloud providers होंगे. They are just providing you those infrastructure related things as a service, right? है सब कुछ उस तरीके से फिजिकली ही उनके पास भी अवेलेबल है, बट उन्होंने उसको इस तरीके से डिज़ाइन कर रखा है कि वो स्केलेबल होती हैं चीज़ें, अक्रॉस द इंटरनेट एक्सेसिबल होती हैं, ठीक है. तो ये सारी चीज़ें क्लाउड के साथ होती हैं कि आपको मेंटेन उसको कुछ भी नहीं करना. फिजिकल जितना भी काम है वो सब कुछ स्किप हो जाता है. यू जस्ट नीड टू पे what you are using. The cloud enables users to access the same files and applications from almost any device because the computing and storage takes place on servers in a data center instead of locally on the user device. So जो इस पॉइंट का एक्सप्लेनेशन है वो ये है कि आपने कुछ डेटा है आपके पास कुछ फाइल्स हैं, कुछ वीडियोज़ हैं लेट्स से, ठीक है, और वो आपने कहीं पे स्टोर कर रखे हैं, ठीक है. फॉर एग्जांपल आप अपने लैपटॉप पे ही डाल रखा है, समहाउ आपके लैपटॉप की हार्ड डिस्क क्रैश होगी, आप वो सारी चीज़ें खो दोगे, राइट. सो दैट हैपन्स इफ समथिंग गेट्स फेल, यू आर लूजिंग योर थिंग्स, बट दिस थिंग्स डजंट हैपन ऑन द क्लाउड साइड. एंड आज के टाइम में बहुत ही सिंपल से एग्जाम्पल में वर्ड्स में अगर हम बोलें इस चीज़ को, लेट्स से यू हैव योर मोबाइल फोन and what happens, let's say it just got broken. So obviously, like whatever you had in your mobile, let's say your photographs, videos, and whatever was stored in the locally, you will lose those things. But let's say talk about the WhatsApp, talking about the Instagram. As soon as you buy a new phone and you just create account there, you are able to get that data, your previous chats, right, your like messages, your pictures or videos, whatever you uploaded there or whatever you send to other people, right, you are able to take that backup. And how that thing is happening, because these things are running over the cloud. Those things, whatever just getting transferred from one device to another device across the internet, they were getting stored on the cloud storage, cloud servers. So whatever computation, whatever storage is happening, that is on the cloud side. तो यही होता है क्लाउड के साथ में. Now we will see what is the difference between the on premises and cloud, right? तो on premises के बारे में अगर मैं बहुत ही नॉर्मल वर्ड्स में बताना चाहूँ तो ऑन प्रीमाइसेस कोई ऐसी चीज़ जिसकी ओनरशिप पूरी आपकी होती है, राइट? चाहे आप मेंटेन कर रहे हो उन चीज़ों को, ठीक है, या जो भी आप कह लो कि उसके मेंटेनेंस से, डिप्लॉयमेंट से लेने से स्केलेबिलिटी, परचेज, बाय, सिक्योरिटी, जो कुछ भी है वो सारी चीज़ें आप मैनेज कर रहे हो। अगर ऐसी चीज़ है दैट मीन्स कि वो ऑन प्रीमाइसेस है, यू ओन इट। बट इन द केस ऑफ क्लाउड, there is a cloud provider who is owning the things, but you are just using it as a service and you are paying for it. So अब हम थोड़ा देखते हैं कि अगर हमारे पास ऑन प्रीमाइसेस चीज़ें थी, क्योंकि अगर लेट से मुझे कोई चीज़ डेवलप करनी है, कोई चीज़ मुझे बनानी है, तो ऑब्वियसली मैं क्या कर सकता हूँ कि मैं 4-6 सर्वर्स लेके आ सकता हूँ, खरीद सकता हूँ और उन पे मैं अपनी चीज़ों को बिल्ड कर सकता हूँ। लेट्स से आई हैव अ क्लस्टर ऑफ नोड्स और क्लस्टर ऑफ सर्वर्स, and whatever application I'm building, I can just deploy it there, and it can be accessible by anyone. But there are multiple factors, right, between the on-premises and the cloud, and we will talk about those important differences which actually help cloud to become that kind of popular thing, right, in the market. So that is the whole point about the difference between on-premises and cloud. So first thing is scalability. This is the very, very important point when you talk about the kind of products or kind of application where lots of requests are coming in a fraction of seconds. For an example, any e-commerce platform, right? Even like a ticket booking kind of system, IaaS etc. So there, even in a like fraction of seconds, there will be n number of users who are making their transactions, logging or doing something. So nowadays scalability plays a very, very important role because you need to handle that massive amount of requests, massive amount of transactions. For the scalability part, it should be like as soon as your system feels that load is quite high, or at a specific time it feels the number of requests, they are very large, and it cannot be handled with some specific number of servers. So there should be kind of auto scaling thing that it is just like scaling itself, right? So, but in case of on premises, what will happen, since you had that requirement earlier that now you are going to start your business, and it's just for like 4 or 5 months for you, you were not that sure that you will be able to handle that amount of customer, or you will be able to get that number of customers, but somehow you just boomed, your business just boomed and you started getting like n number of customers there. So in that case, what will happen, your system will get crashed. Definitely those specific number of servers which you actually bought and you just deployed your things, you whatever you created there, so that kind of on-premises cluster or that kind of on-premises system won't be able to handle that kind of a scale. So in terms of scalability, cloud is just awesome, right? You don't need to worry about it at all. Just select the like important services what you want, and you have the options of auto scaling, and like you will be safe at any particular point of time. Your system is not going to crash. Second is the security. So on premises, like traditional on premises seems more secure as it is in-house. Obviously if you have something and you have the complete ownership, तो वो पूरा secure होगा ही होगा, आपने कोई चीज़ अपने पास रखी हुई है. But if you talk about the cloud part, right, so obviously there is you, जो कि आप एक let's say एक organization हो, and I am a cloud provider. So in between whatever is getting used, whatever we have, definitely वहाँ पे थर्ड पार्टी ओनरशिप का कंसर्न हमेशा ही होगा कि जो क्लाउड प्रोवाइडर है, ऑल दो दे हैव ऑल द सिक्योरिटी इम्प्लीमेंटेड, वी हैव अ एग्रीमेंट अबाउट द डेटा एंड वॉट एवर इट इज़, बट स्टिल आपको एक बैक ऑफ द हेड ये चीज़ रहेगी कि हाँ उनको तो पता ही है, उनके अगर सिस्टम जो अगर वो मुझे सर्विस दे रहे हैं उनकी ही चीज़ों पे मैं चीज़ों को डिप्लॉय कर रहा हूँ या कोई डेटा ट्रांसफ़र कर रहा हूँ, तो उनको तो पता ही है, राइट? बट द ऑर्गेनाइजेशन एंड the company, they have a proper agreement in between, and like things work legally here, right? And if we talk about the on-premises side, and again like one more additional point, when you like create your things on the cloud, they have a very, very awesome like security mechanism there you can implement, and whether it is talking about the डेटा इंक्रिप्शन और जो भी ट्रांसमिशन ओवर द इंटरनेट हो रहा है वो बहुत ही सिक्योर होता है, कनेक्शन, कनेक्टिविटी, ऑथेंटिकेशन, सो एवरीथिंग इज विल बी प्योरली सिक्योर्ड, एंड इवन you will get those kind of notifications like best practices which you should implement, best suggestion from the provider itself that you have built this solution and you need to implement this kind of security. So that kind of security mechanism will be there so that you can secure your system as much as, right? And if I talk about the on premises, so security is important thing. You will feel secure because it is in house, you have the ownership, but there can be any number of attacks which can be done on your like machines, whatever you are using, so that can be hacked for sure. So in order to secure it, you need to take different measurement, you need to implement some important and necessary security implementations, right? Sometimes obviously you need a dedicated team, cyber security team for your organization to manage and maintain those things, and obviously it will be extra cost for the company and extra maintenance part. And third is the cost, which is like actually a very very big factor. That's why most of the companies are moving from the on premises thing to the cloud, right? The cost. So in the on premises part, when you purchase something, obviously those machines are costly, you need to like pay for the memory, for the CPUs, RAM, and whatever you are buying, right? So you need to pay for everything, like in terms of the managing the team, hiring the admins, and hiring the DevOps team who will take care of all these things, security team, and there are a lot of costing factors involved if you talk about the on premises part. But when we talk about the cloud, so it is definitely very very smooth and very very effective in terms of the cost. So the fundamental thumb rule they used to follow is you just need to pay what you are using. Apart from that, you don't need to worry about anything that extra cost will be there for the maintenance, blah blah, etc. No, nothing like that. Whatever you are using, just pay for that, and that's why it is very very cost effective. Now we will talk about the AWS, because there was enough talk about the cloud, difference between on premises and the cloud part, why cloud is actually booming nowadays. So Amazon Web Services is the world's leading cloud computing service provider. So as I already talked about, whenever there will be a new thing coming into the market or there will be a new innovation, definitely there will be you can say competitors who will be coming up with the solutions. So when there was a need of this cloud part, right, shifting things from the on-premises to cloud kind of architecture, there were other competitors including the Microsoft, including the Google, including the Alibaba, right? So these are the cloud service providers, right? So these different companies has created their own cloud solutions and they are providing those things as a service. So Amazon also created their one cloud architecture part or the cloud kind of services named as AWS, Amazon Web Services. And nowadays definitely based on the market cap, it has like grown a lot. The kind of revenue they are generating, Amazon actually the most of the part of Amazon's revenue that is related to AWS, because they are providing it as a service and like n number of companies are using it and paying the bills in the like figures of millions, right? So you can understand the kind of revenue Amazon is generating via the AWS part. So back in 2004, Amazon launched simple queue service like SQS as the first building block that would become AWS. So that was the very first service they launched, and SQS, I will talk about this service, like what it is actually in the later part. But here just for the highlight, this was the first service which Amazon created and it just gave a birth to the AWS side. And after that, like 2 years later, they released another amazing services like the storage. This is very very awesome, and their seminal cloud service storage solution and cloud compute service as well, which is named as EC2. So these were the things like which were actually needed at that particular point of time. The computation part, obviously for the compute thing, you need the machines, you need different configurations machine. So that was the necessary service they brought in, and after that the storage part as well. So these were the things which they launched into the 2006, and after that I don't think so कि उन्होंने पीछे मुड़ के कभी भी देखा. And like in 2021 अभी तक जो भी उन्होंने improvements and innovations करे हैं in the field of cloud, दैट इज़ कमेंडेबल. बहुत सारी सर्विसेज लाइक हर एक डोमेन से रिलेटेड. इट इज़ नॉट लाइक कि किसी एक स्पेसिफिक डोमेन से रिलेटेड उन्होंने सर्विसेज बनाई हैं. इफ़ यू टॉक अबाउट दी वेब एप्स, उनके पास सर्विसेज हैं. इफ़ यू टॉक अबाउट दी IoT, दे हैव सर्विसेज. इफ़ यू टॉक अबाउट दी डेटा एनालिटिक्स, मशीन लर्निंग, they have services. We talk about the networking, access, everything. They have a service for each and everything which you can use to build your own things. And that's how like Amazon has grown so far. Now we will talk about you can see here this picture actually explain the kind of high level services they are providing, like servers, networking part, storage, even computing, mobile, email, security, mobile development related. So all the services they have, and they have created these things, and this is really amazing. Like I have worked like really closely with AWS. I have used these kind of services, so I can actually feel if you haven't used it, प्रॉब्ली अभी आपको उतना समझ नहीं आ रहा होगा कि यार क्लाउड का एक्चुअली फ़ायदा क्या है. बट जब आप एक्चुअली एक सोल्यूशन बिल्ड करोगे क्लाउड पे, क्लाउड नेटिव सोल्यूशन बनाने के लिए, देन यू विल एक्चुअली गेट दैट फील कि हाँ यार कितनी ही अमेजिंग चीज़ बनाई है इन कंपनीज इन दी टर्म ऑफ क्लाउड आर्किटेक्चर और इन दी जस्ट वर्ल्ड ऑफ क्लाउड. सो नेक्स्ट वुड बी वाई टू चूज़ AWS. अगर हमारे पास डिफरेंट बहुत सारे क्लाउड प्रोवाइडर्स हैं, तो हम एक कैसे बेंचमार्किंग सेट करते हैं दैट ओके वी शुड गो फॉर द AWS. So obviously there will be n number of factors involved, whether it is talking about the cost, security, maintenance, upgrade, and multiple n number of factors. But I will just talk about based on their like very important things they are following, or the important things they are giving to the market. So AWS is best known and most widely used cloud service platform on the market, which is actually true. You can just do some research and knowing about the kind of companies which are using the AWS as a cloud provider, and even the kind of bills or the kind of revenue AWS is generating. So based on that market cap, these are just stats which we actually came with. So a core AWS principle is security is job zero, and true to that, they provide all the tools you need to manage your estate no matter how big you scale. So here the main thing which we were actually talking in the previous point, like the comparison with on-premises versus cloud. So the important points was like scalability and the cost part and the security part. So Amazon itself like is providing those things on a very big scale. So आपके लिए कभी भी ये चीज़ मैटर नहीं करेगी. आपको इवन इसके लिए कभी भी कोई कंसर्न नहीं होगा कि अगर मैंने कोई सॉल्यूशन या कोई सर्विस एक परचेज करी हुई है AWS साइट से, कोई अपना सॉल्यूशन बनाया है, तो कोई ऐसा पॉइंट तो नहीं आएगा कि मेरा सॉल्यूशन वहाँ पे फेल हो जाएगा जस्ट बिकॉज ऑफ द अनअवेलेबिलिटी ऑफ द रिसोर्सेज. सो दे टेक केयर ऑफ ऑल दीज थिंग्स. इवन यू कैन सी इन दिस पॉइंट लाइक दिस कपल्ड विद कॉस्ट मैनेजमेंट सोल्यूशन. लाइक ऐसा नहीं है कि हाँ हम एक क्लाउड प्रोवाइडर हैं और हमने आपको एक बस सर्विस अपनी दे दी, उसके बाद हमारी कोई रिस्पॉन्सिबिलिटी नहीं होगी. सो बीइंग अ प्रोवाइडर दे ऑल्सो ट्राई टू गिव यू द बेस्ट एक्सपीरियंस. एंड आपको वो एक्सपीरियंस अच्छे कब मिलते हैं, जब आपको एक रेलिवेंट कॉस्ट ली जा रही हो आपसे. आप जो भी प्रोसेस कर रहे हो, जो कुछ भी चीज़ें वहाँ पे डिप्लॉय और बिल्ड कर रहे हो, उसकी एक रेलिवेंट कॉस्ट हो. तो यहाँ पे जो AWS है वो इस तरीके से अच्छा एक कस्टमर एक्सपीरियंस बिल्ड करता है. लाइक दे यूज टू प्रोवाइड दी कॉस्ट ऑप्टिमाइजेशन सॉल्यूशंस एज वेल टू दी ऑर्गेनाइजेशन कि आप कैसे और कॉस्ट को ऑप्टिमाइज कर सकते हो. and offerings which help provide recommendations to secure and optimize your infrastructure. That was why I was talking about कि जब बात सिक्योरिटी की होती है तो वहाँ पर भी ये लोग बहुत अच्छे रिकमेंडेशंस देते हैं इन टर्म्स ऑफ मेकिंग योर इंफ्रास्ट्रक्चर, मेकिंग योर एप्लीकेशन सिक्योर, सो दैट आपकी एप्लीकेशन को, आपके सिस्टम को किसी भी तरीके का हार्म ना हो पाए कभी भी, एंड अलाउ यू टू डिलीवर फास्टर, सेफर एंड चीपर देन इज़ पॉसिबल विद योर ऑन प्रीमाइसेस इंफ्रास्ट्रक्चर। एंड डेफिनेटली ये सारी चीज़ें एक ऑन प्रीमाइसेस सिस्टम के साथ में अचीव करना पॉसिबल नहीं है, चेक, क्योंकि अगर स्केलेबिलिटी की बात आती है तो आप को वेट करना पड़ेगा कि हाँ नए मशीन्स हम लेके आएंगे, वो सिस्टम में लगाएंगे, हमको इतने दिन का डाउन टाइम चाहिए और उसके बाद हमारी सर्विसेज अप हो पाएंगी। सो ऑन प्रीमाइसेस वाली चीज़ों के साथ में ये सब चीज़ें मैनेज कर पाना लाइक इन कंपैरिजन इज क्लाउड नॉट दैट इजी। इसीलिए आज के टाइम में AWS बहुत ज़्यादा पॉपुलर है बेस्ड ऑन द स्टैट्स, बेस्ड ऑन द रिसर्च, the kind of services they have created, the kind of best user experience they are giving and the best cost they are taking. So ये सारे important factors हैं जिसकी वजह से AWS काफ़ी ज़्यादा popular है। Okay guys, so far if you are liking this content and whatever I have talked about the AWS part, if you are enjoying it, then make sure to like this video because that is needed, that is work as a motivation for me. And if you are new to the channel, then make sure to subscribe and press the notification icon as well. Now just we will look at this important point, like what are the big companies who are using AWS as their cloud provider. सो यहाँ पे आप देख सकते हैं कि लाइक नेटफ्लिक्स, ट्विच, लिंक्डइन, फेसबुक, BBC, ट्विटर, इनके जो मंथली बिल्स हैं ये सिर्फ एक सर्विस के लिए हैं, EC2, जो कि उनकी कंप्यूट सर्विस का यूज़ कर रहे हैं, ठीक है। मंथली उसके लिए इतना बिल पे करते हैं। एंड इतना बिल क्यों बन रहा है? क्योंकि यार इनका स्केल इतना बड़ा है जहाँ पे मिलियंस में कस्टमर्स हैं और हर सेकंड इतनी ज़्यादा एक्टिविटीज़ हो रही हैं और उस लोड को हैंडल करने के लिए, उन चीज़ों को कंप्यूट करने के लिए डेफिनेटली यू नीड दोज काइंड ऑफ कमोडिटी हार्डवेयर लाइक द कंप्यूट मशीन्स। एंड आफ्टर दैट लाइक वो और भी सर्विसेज यूज़ कर रहे हैं। सो दैट्स हाउ यू कैन सी कि किस तरीके से AWS हैज़ ग्रोन सो फार। So now we will start talking about the important services which are available in the AWS side. So I have just categorized these services and within like those categories there are couple of important services. जब आप बहुत डीप टाइप करोगे AWS में, सेल्फ एक्सप्लोरेशन भी करोगे, सो हर एक कैटेगरी में आपको बहुत इंपॉर्टेंट भी सर्विसेज मिलेंगी एंड कुछ ऐसे सर्विसेज भी मिलेंगी जो शायद आपके यूज़ के लिए ना हो। तो इस वीडियो में जो हमारा मेन टॉपिक है बेस्ड ऑन बेस्ट प्रैक्टिसेस और कह लो कि एक जेनेरिक एक प्रोडक्ट बनाने में या जेनेरिक आर्किटेक्चर बनाने में, जेनेरिक एप्लीकेशन बनाने में जो इंपॉर्टेंट सर्विसेज यूज़ हो सकती हैं उनके बारे में ही हम बात करेंगे यहाँ पे। सो पहली है लाइक अगेन AWS कंप्यूट सर्विस विच इज़ EC2. So EC2 is a cloud platform provided by Amazon that offers secure and resizable compute capacity. Its purpose is to enable easy access and usability to developers for web-scale cloud computing while allowing for total controls of your compute resources. So अगर बहुत ही सिंपल वर्ड्स में इसको समझाने की कोशिश करूँ तो कि आप आज एक वेब एप्लीकेशन बनाना चाहते हो, ठीक है, तो डेफिनेटली आप उसको कहीं ना कहीं पे होस्ट करोगे, उसमें बैकएंड में जितनी भी प्रोसेसिंग हो रही होगी तो वो प्रोसेसिंग होने के लिए उसको एक कंप्यूट पावर चाहिए, दैट मीन्स कुछ रैम चाहिए, कुछ CPU चाहिए, ठीक है। तो एक केवल मशीन की बात होगी, ठीक है। जब हम यहाँ पर बात करते हैं कि बहुत बड़े स्केल की मशीन चाहिए हो सकती है जहाँ पे कि हमें हेवी कंप्यूटेशन वगैरह करनी होती है, ठीक है, तो आपके पास वो फ्लेक्सिबिलिटी भी होनी चाहिए कि यार हाँ हम फटाफट से अपनी जो एक कॉन्फ़िगरेशन है मशीन की वो चेंज करके तुरंत किसी दूसरे एक बड़े स्केल की मशीन में उसको कन्वर्ट कर लें। अगर प्रैक्टिकली ये चीज़ हम ऑन प्रीमाइसेस की बात करें, अगर आप एक ऐसी सर्वर और एक ऐसी मशीन लेके आए हो जिसमें लेट से 1 TB की हार्ड डिस्क है आपकी और कुछ लेट से 16 GB समथिंग रैम है, ठीक है, और कोई एक तरीके का प्रोसेसर लगा हुआ है उसमें, बट अब आपको तुरंत है कि यार अब जो मैं सोल्यूशन बना रहा हूँ, अब जब इस पर कंप्यूट होगा, इतनी मेमोरी, इतनी रैम, ये सब तो सफिशिएंट नहीं है, अब क्या करना पड़ेगा, अभी जाना पड़ेगा मुझे मार्केट, अब दूसरी मशीन लेके आएंगे क्या? ऐसा नहीं होता है। तो जब कंप्यूट कैपेसिटी की बात नहीं होती है तो क्लाउड प्लेज एन वेरी वेरी इंपॉर्टेंट रोल देयर। सो जस्ट ट्रीट इट लाइक अ कॉमोडिटी हार्डवेयर जो कि डिफरेंट कॉन्फ़िगरेशंस के प्रोवाइड कर सकता है AWS आपको एट एनी स्पेसिफिक पॉइंट ऑफ टाइम। आपको वहाँ पे ये नहीं है कि अगर मैं किसी एक कॉन्फ़िगरेशन से दूसरे कॉन्फ़िगरेशन पे मूव कर रहा हूँ तो बहुत ही ज़्यादा ब्लंडर हो जाएगा, सर्विसेज सब स्टॉप हो जाएंगी, क्या हो जाएगा, ऐसा कुछ भी नहीं। ईजी होता है, बहुत सिक्योर्ड होता है जो भी आप कंप्यूटेशन यहाँ पे कर रहे हो, रीसाइजेबल बहुत ही बड़ा इंपॉर्टेंट फैक्टर होता है, एंड इन टर्म्स ऑफ द स्केलेबिलिटी डेफिनेटली आपको लेट्स से आपने कोई बड़ा क्लस्टर बनाया, आप स्केलेबल सोल्यूशन बना रहे थे, आपने वहाँ पे केवल 100 लेट्स से कॉमोडिटी हार्डवेयर्स और 100 EC2 इंस्टेंसेस यूज़ करें, आप फटाक से क्या कर सकते हो और EC2 इंस्टेंसेस को परचेज कर सकते हो, वहीं पे ही आप ऐड कर सकते हो। आपका बस जो कंप्यूटेशन हो रही है आपको उसी के लिए ही बिल पे करना है, जितनी देर के लिए आपका जो सर्वर था वो एग्जीक्यूशन मोड में था आपको उसी के लिए पे करना है। बट जब ऑन प्रेमाइसेस की बात होती है तो हमने एक ही बार में सारे पैसे दे दिए, ठीक है, और उसके बाद फिर हमारा कोई कंट्रोल नहीं है उस पर, क्योंकि हम कभी भी उसको स्केल नहीं कर सकते जब भी हमको फ्रिक्वेंटली और बहुत इंस्टेंटली उसकी नीड है। सो दैट इज ऑल अबाउट दी EC2 सर्विस। नाउ डेटाबेस रिलेटेड सर्विसेज, अब हम इसके बारे में बात करेंगे। सो MySQL के बारे में सबको पता है कि MySQL क्या होता है, डेटाबेस होता है जिसमें कि हम टेबल्स को स्टोर करते हैं, डेटा को एक्सेस करते हैं। सो इट इज़ काइंड ऑफ ट्रांजैक्शनल डेटाबेस, राइट। सो ये तो बात होगी ओपन सोर्स साइड की, ठीक है, कि अगर आपको MySQL यूज़ करना है तो आप क्या करोगे, आपने जो भी आपका सिस्टम बनाया हुआ है, ठीक है, उसमें आप MySQL को इंस्टॉल करोगे एंड फिर टेबल्स वगैरह क्रिएट करना एंड जो भी पर्पस है आप उसको सर्व करोगे, वहाँ पे आप यूज़ करोगे MySQL को। So this is the one part talking about the open source side or using about the open source side or kind of database services. But when we talk about the scalability, then it is very hard to achieve. Like जब आप ये इस तरीके की open source चीज़ें यूज़ कर रहे हो, ठीक है, आप एक बड़े स्केल पे करनी है, so like वो database services को ही स्केल कर पाना एक बड़े लेवल पे हार्ड होता है, ठीक है, काफ़ी ज़्यादा हार्ड है वो। सो सेम चीज़ एक अच्छा कंफर्ट प्रोवाइड करने के लिए फॉर डेवलपर्स, जब भी हम एक कोई एप्लीकेशन वगैरह बिल्ड कर रहे हैं तो ऑब्वियसली वी नीड दी डेटाबेसेस। सो अमेजोन क्या करता है कि वो ये सर्विसेज भी प्रोवाइड करता है, लाइक डेटाबेस एज अ सर्विस, ठीक है, जो कि काफ़ी ज़्यादा एफिशिएंट होती हैं। सो RDS एक ऐसी सर्विस है, जस्ट लाइक ट्रीट इट लाइक अ रेप्लिका ऑफ MySQL, ठीक है, कि जो ट्रांजैक्शनल डेटाबेस हम एज अ ओपन सोर्स यूज़ करते हैं, फॉर एग्जांपल MySQL, पोस्टग्रेस, SQL सर्वर, ओरेकल डेटाबेस, इस तरीके की चीज़ें यूज़ करते हैं। सो वो ही सर्विस हमको प्रोवाइड कर रहा है RDS, लाइक अमेजॉन रिलेशनल डेटाबेस सर्विस, ठीक है। सो RDS इज अवेलेबल ऑन वेरियस डेटाबेस इंस्टेंसेस, की जब आप डेटाबेसेस की बात करते हो तो वहाँ पे क्या होता है कि हमारे पास यार पोस्टग्रेस भी है, MySQL भी है एंड हमारे पास SQL सर्वर भी है। सो ये क्या है, डेटाबेस इंजन्स हैं। सो अमेजॉन जो है वो जो ये RDS सर्विस है, यू कैन कॉन्फ़िगर इट बेस्ड ऑन एनी लाइक डेटाबेस इंजन। सो चाहे आपको अगर लाइक पोस्टग्रेस यूज़ करना है, आप वो वाला इंजन सेलेक्ट कर सकते हो और आपका जो डेटाबेस है उसके अकॉर्डिंग क्रिएट हो जाएगा एंड आप उसके बाद जैसे नॉर्मल MySQL वगैरह यूज़ करते थे वैसे ही आप इसको यूज़ कर सकते हो। And by leveraging the AWS database migration service, you can easily migrate or reproduce your existing database to Amazon RDS. तो अगर आपके पास कोई एक डेटाबेस था तो obviously आपको माइग्रेट करना है, लेट्स से अगर MySQL पे वहाँ सब कुछ आपका स्टोर था एंड आपको क्लाउड पे मूव करना है, सो वो ट्रांसमिशन और वो जो माइग्रेशन होता है वो भी बहुत ईजी और स्मूथ होता है कि आप डेटा वहाँ से ला के अपने क्लाउड जो इंस्टेंस है डेटाबेस का वहाँ पे स्टोर कर सकते हो। नाउ AWS रेडशिफ्ट, सो जो रेडशिफ्ट है ये भी एक तरीके से आप कह सकते हो कि काइंड ऑफ डेटाबेस सर्विस है, जो कि आपके सेमी स्ट्रक्चर डेटा हो गया एंड जो स्ट्रक्चर डेटा हो गया लाइक टेबुलर फॉर्म, रो एंड कॉलम्स के फॉर्म में, उसको हैंडल करता है। बट जो मेन पर्पस है इसका वो यूज़ होता है एनालिटिकल क्वेरीज के लिए। जब हम बात करते हैं बिग डेटा एंड कि आपको बहुत ही हैवी, जहाँ पे आपके पास टेराबाइट्स में डेटा होता है, एक एक टेबल आपकी टेराबाइट्स का डेटा स्टोर कर रही होती है। सो ऑब्वियसली ऐसे डेटा सेट्स पे हम करते हैं कि हमेशा एनालिटिकल क्वेरीज रन करते हैं, ठीक है। तो जो RDS या ट्रांजैक्शनल काइंड के डेटा बेसेस होते हैं, जो हमने बात करी AWS RDS या हम MySQL की बात कर रहे हैं, वो ट्रांजैक्शनल डेटा बेसेस हैं। ये ऐसे सिस्टम्स में यूज़ होते हैं जहाँ पे कि एसिड प्रॉपर्टीज़ फॉलो होनी चाहिए, ठीक है, कि हाँ ट्रांजैक्शंस बहुत ही क्रूशल हैं, हम इन द मिडिल स्टक नहीं हो सकते, ट्रांजैक्शन पूरा कंप्लीट होना चाहिए या रोल बैक होना चाहिए, ठीक है। तो इस तरीके की जो एसिड प्रॉपर्टीज़ हैं या जहाँ पे इंसर्ट बहुत ही फ्रीक्वेंट होते हैं, जहाँ पे अपडेट्स बहुत फ्रीक्वेंट होते हैं, डिलीट बहुत फ्रीक्वेंट्स होते हैं, और स्केल उतना बड़ा नहीं ट्रांजैक्शनल डेटा बेसिस का कि अगर आज कुछ होता जा रहा है जो स्टोर हो गया उसके बाद आप उसको प्रीवियस हिस्ट्री में कहीं भी रख सकते हो, यू कैन यूज़ इट। बट अगर सिस्टम पे आपके पास एक एक वेब एप्लीकेशन है, वहाँ से अगर कोई कस्टमर लॉगिन है, कुछ परचेज, कुछ भी ट्रांजैक्शन कर रहा है, तो वो तो रियल टाइम में कैप्चर होगा, ठीक है। सो उसके लिए हमारे पास इस तरीके की RDS काइंड ऑफ सर्विसेज हैं। बट वी टॉक अबाउट सच वेरी लाइक ह्यूज अमाउंट ऑफ डेटा, तो वहाँ पे हमारे पास AWS रेडशिफ्ट है जो कि बहुत ही ज़्यादा स्केलेबल है एंड बेस्ट डेटाबेस सर्विस है, जहाँ पे हम बात करें कि हमें बहुत ही ह्यूज अमाउंट ऑफ डेटा को प्रोसेस करना है और बहुत ही ह्यूज अमाउंट ऑफ डेटा पे एनालिटिकल क्वेरीज रन करनी है। सो इसको एक तरीके से देखा जाए तो हम प्योर डेटाबेस सर्विस नहीं बोलेंगे, इसको हम बोलेंगे डेटा वेयर हाउसिंग सर्विस, क्योंकि डेटा वेयर हाउस एक होता ही यहाँ पे कि हम डिफरेंट सोर्सेज से जो डेटा आ रहा है उसको हम यहाँ पे कलेक्ट करते हैं एंड वी यूज इट फॉर द एनालिटिकल पर्पस। सो मोस्टली दिस विल बी यूज्ड इन दी बिग डेटा सॉल्यूशंस, राइट, जहाँ पे कि आपको एनालिटिकल क्वेरीज परफॉर्म करनी है ऑन द हिस्टोरिकल डेटा और द बैच डेटा, देन वी विल यूज द AWS रेडशिफ्ट. Now the third kind of like database service which is provided by the AWS, that is DynamoDB. DynamoDB is kind of NoSQL database service. तो हमारे पास दो तरीके के टाइप होते हैं, एक तो ट्रांजेक्शनल डेटाबेसेस हो गए, रिलेशनल डेटाबेसेस हो गए, एंड दूसरे टाइप के जो होते हैं वो NoSQL डेटाबेसेस होते हैं. सो NoSQL डेटाबेसेस जो हैं दैट इज़ हेल्पफुल कि हमारे पास जब ऐसी सिचुएशंस हैं, डेटा है वो NoSQL डेटाबेसेस में एक तरीके से स्ट्रक्चर्ड वे में नहीं आता है, ठीक है. हमने ट्रांजैक्शनल डेटाबेसेस की बात करी, वहाँ पे हमें पता है कि केवल हम रो कॉलमनर टाइप का ही डेटा स्टोर कर सकते हैं, ठीक है, और उसको वहाँ पे बहुत सारी ट्रांजैक्शनल प्रॉपर्टीज़ मेंटेन होती हैं. बट हम जब बात करते हैं NoSQL डेटाबेसेस की, तो NoSQL डेटाबेसेस इन पर्पस के लिए मोस्टली यूज़ होते हैं क्योंकि ये डिस्ट्रीब्यूटेड होते हैं. आपके पास पहली बात तो इतने लार्ज वॉल्यूम का डेटा होता है, तो वो आप एक सिंगल मशीन पे तो स्टोर कर नहीं सकते. आपको एक डिस्ट्रीब्यूटेड एनवायरनमेंट चाहिए जहाँ पे डिस्ट्रीब्यूटेड वे में आपका डेटा सेव हो सके, ठीक है, एंड रेप्लिकेटेड भी होता है क्योंकि जो इंटायर डेटा आ रहा है वो बहुत ही छोटे छोटे ब्लॉक्स में डिवाइड होता है एंड डिफरेंट डेटा नोड्स हैं उन पे जाके स्टोर हो जाता है. जो डेटा नोड हैं वो बेसिकली जो DynamoDB का एग्जांपल अगर हम लें यहाँ पर, तो DynamoDB एक क्लस्टर की तरीके से काम करेगा जिसमें कुछ डेटा नोड्स होंगे, ठीक है, जहाँ पे कि एक्चुअल हमारा डेटा जाके स्टोर हो रहा है, तो वो रेप्लिकेटेड भी होता है. दैट्स वाई कि जो NoSQL डेटाबेसेस होते हैं वो फॉल्ट टॉलरेंट भी होते हैं. आपके पास डेटा लॉस नहीं होगा अगर कोई एक कमोडिटी हार्डवेयर, कोई एक डेटा नोड पूरी तरीके से बेकार हो गया, कुछ भी हम उस पर परफॉर्म नहीं कर सकते, तो जो ब्लॉक्स बने हुए थे उनके डिफरेंट रेप्लिकास अवेलेबल होते हैं अदर डेटा नोड्स पे, तो आप कभी भी अपना डेटा लूज नहीं करते हैं. एंड हमारे पास जब इस तरीके के यूज़ केसेस होते हैं जहाँ पे कि स्ट्रक्चरल डेटा नहीं आ रहा है, अदर टाइप ऑफ डेटा सेट्स हमारे पास आ रहे हैं, फॉर एन एग्जांपल कि प्रॉपर जेसन ऑब्जेक्ट ही है जिसको कि मुझे स्टोर करना है, कोई की वैल्यू काइंड ऑफ है, या कोई ग्राफ बेस्ड हमें डेटा स्टोर करना है अपने डेटाबेस में, तो इस तरीके के यूज़ केसेस के लिए वी विल यूज़ दी DynamoDB, ठीक है. तो ये हमें हेल्प तब करेगा जब हमारे पास इस तरीके के यूज़ केसेस हो, ठीक है. फॉर एन एग्जांपल, आपने एक सिस्टम बनाया हुआ है, ठीक है, आप एक ई-कॉमर्स प्लेटफॉर्म हो, आपके पास लेट्स से 100 मिलियन यूजर्स का डेटा है, ठीक है. सो एट अ पर्टिकुलर पॉइंट ऑफ टाइम आपका जो यूजर्स का डेटा है, ठीक है, वो ज़रूरी है कि फिक्स हो सके, ठीक है. दैट्स वाई जो ये NoSQL टाइप ऑफ डेटाबेसेस होते हैं ये हमें हेल्प उन्हीं तरीके के डेटा के लिए करते हैं जहाँ पे स्ट्रक्चर फिक्स नहीं होता है, स्कीमा फ्लेक्सिबल होता है. कभी भी कोई एट्रीब्यूट ऐड हो सकता है बेस्ड ऑन द एप्लीकेशन, कभी भी कोई एट्रीब्यूट डिलीट भी हो सकता है बेस्ड ऑन द एप्लीकेशन नीड, ठीक है. सो जब इस तरीके की हमारे पास यूज़ केसेस होते हैं तो हम पूरे ऑब्जेक्ट को ही, और इस ऑब्जेक्ट को हम बोले तो एज अ डॉक्यूमेंट फॉर्म में ही डेटाबेस में स्टोर कर लेते हैं एंड एक स्पेसिफिक की पे मैप कर देते हैं. तो इसको अगर मैं बोलूँ तो की वैल्यू काइंड ऑफ डेटाबेस या की वैल्यू पेयर काइंड ऑफ डेटाबेस बोलते हैं, डॉक्यूमेंट बेस्ड डेटाबेस बोलते हैं. तो यहाँ पे होता क्या कि आपके पास कीज़ हैं. जैसे अगर मैं बात कर लूँ, हम कस्टमर्स की बात कर रहे थे, कस्टमर डेटा के लिए, सो कस्टमर रिलेटेड जितनी भी इंफॉर्मेशन है आप उसको एक जेसन ऑब्जेक्ट में पैक कर सकते हैं एंड इट विल बी स्टोर्ड, एंड आप कस्टमर आईडी को जो है वो की तरह यूज़ कर सकते हैं, ठीक है. तो लेट्स से आपने कोई एक एप्लीकेशन लिखी हुई है, सो आप कभी भी बहुत ही क्विक रिस्पॉन्स आपके पास आएगा, ठीक है. मिलियंस ऑफ जो रिक्वेस्ट है वो DynamoDB हैंडल कर सकता है इन अ फ्रैक्शन ऑफ सेकेंड, ठीक है, कि इतनी रिक्वेस्ट इस पे आ सकती हैं और क्विक लुकअप होके आपको वो पर्टिकुलर ऑब्जेक्ट रिटर्न होके मिल जाएगा जो भी आप कस्टमर का डेटा एक्सेस करना चाह रहे हो. सो इस तरीके के यूज केसेस के लिए वी हैव द DynamoDB एंड इट्स अ नो SQL डेटाबेस। AWS सर्वरलेस सर्विसेज, तो सर्वरलेस सर्विसेज एक्चुअली होती क्या है? तो सर्वरलेस सर्विसेज में ऐसा सुनने से ही हमें लग रहा है ना कि यार इसमें कुछ सर्वर जैसा नहीं होगा, ठीक है। तो बहुत ही सिंपल वर्ड्स में अगर हम बोलें तो अगर आपको कुछ भी, इवन आपको अपना प्रोग्राम तक एग्जीक्यूट करना है, लेट्स से यू हैव रिटन अ पाइथन प्रोग्राम, आपको अगर वो एग्जीक्यूट करना है तो आपके पास मशीन होगी, आपने उस पर पाइथन इंस्टॉल कर रखा होगा एंड देन यू विल बी एबल टू एग्जीक्यूट इट, ओके। एंड सर्वरलेस होने का मतलब है यू डोंट हैव एनी काइंड ऑफ कंप्यूट थिंग इन द बैकग्राउंड, ठीक है। आपके पास वो सर्विस है, आपको वहाँ पे ऐसा नहीं कि यार मुझे ओके फटाफट पहले पाइथन इंस्टॉल करनी है एंड फिर उसके बाद जो मैं कोड लिखूंगा वो एग्जीक्यूट होगा, नहीं। आपके पास ये एक एज अ सर्विस है, आपका जो भी बस कोड है आप उसको जाके केवल वहाँ पे अपलोड कर सकते हैं, कोड को वहाँ पे लिख सकते हैं, उसके बाद एक इवेंट बेस्ड हम उसको ट्रिगर भी उस पर सेट कर सकते हैं, ठीक है। सो लैम्डा परमिट्स यू टू रन कोड विदाउट ओनिंग और मैनेजिंग सर्वर्स, कि आपको यहाँ पे कोई सर्वर स्पिन अप करने की जरूरत नहीं, यू जस्ट लाइक राइट योर कोड एंड डिप्लॉय एंड इट विल गेट एग्जीक्यूटेड। जैसे भी आप उसको एग्जीक्यूट करना चाहें, चाहे तो आप उसको इवेंट बेस्ड बना सकते हैं एंड चाहे तो आप उसको मैनुअल ट्रिगर है वो भी आप कर सकते हैं। यूजर्स ओनली पे फॉर द कंप्यूट टाइम कंज्यूम, एंड जो ब्यूटी है उसकी वो ये है कि आपका लेट से कोई कोड है, कोई पीस ऑफ कोड है जो रेपिटेटिवली यूज होना है एंड आपने उसके लिए लैम्डा फंक्शन को यूज कर रखा है, लैम्डा में अपनी चीज़ों को कोड कर रखा है, तो जितनी देर के लिए बस आपका कोड एग्जीक्यूशन होगा आपको उतनी देर के लिए ही बिल पे करना है, ठीक है। उतनी देर की ही केवल आपके चार्जेस होंगे। मगर यही अगर हम बात कर लें अदर सर्वर्स की, जहाँ पे आपको सर्वर्स लेने, तो वहाँ पे तो सर्वर रन टाइम का आपको पेमेंट करनी है, ना कि आपको जितनी देर के लिए एग्जीक्यूट हुआ उतनी। सो दैट इज दी लाइक सर्वरलेस पार्ट एंड दी AWS लैम्डा सर्विस विच इज़ रियली पॉपुलर, जहाँ पे कि आप क्या कर सकते हो, इसको बहुत ही डिफरेंट इवेंट बेस्ड ट्रिगर बना सकते हो कि हाँ कुछ एक्टिविटी हो और मेरा ये कोड पीस रन कर जाए, तो इस तरीके का आप डिप्लॉय कर सकते हो सोल्यूशन यूजिंग दी AWS लैम्डा। AWS API गेटवे, तो ये बहुत ही इंपॉर्टेंट सर्विस है जब आप एक अच्छी वेब एप्लीकेशन काइंड ऑफ, या आप एक कोई वेब सोल्यूशन बना रहे हो, ठीक है। तो जब हम वेब सोल्यूशंस बनाते हैं डेफिनेटली हमारे पास एक URL होता है जिसको हम हिट करते हैं, हम कोई ऑब्जेक्ट जो है उसको एक्सेस कर पाते हैं, या कुछ भी वैल्यूज़ हैं उनको हम बैकएंड में राइट कर पाते हैं, तो उनको हम बोलते हैं APIs, राइट। सो जो AWS API गेटवे दैट इज़ अ फुली मैनेज सर्विस दैट मेक्स इट ईजी फॉर डेवलपर्स टू क्रिएट, publish, maintain, monitor and secure APIs at any scale. So basically जो application programming interfaces हैं उनको बनाने के लिए हेल्प करता है API गेटवे, ठीक है। आप क्या कर सकते हो, आप अपने URL एंड पॉइंट्स क्रिएट कर सकते हो यूजिंग दैट वन, एंड पर्टिकुलर URL पे जैसे आप बैक एंड रेस्ट APIs लिखते हैं, तो हम जब APIs क्रिएट करते हैं तो हर एक स्पेसिफिक URL का मतलब है वो किसी स्पेसिफिक पीस ऑफ कोड को हिट करेगा, जो कि या तो क्या कर सकता है, कोई डेटा पुल करके ला रहा होगा डेटाबेस से, या कुछ एक एंट्री क्रिएट कर रहा होगा डेटाबेस में। तो ये एक तरीके का रेस्टफुल API जब आप बनाते हो तो वहाँ पे API क्रिएशन के टाइम पे हम ये फंडामेंटल यूज़ करते हैं। सो उसके लिए ऑब्वियसली यू विल बी यूजिंग सम फ्रेमवर्क्स जहाँ पे कि आप उन चीज़ों को कोड करोगे, आप अपनी API डिज़ाइन करोगे एंड देन यू विल डिप्लॉय इट ऑन अ वेब सर्वर। बट उन सब सारी चीज़ों से आप दूर हट सकते हो। वी कैन यूज़ दी API गेटवे हेयर, हम अपने एंड पॉइंट्स यहाँ पे क्रिएट करेंगे एंड दोज एंड पॉइंट्स विल बी मैप्ड टू एनी लैम्डा फंक्शन, जो कि आपके लिए कुछ ना कुछ स्पेसिफिक पीस ऑफ फंक्शन को परफॉर्म कर रहे होंगे, वो कुछ भी हो सकते हैं, ठीक है। तो इस तरीके से वी कैन लेवरेज दिस सर्विस एंड वी कैन क्रिएट आवर वेब सोल्यूशन एंड वी कैन क्रिएट दोज वेब APIs. Now storage service, that is also very important. So the very common and very useful storage service the AWS has, that is S3, like simple storage service. तो ये सर्विस, इसको आप इस तरीके से समझ लो कि आप बस डेटा स्टोर कर सकते हो। यहाँ पे आपके पास जिस भी तरीके का डेटा है आपको एक सेपरेट प्लेस दे दी गई है, आपके पास एक गोडाउन टाइप का है, ठीक है, जहाँ पे कि आप बस चीज़ों को रखते जा रहे हो, स्टोर करते जा रहे हो, एंड आपका जो वो डेटा है वो सिक्योर्ड भी रहता है। सर्वर साइड इंक्रिप्शन भी आप उस पर लगा सकते हो। इवन यू कैन यूज़ योर कीज़ इन ऑर्डर टू सिक्योर योर डेटा। जो भी डेटा आपने क्लाउड पे स्टोर कर रखा है, यू कैन एक्सेस इट एनी टाइम। आप इवन उस डेटा को, ऐसा नहीं है कि आपको मैनुअली केवल यूआई पे लॉगिन करके वहाँ से ही आप अपलोड डाउनलोड कर सकते हो. यू कैन यूज़ लाइक हर एक सर्विस के लिए AWS ने ओपन APIs दे रखी हैं, बिकॉज आपके पास दो चीज़ें हैं इन तरीके की सर्विसेज को एक्सेस करने के लिए, कि आप AWS के वेब कंसोल पे जाओ, वहाँ पे आप चीज़ों को, आप जो सर्विसेज हैं उनको एक्सेस कर लो. ईदर यू विल बी यूजिंग दी ओपन APIs, राइट, कि अगर मुझे लेट्स से ट्विटर से कोई डेटा लेके आना है, ठीक है, तो ऑब्वियसली ट्विटर की ओपन APIs हैं. APIs आर लाइक जस्ट देयर पैकेजेस और मेथड्स और फंक्शंस जो कि लाइक यू कैन यूज इन ऑर्डर टू access the Twitter data or like make connection there and pull the data from there. So same kind of thing is with the AWS. Like अगर आपके पास कोई एक सॉल्यूशन, आपने कंप्लीट सॉल्यूशन बनाया है, तो वहाँ पे ऐसा तो है नहीं कि हम जाएंगे वेब कंसोल पे और वहाँ से चीज़ों को एक्सेस करेंगे, सर्विसेज को. वी विल यूज दोज APIs. लाइक फॉर एवरी सिंगल सर्विस दे हैव क्रिएटेड दी APIs. You can access those services from the code itself and manage things by your own. And for the S3 side, definitely it's in terms of the storage, in terms of scalability, like आप कितने भी amount terabyte, petabyte, exabyte of data इसमें store कर सकते हो. It will be scalable and it will be secured. So that's the beauty of the like AWS S3 storage service. AWS Access Network and Security Service. तो अब अगर हम कोई सॉल्यूशन बिल्ड कर रहे हैं, हम कोई सॉल्यूशन बना रहे हैं, तो हम कैसे एक्सेस इम्प्लीमेंटेशन करेंगे, कैसे सिक्योरिटी प्रोवाइड करेंगे. अब मैंने कोई एक सॉल्यूशन बनाया एंड मैं चाहता हूं कि इसको केवल वैसे ही लोग यूज़ कर पाएँ जिनको ऑथराइज्ड हों. जो लोग ऑथराइज्ड हों उस चीज़ को यूज़ करने के लिए, केवल वो ही उसको यूज़ कर पाएँ. तो ऑब्वियसली AWS ने कुछ ऐसी सर्विसेज प्रोवाइड करी होंगी जो कि मेरे पीस ऑफ वर्क को सिक्योर कर सकती हैं विद इन दैट AWS पार्ट एज वेल. ठीक है, तो अब हम उन सर्विसेज के बारे में देखते हैं. तो जो पहली सर्विस है लाइक AWS VPC. Amazon VPC enables you to set up a reasonable isolated section of the AWS cloud where you can deploy AWS resources at scale in a virtual environment. So that was I was talking about कि you are working on a solution. Let's say आपने कुछ एक solution build करा जिसमें आपने different services use करी AWS के, let's say S3, Lambda and let's say Redshift. ठीक है, इस तरीके की चीज़ें आपने यूज़ करी एंड यू जस्ट वांट टू मेक इट सिक्योर. ठीक है, तो हमें इंटरनेट पे पता है कि IP का फंडा होता है. ठीक है, आपके पास अगर आपको उस IP ऐप पे एक्सेस नहीं है, देन यू वोंट बी एबल टू मेक कनेक्शन, यू वोंट बी एबल टू एक्सेस दैट पर्टिकुलर वेब पेज. सो definitely that kind of virtual environment or virtual network you can create within the AWS environment कि इस सेक्शन में चीज़ों को कोई तभी एक्सेस कर सकता है जब कि अगर किसी एक्सटर्नल पॉइंट से अगर इस सर्विस को एक्सेस करने के लिए कोई रिक्वेस्ट आ रही है, अगर मैंने वाइट लिस्ट नहीं कर रखी है वो IP एड्रेसेस या वो अकाउंट, सो ऑब्वियसली मेरे पास जितना भी कंट्रोल है उन रिसोर्सेज का जो मुझे असाइन हुई हैं उनको कोई और एक्सेस नहीं कर सकता. सो यूजिंग दैट VPC सर्विस, इट इज़ लाइक जस्ट कि आप एक क्लोज्ड रूम में हो एंड और भी लोग वहाँ पे हैं. एक बहुत ही कह लो बड़ा घर बना हुआ है जिसमें कि यू हैव अ सेपरेट सेक्शन एंड आप नहीं चाहते कि कोई और उन चीज़ों को एक्सेस करो, और केवल वो ही एक्सेस कर सकता है जिसके के पास ऑथराइजेशन हो, जिसको आपने अलाउ कर रखा हो. सो VPC आपको उसी तरीके का एक आइसोलेटेड प्लेस बनाने के लिए हेल्प करता है विद इन दी AWS साइड. नेक्स्ट दी AWS IAM. सो AWS आइडेंटिटी एंड एक्सेस मैनेजमेंट. तो ये जो सर्विस है ये काफ़ी ज़्यादा इंपॉर्टेंट रोल प्ले करती है. हमने अभी तक इतना देख लिया कि AWS में काफ़ी सारी सर्विसेज हैं. ठीक है, अब किसी स्पेसिफिक पॉइंट ऑफ टाइम पे कोई एक सर्विस किसी दूसरी सर्विस से भी इंटरेक्ट कर सकती है, राइट. लेट्स से यू हैव रिटन अ सिंपल एप्लीकेशन वेयर यू आर ड्रॉपिंग अ फाइल इन S3, राइट. आप कोई एक फाइल है उसको S3 में ड्रॉप कर रहे हो एंड एज सुन एज दैट फाइल इज क्रिएटेड, बिकॉज फॉर लैम्डा वी कैन मेक द इवेंट्स कि कोई अगर इवेंट होता है सो दैट दिस स्पेसिफिक लैम्डा इज गेटिंग ट्रिगर्ड. सो बेस्ड ऑन दैट S3 create event I have triggered specific lambda and then I am just dumping that specific file or dumping that data into the database. So ये एक सिंपल सोल्यूशन मैंने बनाया, तो इसमें डिफरेंट सर्विसेज यूज़ हो रही हैं. हमारी S3 भी यूज़ हो रही है, हमारा लैम्डा भी यूज़ हो रहा है, एंड हमारा डेटाबेस सर्विस भी यूज़ हो रही है. सो these services can interact with each other, so they should have the access, right? They should have the policy attached with it. तो उसके लिए हम क्या करते हैं, एक रोल बनाते हैं. ठीक है, एक रोल हो गया कि स्पेसिफिक सेट ऑफ ऑथराइजेशन, स्पेसिफिक सेट ऑफ पॉलिसीज जो एक पर्सन को और जो एक रोल को हम देते हैं, एंड इफ दैट रोल इज बीइंग यूज्ड बाय डिफरेंट सर्विसेज, सो उस पॉलिसी में जो कुछ भी डिफाइंड है वो सारी सर्विसेज दैट स्पेसिफिक सर्विस कैन यूज. कि अगर मैंने एक रोल बनाया है जिसमें कि मैंने दे रखा है कि S3 रिसोर्सेज को आप फेच कर सकते हो, एग्जीक्यूट कर सकते हो, आप रेडशिफ्ट को एग्जीक्यूट कर सकते हो, आप उसका यूज़ कर सकते हो, एंड ये सारी पॉलिसीज़ मैंने एक रोल चीज़ में डिफाइन कर दी हैं. एक उसके लिए कह लो कि एक सिंपल सा एक सिक्योरिटी ग्रुप बना दिया है, काइंड ऑफ थिंग. ठीक है, तो हम क्या कर सकते हैं कि जिस भी सर्विस को वो असाइन करेंगे, क्योंकि लैम्डा को अगर S3 को भी एक्सेस करना है एंड रेडशिफ्ट को भी एक्सेस करना है, तो वो रोल लैम्डा के पास में होना चाहिए जो आपने क्रिएट करा है. ठीक है, तो अगर उसके पास वो अथॉरिटीज नहीं है, सो इट वोंट बी एबल टू एक्सेस इट. सो दैट्स द यूज ऑफ AWS IAM सर्विस, वेयर यू कैन अटैच these policies, you can create the policies according to you and assign it to a specific service, so that your things are secured. Like it's not like that any specific point of time कोई भी कुछ भी आके यूज कर रहा है आपने जो सोल्यूशन बनाया है. नेक्स्ट इज द सीक्रेट मैनेजर. सो इसके नाम से ही एक्चुअली क्लियर है कि ये किस तरीके की सर्विस है. सो AWS सीक्रेट मैनेजर इज बेसिकली काइंड ऑफ सर्विस और काइंड ऑफ लॉकर रूम. ठीक है, कि आपके पास कुछ इंपॉर्टेंट चीज़ें हैं जिनको कि आप कहीं पे स्टोर करना चाहते हो. ठीक है, बहुत ही हिडन वे में. सो फॉर दैट सीक्रेट मैनेजर इज द बेस्ट सर्विस. A good example is that let's say you have the database credential, you will be having the username, you will be having the password, port, host, everything. You will have that information for your database. And let's say you are writing your application, then you won't be hard coding those credentials in your application. Like कि अब मैंने यूज़र नेम भी कोड में ही मेंशन कर दिया, मैंने पासवर्ड था वो भी कोड में ही मेंशन कर दिया. ऑब्वियसली वी डोंट डू इट बिकॉज इट्स अ लाइक सिक्योरिटी फ्लॉ. कोई भी उन क्रेडेंशियल्स को यूज़ करके डेटा ब्रीच कर सकता है. टू हेल्प अस विद दैट काइंड ऑफ सिचुएशन, सीक्रेट मैनेजर सर्विस इज देयर, वेयर what you can do, you can just create specific credentials and they will be stored there, and using the APIs. अब हम क्या करेंगे, हम अपने कोड में सीक्रेट मैनेजर की APIs को यूज करेंगे एंड वी विल बी एबल टू एक्सेस द क्रेडेंशियल्स जो कि हमने वहाँ स्टोर करें. ठीक है, तो हम एक डीकपलिंग यहाँ पर देख सकते हैं. चीज़ें हार्ड कोडेड नहीं है, काफ़ी ज़्यादा डीकपल्ड हैं कि मैंने यहाँ पर अपना डेटा और अपना जो सीक्रेट क्रेडेंशियल्स हैं वो स्टोर कर रखे हैं और वो मैं APIs के थ्रू एक्सेस कर पा रहा हूँ, और अपने कनेक्शंस को जो भी मैं कनेक्शन बनाना चाहता हूँ दे आर सिक्योर्ड, और कोई भी तरीके का वहाँ पे इंटरप्शन नहीं हो रहा है इन टर्म्स ऑफ द सिक्योरिटी और इन टर्म्स ऑफ दी किसी भी तरीके का डेटा ब्रीच नहीं हो पाएगा, क्योंकि जो क्रेडेंशियल्स हैं वो हिडन है एंड केवल हम उनको APIs के थ्रू ही एक्सेस कर सकते हैं. नाउ वी विल टॉक अबाउट दी मैसेजिंग सर्विसेज. तो ये टाइप की सर्विसेज आज के टाइम में बहुत ज़्यादा इंपॉर्टेंट है. जब हम बात करते हैं कि नोटिफिकेशंस बहुत ज़्यादा आ रहे हैं, ठीक है, कि ईमेल्स आ रहे हैं, कहीं पे भी आप लेट्स से कोई अकाउंट बनाते हो तो यू कीप ऑन गेटिंग नोटिफिकेशंस. So in order to help with that kind of use cases, Amazon has developed two kind of services which basically kind of messaging services कि आपके पास कोई एक मैसेज टोकन है, कोई एक मैसेज पार्सल है which you want to send it to another AWS service, एंड कोई मैसेज है जो कि आप एज अ ईमेल भेजना चाहते हो नोटिफिकेशन के टर्म्स में. सो दैट काइंड ऑफ थिंग कैन बी डन यूजिंग दीज सर्विसेज. सो फर्स्ट सर्विस इज SNS, which is basically simple notification service. It is a messaging solution that provides low cost infrastructure for bulk message delivery primarily to mobile users. So that's why this is really helpful जब आपको एक बड़े स्केल पे बहुत सारे नंबर ऑफ यूजर्स को आपको नोटिफिकेशंस भेजने हैं, देयर दिस विल बी अ रियली हेल्पफुल सर्विस. Users can chat directly with customers through system to system or app to person communication between decoupled microservices app. So using these services, let's say आपके पास जो भी services हैं, तो वहाँ पे I was talking about the APIs and let's say they are doing something in between whatever communication is happening and let's say किसी एक वेब सर्विस ने कुछ डेटा राइट करा and they just want to send some notification to a user. So जैसे ही वो ऑपरेशन सक्सेसफुल होगा, there will be one message will be created in the like SNS. सो एंड वो जो SNS पे है, जो भी हमने प्रोटोकॉल सेट कर रखी है, लेट्स से ईमेल ट्रांसमिशन एंड लेट्स से नॉर्मल SMTP ट्रांसमिशन, सो वो जो मैसेज है उसी के अकॉर्डिंग ही डिलीवर हो जाएगा उन जगह पे. एंड आप यहाँ पे देख सकते हैं कि जो आर्किटेक्चर है कि SNS और मैसेजिंग काइंड ऑफ सर्विस है, ये बहुत ज़्यादा हेल्पफुल हो जाती है जब हम एक रियल टाइम डेटा सॉल्यूशंस बनाने की बात करते हैं, जहाँ पे बहुत कॉन्टिन्यूसली डेटा किसी भी सोर्स साइड से आ रहा होता है एंड हमको दूसरी साइड पे कंज्यूम करना है. तो उस टाइम पे होता क्या है ना कि ज़रूरी नहीं है कि सोर्स और जो हमारा डेस्टिनेशन या जो कंज्यूमर है उन दोनों की स्पीड सेम हो. एक जो प्रोड्यूसर है हमारा, ये जो सोर्स है वो एक डिफरेंट रेट पे डेटा को जनरेट कर सकता है एंड जो कंज्यूमर है वो एक डिफरेंट रेट पे कंज्यूम कर सकता है. सो वो रेट मिसमैच को हैंडल करने के लिए हमारे पास जो डेटा है या जो डेटा पैकेट्स आ रहे थे वो किसी जगह पे स्टोर्ड होने चाहिए सो दैट हम उनको एक्सेस कर पाएँ अगर हमारी रेट मैच नहीं कर रही है. तो उसके लिए ही ये सर्विसेज है हमारे पास, मैसेजिंग सर्विसेज. वन इज़ SNS एंड सेकेंड इज़ SQS. सो ये फर्स्ट सर्विस थी जो बनाई थी AWS ने एंड नाउ इट इज़ वेरी इंपॉर्टेंट इफ़ समवन हैज़ यूज द काफका. सो काफका भी एक पबसब काइंड ऑफ मॉडल है जहाँ पे कि आपके पास एक पब्लिशर होगा एंड आपके पास कंज्यूमर होगा. सो पब्लिशर व्हाट इट डज, it just picks data from the source and it keeps on writing on the like Kafka topics and those topics are actually partitioned. So data जो है आपका partitioned way में stored रहता है, replicated रहता है and fault tolerant होता है Kafka cluster जो हमारा है. So same kind of thing we can done with the SQS as well. जो SQS है वो क्लाउड साइड पे एज अ पबसब मॉडल के तरह हम यूज़ कर सकते हैं, क्योंकि जो भी डेटा हम सोर्स से जो प्रोड्यूसर कोड हम लिखेंगे दैट कैन राइट डेटा इनटू द SQS एंड वी कैन राइट आवर कंज्यूमर्स प्रोग्राम विच विल कंज्यूम डेटा फ्रॉम द SQS. सो इट इज़ डेफिनेटली मैसेजिंग queue kind of service just like the Kafka. So here we can see a simple diagram here where we have a producer which is generating some messages and they will be stored in the SQS in the form of queue, and now like consumer can consume it. So the SQS has actually two techniques like normal LIFO, last in first out kind of mechanism to store the messages in the queue, and FIFO, first in first out. So based on your use case you can pick your service by your own. Now the management and governance service, this is again very important, AWS Cloud Watch. So AWS Cloud Watch is basically a monitoring service, right, which helps the DevOps engineers, developers, SREs and IT managers. Why? बिकॉज हमें DevOps का रोल पता है, हमें SREs का रोल पता है, IT मैनेजर्स का रोल पता है, क्योंकि दे यूज़ टू टेक केयर अबाउट द इंफ्रास्ट्रक्चर. जो भी सेटअप हमारे पास है, जो इंफ्रास्ट्रक्चर बिल्ड हो रखा है, हमको उसे मॉनिटर भी करना है, राइट, कि किसी टाइम पे हमारे मशीन्स पे कितना ज़्यादा लोड है. ठीक है, तो ये अगर हमारे पास इस तरीके की जो भी मॉनिटरिंग है, सो AWS में होता क्या है कि वॉट एवर सर्विसेज वी आर यूजिंग, तो अगर कहीं पर कोई कंप्यूटेशन रिलेटेड थिंग है तो वहाँ पर क्या होता है कि वो कुछ ना कुछ लॉग्स जनरेट होते हैं एंड दोज लॉग्स विल बी ट्रांसफर टू दी क्लाउड वॉच. सो क्लाउड वॉच सर्विस एक है जो कि हर एक सर्विस के लॉग्स को कैप्चर करती है और इट बेसिकली मॉनिटर्स दी ऑल दी सर्विसेज विच आर रनिंग ऑन योर AWS अकाउंट. तो आप जो कुछ भी यूज़ कर रहे हो उन सर्विसेज की मेट्रिक्स जितनी भी होगी दैट विल बी कैप्चर्ड बाय क्लाउड वॉच, एंड आप जितना कंज्यूम कर रहे हो, जितना लोड है, वो सारी तरीके की मेट्रिसेस क्लाउड वॉच के पास होंगी. एंड बेस्ड ऑन दैट इवन दिस क्लाउड वॉच हेल्प्स अ लॉट. लाइक आप जो ट्रिगर्स बना सकते हो, आप अपनी जॉब्स को यहाँ पे शेड्यूल कर सकते हो बेस्ड ऑन द cron expression, based on some events, and whatever let's say metrics you are getting, you can even set the alarms as well. So for an example, let's say you have a EC2 instance जहाँ पे कि आपकी कोई सर्विस रन हो रही है एंड at a specific time you saw that like 80% CPU or is getting used, right? So ये बहुत ही critical use हो गया, यानी कि कोई बहुत ही heavy सर्विस रन हो रही है, बहुत heavy computation हो रही है एंड अगर इसी पे से रन करेगी so it can crash the server. So we can set that kind of alarms. That's why this CloudWatch part, it's very very handy and very very important for the DevOps engineers, because they need to maintain everything. They need to keep an eye on the infrastructure that everything is up and running. So ये तभी पॉसिबल है जब आपके पास वो मेट्रिसेस हों आपके इंफ्रास्ट्रक्चर की एंड आपके पास प्रॉपर अलार्म्स हो, प्रॉपर गवर्नेंस हो, प्रॉपर मॉनिटरिंग हो उन सर्विसेज की. एंड हेयर CloudWatch will help us with that kind of thing. So we can see a simple example here, like again I was talking about the EC2. So ये कुछ logs produce कर रही थी and what metrics, other metrics it will capture, like कि कितना load है इस EC2 instance पर. एंड जैसे ही हमने सेट कर रखा है वहाँ पे कि 80% से ऊपर क्रॉस होता है तो क्या होगा, CloudWatch से एक अलार्म ट्रिगर होगा एंड उस अलार्म पे हम बहुत सारी सेटिंग्स कर सकते हैं कि हाँ अगर ये अलार्म सेट हो तो एक मेल जाना चाहिए आईटी टीम को दैट लाइक दिस पर्टिकुलर इंस्टेंस इज कंज्यूम्ड मोर देन 80% एंड यूजिंग दैट नोटिफिकेशन. आपके पास मेल पे ही नोटिफिकेशन गया, लेट से आप क्या करते हो कि मेल्स उतना फ्रीक्वेंटली चेक नहीं कर सकते हो, सो आप एक ऑटोमेटेड पाइपलाइन टाइप में बना सकते हो कि नोटिफिकेशन है वो मेल पे भी जाए, आपके स्लैक चैनल पे भी जाए. आप स्लैक यूज़ कर रहे हो जो कंपनी अकाउंट है तो आपको स्लैक पे एक पिंग आ जाएगा, सो दैट समहाउ यू आर क्विकली एबल टू टेक सम एक्शंस. दैट इज द मेन मोटिव. AWS Analytics Services. So in the beginning I was talking about this part that for every single thing AWS has provided the cloud services, and again for the data analytics they have provided some really amazing services, right? Because in the big data domain you have couple of things, right? High volume of data, and for that we have talked about the storage service like the S3, and you should have a data warehousing kind of solutions where you can store your historical data and run analytical queries. So for that we have the database service like or data warehouse service like AWS Redshift and NoSQL database like the DynamoDB. But if we talk about the dashboarding side and if we talk about the distributed computation side, we should have some services, right? क्योंकि अगर हमें टेराबाइट ऑफ डेटा और पेटाबाइट ऑफ डेटा को प्रोसेस करना है तो वो एक डिस्ट्रीब्यूटेड इन्वायरमेंट में ही प्रोसेस होता है. वो ऐसा नहीं है कि आपके पास एक मशीन है एंड प्रोसेस हो गई. आपके पास एक n नंबर ऑफ स्पेसिफिक नोड्स ऑफ क्लस्टर होगा जिसको कि हम एक क्लस्टर और डिस्ट्रीब्यूटेड क्लस्टर बोलते हैं. सो वो उस क्लस्टर का काम ही है कि आपको एक इन्वायरमेंट वो प्रोवाइड करेगा जहाँ पे कि यू कैन just do the parallel computing, and for that AWS has provided these services. So the first and important like data analytics related service is AWS EMR, that is Elastic MapReduce. So if you are someone who know about the parallel computing, distributed computation like Hadoop, Spark, so AWS EMR इसी तरीके की ही एक distributed computation service है जो कि AWS ने बनाई है. Where you can install the like Apache Spark kind of frameworks, Hive, Hadoop, HBase, and इस तरीके के जो tools हैं वो आप EMR पे use कर सकते हो, run कर सकते हो for your use and for the distributed computation actually. EMR makes it easy to set up, operate and scale your big data environments by automating time consuming tasks like provisioning capacity and tuning clusters. सो इस तरीके की चीज़ें जो है कि आपको क्लस्टर को अपने ट्यून करना है, कैसे उसको स्केल करना है, ये सारी तरीके की चीज़ें आपकी जो मिडिल लेयर है वो हट जाती है यहाँ से, एंड एक तरीके की डिस्ट्रीब्यूटेड कंप्यूटेशन सर्विस आपको यहाँ पर मिलेगी यूजिंग दी EMR, जहाँ पे आप इस तरीके की फ्रेमवर्क्स को सेटअप कर सकते हैं. विद EMR you can run petabyte scale analysis at less than half of the cost of traditional on-premises solutions. क्योंकि जब आपके पास ऑन प्रीमाइसेस सॉल्यूशन होगा वहाँ पे आपको ये सारी चीज़ें स्क्रैच से सेटअप करनी है. आपके पास जितने भी सर्वर्स हैं आपको प्रॉपर जो भी आप टूल यूज़ करने जा रहे हो, लेट्स से ओपन सोर्स के लिए आपको सब कुछ मेंटेन करना है, कुछ इन बिटवीन आपका कोई नोड फेलियर होता है, यू नीड टू रिकवर इट समहाउ, क्योंकि ऑन प्रीमाइसेस है, आपके लिए डिफिकल्ट होने वाला उस चीज़ को मेंटेन करना. बट विद दी EMR side or with the AWS side, this is not gonna happen. Things are really scalable and काफ़ी ज़्यादा fast है in terms of the distributed computation. Next is AWS Glue. तो हमने AWS EMR की बात करी, एंड जो AWS Glue है that is also a distributed computation service, but it is more easy to use, more flexible and with some advanced options as well like AWS Glue. So इसके थ्रू हम क्या कर सकते हैं कि वी कैन इवन मेंटेन दी कैटलॉग्स, राइट. आपको वहाँ पे हर बार टेबल्स का स्कीमा डिफाइन नहीं करना है, एंड यू कैन यूज़ दैट कैटलॉग. जो भी आपका सोर्स सिस्टम है आपने कैटलॉग बना रखा है, एंड वॉट एवर कोड, डिस्ट्रीब्यूटेड कंप्यूटेशन कोड यू आर यूजिंग, यू कैन जस्ट यूज द कैटलॉग इन ऑर्डर टू एक्सेस दैट पर्टिकुलर टेबल. आपको टेबल्स के लिए बार बार कनेक्शन डिफाइन नहीं करना है कि यहाँ से टेबल रीड होनी है और समथिंग लाइक दैट. एंड यू कैन इवन क्रिएट द ट्रिगर्स हेयर. जो EMR है दैट विल बी अ काइंड ऑफ सर्वर काइंड ऑफ आर्किटेक्चर, जहाँ पे कि आपके पास एक प्रॉपर सर्वर होगा, आपको कंसोल पे लॉग इन करना पड़ेगा, कोड वहाँ पे आपको लिखना पड़ेगा. जैसे लिनक्स पे हम बैश स्क्रिप्टिंग करते हैं, ठीक है, एंड वहाँ पे यूजिंग दोज काइंड ऑफ एडिटर्स यू विल बी राइटिंग योर कोड, यू विल जस्ट डिप्लॉय देयर एंड यू विल रन. सो इट इज़ काइंड ऑफ लिनक्स बेस्ड इन्वायरमेंट, और एक लिनक्स बेस्ड आपका क्लस्टर होगा जहाँ पे कि आपको मशीन लेवल कोडिंग जाके वहाँ पर आपको करनी है. बट विद दी AWS Glue इट विल बी मोर ओवर लाइक UI थिंग, जहाँ पे आप UI पे जा रहे हो, वहाँ पे ही आप एडिटर पे कोड कर रहे हो. AWS का जो कंसोल है, एंड आई हैव ऑलरेडी टॉक्ड अबाउट दी कैटलॉग पार्ट. यू कैन इवन क्रिएट ट्रिगर्स की इस स्पेसिफिक टाइम पे मेरी ग्लू जॉब ट्रिगर हो जाए. You will have the flexibility to maintain the concurrent jobs, the timeout part, the delay part, notification part, everything will be handled on this part. And using the new feature of the AWS Glue, which is AWS Glue Studio, so there you can just see the dependency part, you can create the workflow, and it becomes more and more easy to do less coding, and it becomes more easy for you to create your distributed applications with just simple clicks, right, using the AWS Studio. So that was the advantage with AWS Glue, and now I think you can even compare between the AWS Glue part and EMR, and not that much. Definitely when you will explore, you will use it, you will get the actual difference between these two. The next and the last one is the AWS Quicksite. So AWS Quicksite, this is basically our dashboarding tool. When we talk about the data analytics, definitely if you have a meaningful information, you will be representing it on a specific dashboard, right? Creating pie charts, bar charts, line chart. So same thing kind of service AWS has provided, which is named as Quicksite. So if you know about the dashboarding tools, we have the Tableau, we have the Power BI, Grafana, Kibana, where we can create those kind of fancy dashboards. So that's how using the Quicksite, you can create those chart as well, like the bar chart, pie charts, and whatever kind of information you want to provide on the screen in the form of the charts. So it is basically kind of business intelligence tool. It is very easy to use. Quicksite dashboards can be accessed from any device. If you have the access on your AWS account, you will have a proper URL for it and you can access it. Quicksite is serverless and can automatically scale to tens of thousands of users without any infrastructure to manage or capacity for or plan kind of thing. Because when we talk about the third-party tools or third-party dashboarding tools like Power BI, Tableau, you have to pay a heavy license fee for that, and then like things will be maintainable for you. But using the Quicksite part, you don't need to maintain the infrastructure side, license fee, and whatever it is. You will be only paying the fees for the Quicksite once you as a user is accessing the Quicksite dashboard. If it is idle and if it is idle and if it is not getting used by the user, then you like won't be charged anything for that. तो ये एक ब्यूटी है क्विकसाइट की, बिकॉज इंफ्रास्ट्रक्चर को मैनेज नहीं करना है। जो काम हम अदर ओपन सोर्स और थर्ड पार्टी डैशबोर्डिंग टूल्स के साथ कर सकते हैं वो हम इसके साथ भी कर सकते हैं। कॉस्ट काफ़ी ज़्यादा कम है, बहुत सारे कंकरेंट कनेक्शंस को हम हैंडल कर सकते हैं, एक ही टाइम पे बहुत ज़्यादा कनेक्शंस और बहुत सारे यूजर्स को हम यहाँ पे हैंडल कर सकते हैं। सो इट्स जस्ट काइंड ऑफ डैशबोर्डिंग टूल प्रोवाइडेड बाय दी AWS. So these are the important AWS services. I hope now you are able to understand, at least you have the overview or the important idea about the AWS, what it is and what are the important services available in the AWS side. In the beginning, I talked about the cloud part as well little bit, but in the coming videos, I will actually bring a detailed video about the cloud computing. But in today's topic, the main agenda was to talk more about the AWS and its important services. So I hope this conversation and this kind of detailed information about AWS will help you with your development task using the cloud services. So that was all about in this video, guys. I hope you would have enjoyed it, and whatever I have talked about the AWS part, hope you would have found it very informative. If yes, then make sure to give a like and share this video with your fellow friends. And if you're new to the channel, then make sure to subscribe and press the notification icon. We will keep bringing such kind of exclusive content for you guys. And after watching this video, if you have any query, if you have any question and any doubt, and if you have any thoughts, then feel free to put it in the comment section. We will answer all your queries, all your questions. So that was all about in this video. I will see you guys in the next video.
Hey guys, welcome to the AWS EC2 tutorial. So in this particular session, we'll be learning all about the Elastic Compute Cloud Service. I'm Cody Suran and I'll be explaining you all about this particular tool, and we'll also be showing you how to create a virtual machine and how to create an instance, a Linux instance and a Windows instance on AWS. We'll also understand the theoretical concepts. So now before moving on with this particular session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. And also if you have any queries, please leave a comment down below and we would love to help you out. So now let's get started. So let's start with what is Amazon EC2. So Amazon Elastic Compute Cloud provides scalable computing capacity in the Amazon Web Services cloud. So using EC2 eliminates your need to invest in hardware upfront so you can develop and deploy applications faster. So to put it very simply, EC2 is a service which provides you servers. So you can basically create or any kind of server you want on the AWS cloud and start using it whenever you want to. So basically you don't have to wait for someone to buy hardware. So basically provide an upfront cost or put in a lot of capital, buy a lot of physical hardware, set up your servers, configure it, and then deploy your applications inside of them. Instead, if you're going with AWS cloud, in this case, they provide you the service called EC2. So EC2 is the service which can provide you the means to basically deploy your applications faster than how you used to do normally in an on-premise setup. So when it comes to EC2, you can basically create a Linux machine, a Windows machine, a Mac machine. So any operating system you want to, you can choose the RAM, you can choose the storage you want for that particular server. If you want 10 servers of the same configuration, you can get the same thing. If you need 100 servers, if you need 10,000 servers, AWS Cloud can scale up and down according to your needs. That's why it is called the Elastic Compute Cloud. So basically you can increase the compute power, decrease the compute power. You can increase the number of servers and decrease the number of servers according to your needs. And you can basically do it whenever you want and wherever you want. You don't need any high configuration missions. So you can use any laptop with just an internet connection, because every process is happening in the AWS infrastructure, in the AWS data center. You just need a proper system with internet. That's more than enough to access EC2 or any AWS service for that matter. So why we are going with EC2 first is because EC2 is the most integral service in AWS, and without EC2 a lot of other services would not work. For example, if you take Elastic Beanstalk is a platform as a service where you can upload your code by choosing the runtime. Let's say I have a PHP application. I can choose PHP, upload my PHP application's code, and it'll automatically provision servers in the backend for me, and it'll automatically host my application. So, but in this case, the thing is, To host the application, you would need a server in the backend. So Elastic Beanstalk automatically provisions the server, but that server is basically an EC2 server. You're not provisioning it, but yet it is launched in EC2. So Elastic Beanstalk would not work if there is no EC2. So like that, there are many other services which needs EC2 to function in AWS. Also, in Amazon EC2 provides scalable computing cloud in the Amazon Web Services cloud. So this is what I'm saying right now. Using Amazon EC2 eliminates your need to invest in hardware upfront. So Amazon EC2 enables you to scale up or down to handle changes in requirements or spikes in popularity, reducing your need to forecast traffic. So basically, when you're using EC2, you can create a scaling policy which will automatically look into the traffic, the CPU utilization of the servers. So let's say you have 10 servers and right now there are 1,000 users using your application. So now to handle each 100 servers, you need one server. So basically there are 1,000 users. You have 10 servers handling 1,000 users. So that basically means, let's say by average, one server can handle 100 users at a time. So let's say your application becomes an overnight hit and now there are around 10,000 users. So in this case, obviously you would need more servers to accommodate 10,000 users, right? For example, to handle 1,000 users, you needed 10 servers. So to handle 10,000 users, you would need 100 servers. So now Amazon EC2, if you set up a scaling policy according to the CPU utilization, if all these servers have already been utilized, the 10 servers, then it'll automatically create more servers to accommodate the incoming traffic. So same thing, let's say then it reduces to 5,000 users. So now if there are 100 servers running for 5,000 users, that would be a waste of compute power and also would be a waste of your cost. You are basically buying these servers, right? You are basically paying for whenever the servers are running. So you would be paying extra. So if there are 5,000 users, EC2 automatically will figure out and reduce the number of servers accordingly. So instead of 100 servers, it would make it 50 servers. So now you only pay for 50 servers for that particular period of usage. Let's say for 1 hour, 100 servers have run. So for that 1 hour, you would be paying the cost for the 100 servers. And let's say the next hour, the user traffic has reduced, now 5,000 users. For the next hour, there are only 50 servers. So the next hour, you are only going to pay for the 50 servers which has been used. Then let's say it's after 1 or 2 a.m. the user base has reduced because most people will be asleep. So let's say it goes back to like 50 users. And in this case, let's say you need only 5 servers. So in that case, if there are only 5 servers running in that particular period of time, let's say for 3 hours, only 5 servers were running. So that 3 hours cost would be the total of those 5 servers cost only. There won't be anything else or extra cost added to it. So this is how you can cost optimize, and this is how you can scale using EC2. All right. So this is basically EC2. It's an infrastructure as a service. So now in EC2, the virtual computing servers. So the servers are called instances. So I'm going to use the word instance hereafter whenever I want to mention a server, a virtual computing server in EC2. So if I say instance, that basically means a virtual computing server which is running on EC2. Okay. And okay, so now instances, let's keep them aside. Next, coming to the next important concept in EC2, which is an Amazon mission image. So it's called an AMI. So it is the template that contains software configuration, for example, the operating system, an application server, the application, so whatever it is. So basically it contains the entire software configuration for your instance. From an AMI, you launch an instance, which is a copy of the AMI running as a virtual server in the cloud. So to put it very simply, let's say you are creating a virtual machine in your local system using, let's say, Oracle VirtualBox or VMware workstation. So in that case, you will be using a ISO file. So the ISO file will have all the necessary configuration, the necessary data in order to create that particular server, right, in your local system. Create that particular virtual machine in your local system. If it's an Ubuntu system, it would have the Ubuntu configuration. It will have the Ubuntu complete setup inside of it so that you can create the virtual machine in your local system. So same way, the AMI consists of the configuration which is required to create that particular server or that particular instance which has that operating system, that server or the applications which are meant to be in that particular instance. Okay, so now again, you would understand this concept even better when I show you the demo. Right now I'm just trying to give you a simple understanding of what exactly we're going to do. So if you look at the image, it will give you an even better understanding. So now coming to the next point, the root device for your instance contains the image used to boot the instance. The root device is either an Amazon Elastic Block Store volume or an instance store volume. So this is basically the root storage for instance. So it could be Amazon EBS, which is a volume, or it could be an instance store volume. So instance store volume is created with the instance itself. Amazon EBS is a separate storage tool, okay, in AWS. So now looking at the image, you can see AMI over here, right? So this is the AMI. So now using the AMI, you can create one instance, or you can create multiple instances with the same configuration. So let's say you have a web server, and the web server has a website running inside of it. So now you can launch one instance, and it doesn't have to be that you'll have to launch every time individually. So let's say this particular AMI consists of an Ubuntu operating system which has a simple application running inside of it. Let's say it's a static website, and let's say it's just a hello world website. Okay, so now you want this hello world website to be running in 10 instances. So using this AMI, you can launch 10 instances at one single go. You don't have to basically create each and every instance and basically then log into it, then set up the entire configuration, then upload the file and do all of that. You don't have to do that. You'll just have to launch instances, and you'll have to set up the entire thing completely. You can do that with just a single AMI. All right. Okay, so when you launch an instance, so this is complete. Now coming to the next point. So when you're launching an instance, you should choose something called the instance type. So the instance type that you specify determines the hardware of the host computer. So each instance type offers a different compute, memory, and storage capabilities, and is grouped in an instance family based on these capabilities. Amazon EC2 provides each instance with a consistent and predictable amount of CPU capacity regardless of its underlying hardware. So what they are trying to say here is, so there are so many different instance types and you can choose any one of them. And if you need a high performance instance, you would need to choose an instance according to that. If you need a simple general purpose instance, you can choose according to that. But one more point which Amazon is telling, that Amazon EC2 provides each instance with consistent and predictable amount of CPU capacity. So whatever you choose, that will exactly be given to you. It will be provided consistently and predictably, so that whatever your underlying hardware is, the capacity you choose will always be provided to you. So this particular thing is this site. Over here, you can see there are the different types of instances. So these are the instance types. So general purpose, so these are the instance various kinds of instance types: general purpose instances, compute optimized, memory optimized, storage optimized. Okay, so now these are the available instance types. The complete list is provided here. You can just have a go through if you want to know what kinds of instances these are. And then previous generations. So these are the naming conventions, guys. For example, there is C3.Large. If you want to know what that is, everything would be provided in this particular section. Okay. So I just wanted to show one thing to you guys before moving on to the next slide. So all of this information would be provided while you're creating an instance as well. Yeah. So if you want to know more about the general purpose instances, you can go over here. And then there is compute optimized. So the compute optimized instances are ideal for compute bound applications that benefit from high performance processors. So if you have an application which requires a high performance processor, then go with the compute optimized instance. If you are just doing it for a regular application, go with general purpose. Or if you're doing it for practice, go with general purpose. Memory optimized instances are designed to deliver fast performance for workloads that process large data sets in memory. So if you have a machine learning model which needs to process a large data set in memory, not by storing it in the disk, but in memory, in that case, you should take up the memory optimized, which will give you a much bigger memory compared to the storage. Okay. And then finally, there is storage optimized. Storage optimized instances are designed for workloads that require high sequential read and write access to very large datasets on local storage. So the previous one, memory optimized, they are basically running it on memory itself. They are analyzing the dataset in memory itself. But if you have the data stored in a local storage, and if you want high read and write output. So if you want high speed read and write access, in that case you should go with a storage optimized instance. Okay, so if you want to know more about these instance types, you can go ahead and look into this particular documentation. So now I'm just going to go ahead with the PPT so that we could move on from the theory, and then I'll show you the demo, because theoretical, yes, it would teach you something, but then if you see the same thing practically, that would give you an even better understanding of what is going on. All right, and then okay, so now let's say we learned the basics about Amazon EC2. We learned what is an instance, what is an AMI, what are the instance types. So, and one more thing we'll be learning, which is the storage. That would be the next slide. So now these three are required. So let's say now we are launching an instance. Let's say this is a Ubuntu AMI. I'm launching an Ubuntu instance, and an Amazon EC2 instance transitions through different states from the moment you launch it through its termination. So what they're telling is that once you launch, it will start from a pending state, then it will have so many different states, and finally it will come to one particular state, and then once you are trying to do certain actions, the states will keep on varying. Okay, so now let's look into it. So I'm launching an instance. So the first state would be pending. So it would be in pending, and it would basically be launching this instance in the Amazon data center. So once it's launched, it will give us the required details like the public IP address, the private IP address, the DNS name. So all of that will be provided. So once that is done, it will do a status check whether the instance is running or not. Once it is done, it will give us this particular state. It will be in a running state. So when it's in a running state, that basically means we can start working on the instance. We can log in into the instance and we can start working on it. And then if I reboot the instance, then it will be in rebooting state, and again it will start running. And then if I stop the instance, so there are two major things: stop and terminate. If you stop the instance, that basically means you're just stopping the instance. You can restart it. It's like putting your system on sleep or shutting down your instance, and you can basically restart your instance and start using it. It's just stop. Okay, so if you stop it, you can start it again, and it will go back to the pending state and running state again. So that's basically stop. But if you terminate the instance, what happens is it basically shuts down this instance. Once it shuts down, it deletes the instance from the Amazon data center. It basically deletes the data, or it deletes the virtual machine altogether from the Amazon data center. Stop will basically keep your server right there. It will keep your instance in Amazon data center, and you can basically restart it again. But termination is completely terminating the instance. So these are the various states which an EC2 instance goes through. Okay, so the final slide we're going to look into is about the storage, because we already know about the instance. What is an instance? What is an instance type? What is an AMI? So, and one more thing we need to know before starting off with this demo is basically the storage, because when you are launching a server, that the server would need a storage in where the configuration files are stored for the operating system, right? Let's say I'm launching an Ubuntu instance. Obviously, the Ubuntu instance should be stored somewhere. So the data of the Ubuntu instance would be stored somewhere, right? So for that, we need storage. So there are different kinds of storage in which you can do that, which you can store in Amazon Web Services. So these are some of them, and that's what we're going to see. So Amazon EC2 provides you with a flexible, cost-effective, and easy-to-use data storage options for your instances. So each option has a unique combination of performance, durability. These storage options can be used independently or in combination to suit your requirements. So basically what they're saying is they provide you flexible, cost-effective options in terms of storage for your EC2 instances. So over here from the image you can see, so this is one instance, this is another instance. So let me just give you a brief about these different types of storage. So the first one is Amazon EFS. So Amazon EFS is elastic file storage. Okay, so basically EFS provides you shared storage, so you can have one storage and you can attach it to multiple instances. For example, let's say there is a very large data set and you want to share it with hundreds of servers, but that basically if you upload it to each server, that will obviously take a big chunk of the storage in each server. So instead of doing that, you can have a shared storage where you can create an Amazon EFS, and that shared storage could be connected to all of those instances. So every instance can see this exact same data set and basically import it or start using it. Okay, so that is EFS. So now then comes in the host computer section, you can see there is something called the Emr storage. So Emr storage is basically like RAM. So it only exists in the time of the instance is running. So let's say I launch an instance and the instance is running for 10 minutes. So in that particular period of time, let's say I'm doing some operations in the memory, so there will be data stored in the Emr storage. Okay. So now if data is stored in the Emr storage, so in that case, let's say I'm stopping the instance. If I stop the instance, that data won't be available because I've stopped the instance and the data in the memory would be erased. So that basically is Emr storage. And yeah, so this is the instance store. So this would be stored within the instance itself. And then finally comes Amazon EBS. So it's called the Elastic Block Storage. Okay, so Elastic Block Storage is basically the main storage type used in EC2 instances to basically connect. For example, when you launch an EC2 instance, you can choose to take an EBS volume. So when you choose to take an EBS volume, that basically will create an EBS volume, which is another AWS service, and that could be attached to an EC2 instance. And let's say you're launching an Ubuntu instance, the configuration files, the setup files, all the data files, everything will be stored in that EBS volume. Okay, and that EBS volume is exclusive to that particular EC2 instance. So there is a new feature, multi-attach EBS. You can create an EBS volume which can attach to multiple instances. But in this case, you will have to create a EBS volume, which is a different type of EBS volume. And also it will not attach to all types of EC2 instances. You will have to create something called a Nitro based instance, which is a much bigger and a much expensive instance. So normally to practice, I would not suggest to go with multi-attach EBS volumes. The normal ones are more than enough. That is normally attaching an EBS volume to an instance. So one more thing is that you can attach multiple EBS volumes to one instance. So let's say I have a laptop and the laptop storage is 1 TB. So I'm almost done with my 1 TB. I need more storage. So I can either buy a new laptop which has 1 TB more storage, or I can basically buy an external storage, okay, and attach it to my laptop and use that to store my data. So like that in EC2, you can create another EBS volume and attach it to the same instance and also mount it and use it like normally. So you can use the EBS volume normally. So yeah, so this is another storage. And finally, there is one more, which is Amazon S3. So we're going to learn about S3 in another tutorial, but right now I'm just going to give you a very brief. So let's say you want to basically terminate the instance, but you want to basically keep the configuration of the instance available in EC2 in AWS, so that the next time you want to launch the instance with the same configuration, same files and the same applications which you have already installed in it, so you can directly use the setup, the file, and directly launch an instance. So for that, there is something called a backup in AWS. So that backup is called a snapshot. So you can create a backup of the EBS volume, which again is called a snapshot, and which will be stored in S3. So now using the snapshot, you can create an EC2 instance which resembles the one you currently have. So this is where AMI comes in. So let's say you have created an instance, you have launched a server inside of it. There is a web server running. There are 10 different web files stored inside it. Okay. So now let's say you want an instance just like this. You want the same files, you want the same web server running in it, but you don't want to configure it again. So in that case, you can create a copy of the same instance. And once you create a copy of the instance, you can use that copy to create multiple instances with the same configuration. So this is the end of the theory part. So guys, in the demo, what I'm going to show is I'm going to show you how to create an EC2 instance first and how to connect to an EC2 instance. And once we connect it, I'll be showing you how to launch a web server inside the instance and how to basically make sure it runs. Okay, and the final thing I'll be showing you is how to create an AMI and create a copy of the same instance, so that you can increase the number of servers or decrease the number of servers according to your need. So these are the three things which I'll be showing you. So this is the theory part. Now let me open the console and let's start off with it. So guys, this is the next part. So we've covered the theoretical part. So now what we're going to see is we're going to understand the AWS Management Console. So the first thing you will have to do is obviously log in into AWS. And before doing that, make sure you have created an AWS account. So to do that, I'll just show you because I want to start from scratch. I don't want to give you guys information from right in the beginning. So basically, you will have to come to aws.amazon.com. So for now, it's showing sign into the console, right? I've already signed in. So let me just sign out. All right. So now it's asking me to sign in to the console. So I can directly sign in like this. Okay, so if you've not created an account, you can click on create a new AWS account. So then it's pretty simple. Just provide your email address, password, and your AWS account name. It'll be like your username. So this is basically set up like how you set up for a Facebook account or an Instagram account. It's pretty simple. So once you do this, just provide continue. So after that, they would be asking some more information like billing information, but either debit or credit card details. So the thing is, you will have to provide a debit or credit card detail. Without that, you cannot proceed. So if you're from India, they would detect 2 rupees from your account and which will be returned back to your account after 3 days because they just want to verify if your card is an authentic or a legit card or not. So that's it. So once that is done, your AWS account will be set up and you can wait for an hour or two and then everything would be set up in your account and it will be ready for use. All right. So once that is done, you can basically sign into your account. So I'm just signing in. Okay. So now you can access all AWS services here. There are sections for recently visited and you can save your favorite services too. Okay, so first of all, if you click on services, you can see every single service over here. And recently I just opened EC2. Okay, so this is a new account. And again, analytics, application integration. So these are the various service domains which you can click and look into various other services. For example, if you want to look into a migration service, then you can just click on migration and transfer and it will show all the different tools which are available for migration. So database migration, AWS migration, simplify and accelerate the migration of your data centers to AWS. Server migration, if you have servers in your on-premises system and if you want to migrate it to AWS without any further attention, without setting up anything, you can use server migration service. So like this, you can view services for every single domain. So in our case, EC2 is a compute service. It provides you compute power. So it gives you virtual servers in the cloud, which are called as instances. All right. So this is what we're going to cover in this particular session. So why EC2 at first? Because EC2 is the most integral service. So we'll be looking into many other AWS services in the future in our YouTube channel. So we'll be looking into VPC, S3. We will be looking into a simplified project using these services. We'll be looking into RDS, and there are so many services to learn. So this session, we want to look into EC2. All right. So once logged in, few things you'll have to look into is, so this is services. This is the search bar, like you can search for the services over here, and this is the shell. So it opens up the cloud shell if you already have services, so you can basically access those services via the shell. So to basically start working with the shell, you will have to know the commands, AWS CLI commands. So you can check out the AWS CLI documentation in order to start with that. So again, this is a little complex. I'm not going to go into this. This we'll see later in another session. And then this is a notification one. So if there are any issues with certain services, they'll be showing it over here. And then over here, so this is the help section. So basically, if you want to raise support ticket, then you can go to support center and do that. Okay, and this is an important part. So this is where you will be provided all the regions from all the regions which you can choose from. So these are the data centers, different data centers available in different various locations. So this is North Virginia, which I'm currently using. So if I'm in India, I could go with Asia Pacific Mumbai as well. So right now, the only data center available in India is in Mumbai. So rest every Asia Pacific regions are, you can see Hong Kong, Osaka, Seoul, Singapore, Sydney, and Tokyo. All right. And in US West, there are 4. Europe, there are 6. Yeah. So basically, you'll choose whichever region you want. I'm just going to go with North Virginia. So this is one of the most reliable regions in AWS because as you can see, this is US East 1. And so basically the US data centers, get the new features first before they implement it in other data centers. So if there is a beta version of a new service, that would be implemented in the US data centers. So if you are using AWS, then go with the US data centers to start off with, that is to practice with, because if you want to check out the new features, it would be available in the US data centers. All right. Okay. And then this is your account details. So your account ID will be provided here. If you click on this, more account details will be provided. This is organization. This is a separate tool, AWS organizations. So if you're working for a company and let's say you can create an organization, under that you can have multiple AWS member accounts. So for example, let's say you are managing a team of 50 people who all are working on the cloud, who all have separate accounts or who all have member accounts. So you can maintain that access from this one particular tool organization. So if you want to remove certain access, if you want to give people access, you can do that from this particular console. Okay, service quotas. So initially there would be certain service quotas. For example, you can only launch 100 servers in one particular region. So if you want more, you can basically click on service quotas and check what are your current service quotas, and then ask for an increase in your quota to AWS, and they would give you an increase as soon as your ticket is solved. Okay. And then billing dashboard. So this is where you get all your billing details once you, let's say you're using a service for 3 hours. If it is not under the free tier limit, that will basically give you a charge. And that charge will be reflected in the billing dashboard, which you can view over there. Security credentials. So these are important, but again, you need to know more about AWS in order to understand these concepts. Okay, so I'm going to skip this. All right. So this is the account and you can sign out directly from here. Okay, so this is basically the console, guys. And then over here you can see build a solution. These are for beginners. You can start off with this as well. You can learn the fundamentals from the documentation. You can pick a learning path. Okay, so now I'm going to just open the EC2 console. All right, this is how the EC2 console looks. Over here you can see the instances, the elastic IP addresses, the key pairs. So I'll be explaining what is a key pair, so you don't have to worry about what are these. I'll be explaining about them. So I won't be explaining about load balancers or security groups. What else? Yeah, so load balancers I won't be explaining because it's a separately different concept. Load balancers again is a major topic which we can see. And then there is a new feature available right now, EC2 global view. So if you have servers in, let's say, 10 regions, and if you want to view them in one single place, so you can click on EC2 global view and it will give you a view of all the servers running in all the regions. So this has been provided recently. This was not available before. So you can see they are giving you a complete overview of all the regions, number of instances running, if there is a VPC created, if there are subnets, if there are security groups, and every single information you need to know about EC2 instances. All right. Okay. And one more thing I wanted to show you guys is, yeah, so instances running, if there are any instances running, it will be shown over here. Okay. All right. So this is basically the introduction. So next what we'll be doing is we'll be launching a server in EC2. That's when we'll be understanding more about EC2 and how to configure EC2, how can we choose an AMI and all of that. So I'll be explaining every single step. I'll be explaining the components and the things I'm entering. So you don't have to worry about anything else. So just follow me through. If you already have created an AWS account, then you can just follow this tutorial you can basically walk through with me. If not, create an AWS account and then start off with a video from this particular part, because we'll be looking into a demo from here on. All right. Okay. So we'll start off with the demo. So starting off with the demo. So first of all, we'll be looking into instances. So we'll be launching an instance using EC2. So as I already explained, instance is a server. So I'm going to show you how to launch a Ubuntu instance. And once we launched an Ubuntu instance, I'm going to show you how to connect to the Ubuntu instance using the terminal. So this is a Mac, so the connection, I'm going to use a terminal to connect it. If you're using a Windows system, then you can download something called Putty. So Putty is a tool which I'm going to show you. So this is the Putty link. So you can basically go over here and download the Windows installer. So over here you can just download it and you can start using the Putty tool instead of using the terminal. So this is for Windows. If you're using a Linux machine, so let's say you're using Ubuntu or a CentOS machine, so in that case again you can directly use the terminal itself. You don't have to use anything else. Okay, so now let's start. I'll be explaining each and every step while we go through this. Alright, so instance running. So currently there are no instances running, so it's not going to show anything else. And so before moving on, I just wanted to show one more thing, which is the free tier in AWS. Okay, over here you can see, you can go to aws.amazon.com/free if you are watching the video currently. You will be provided with all the services which you get a free tier for. So basically you would get a amount or number of services, number of features for free for a period of time. For example, for EC2, they're giving you 750 hours of runtime for a server. Like, it's not one server. Let's say if there are 10 servers running and each server can run for 75 hours. The total would become 750 hours. So for that 750 hours, you would not get billed anything. If your hours go beyond 750, then you will start getting billed for the first 12 months once you create your AWS account. So like that, all the integral services have certain free tier limits. So you can basically be within the free tier limits while practicing, and you won't get any bill. You would not get billed anything. So you can just check what is free for 12 months, what are the services which will be always free. So like Dynamodb, 25 GB of storage in Dynamodb is always free. 1 million publishes in SNS is always free. So like that, all of this will be provided. All right. So I just wanted to show that because while we go through this particular process of launching an instance, here we'll be given options of something called a free tier instance type. So I don't want to take you again over the website to show you this is what a free tier is. So I just wanted to show you right now so that we can move on. All right. Okay. So now let's launch an instance. So to start off with it, you can just click on launch an instance over here, or you can just go to the EC2 dashboard and click on launch an instance over here. Alright, so the next step is basically to choose an Amazon mission image. So over here you can see the first one is Amazon Linux 2 AMI. So Amazon Linux 2 is the operating system which Amazon themselves provide. And you can see there is something called free tier eligible. So whichever AMIs have the name free tier eligible over there are the AMIs which are given for free of cost. You won't get charged anything for using these AMIs. If you're using the other AMIs, for example, the deep learning AMI or the deep learning AMI GPU PyTorch, let's say Microsoft Server 2019 with SQL Server 2019 standard. So these kinds of AMIs will cost you. You will get billed. So to start off with it, to practice, you can just start off with the free tier eligible AMIs. So I've already explained what is an AMI. And so again, they also recently added the Mac OS. You can be also create a Mac server. All right. Okay. So what I'm going to do is I'm going to launch an Ubuntu server and I'm going to show it, and I'm going to connect to the instance and show it to you. All right. Okay. So Ubuntu instance, it's free tier eligible. And yeah, so I'm going to choose the 20.041. There is the 18.04 as well, which is the older version. The new latest stable version is 20.04. So I'm going to select this. So the next thing it will ask is what type of an instance type do you need? So the instance type which is going to be free for you if you create a new AWS account would be t2.micro. So every other instance types will get you a build. So the only instance type which is free is t2.micro. So go with it. So what you want to know here is, so t2.micro provides you one virtual CPU. So that basically means it provides you one virtual CPU of compute power and 1 GB of RAM. And it only allows EBS storage. That is, you can only connect an EBS volume to it. You cannot connect anything else. You can connect other storages, but the root volume would be EBS. So if you come down, so here you can see SSD is allowed. Here EBS only. So wherever EBS only is provided, you can only connect EBS. Wherever SSD is provided, you can connect other services like instance store. You can connect EFS. So all of that can be connected. So you can also connect EFS to here, but EFS would not be the root volume. The EBS volume which will be created with the instance would be the root volume. So that would be added in the fourth step, which is add storage. So first we choose the AMI. Second we choose the instance type. We need one virtual CPU and 1 GB of RAM. All right. Next, we are going to configure the instance details. So over the instance details, the first one is number of instances. If you need one instance or 10 instances or 100 or 1000, how many instances do you need? You will have to provide the number over here. Okay, so it will create that many instances for you. The next one is a purchasing option. So we are not going to purchase any instance right now. So this basically, I'll explain it to you. Purchasing option is basically you can reserve the instance for a year or 3 years. So it will basically provide you a dedicated instance in a dedicated physical server, which will always be available for you at any time. So if right now we are creating an on-demand instance. An on-demand instance is basically an instance which you create whenever you want, terminate whenever you want. But if you want, let's say 100 instances dedicated for you in a dedicated physical server, even though it's AWS, it's someone else's data center, but you want dedicated number of instances. In that case, you can use the purchasing option. You would also get a discount in the purchasing option because you're going to purchase it for a complete year. So you'll be locked in for a year and you'll be paying for that. All right. Okay. And next comes the network, subnet, and auto assign IP. So this I'll be covering in the VPC tutorial, but again, these are very vast concepts which you'll have to understand more. But to be very simple, so every single system should be in a network. Without a network, you cannot have a system. So to connect with the system, to communicate with the system, there should be a network. So that's what VPC will do for you. You can have an isolated network within AWS, which will be isolated from other VPCs, other networks which other customers have. Okay, but again, you can create a peering network within two different VPCs. So peering network is a communication network where a server from another VPC can talk to or communicate with another server in another VPC. So again, so these concepts we'll learn in another tutorial, and so I'm just going to move ahead. Okay, so for now you just have to know this number of instances is 1. So we're going to create 1 instance. That's it. Next, we have to add storage. So while you install a server, while you install this particular instance, the data, the files should be stored somewhere, right, in a root volume. So for that, we need to create a root volume instance, okay, a volume. And here it's basically an EBS volume. As I told you, only EBS is allowed in this particular instance type. And free tier eligible customers can get up to 30 GB of EBS volume per month. Okay, so you can see I can go to the free tier thing and check it out. So I'm just going to use 8 GB. So because Ubuntu server doesn't need more than 8 GB of storage, just takes 2 GB. The server itself is 2 GB. Then there will be lots of space for storage because I'm not going to upload any huge file to the server. So it doesn't matter for now. I'm going to go with the initial size, which is 8 GB. Okay. And delete on termination. So if you switch this on, what happens is when you delete the server, that is the instance, the EBS volume which is attached to it will also automatically delete. If not, if you disable this, when you delete it, the EBS volume will still be available. You will have to delete it manually. Alright. So I'm just going to keep it enabled. And encryption, you can use a key which is available already, or you can leave it just like that. And shared file system. So this is EFS. So you can add a file system directly over here. Or after creating an instance, you can create a shared file system and then later attach to it. Okay, so again, this would be a storage tutorial. I'm not going to get into the storage part. We're just covering the EC2 part. Okay, so we need a storage root volume. So we've created that. So that is automatically provided. It's 8 GB. And volume type, it's going to be general purpose. And next, tags. So tags are not integral. They are clearly an optional step. So why tags is basically, let's say you have 10 instances, let's say you have 100 instances and you have created 10 instances in that particular region. There are other people using the account, but you want to differentiate your instances. So in that case, you can give all the 10 instances a unique tag, which you can search for and it will provide those particular instances. For example, let's say name, I'm gonna put it as scalar. So in this case, the instance which I'm creating will have the tag as scalar. And if I have 10 instances named scalar, and if I search for scalar in the EC2 instance dashboard, it will give me all the instances named scalar so that I don't have to navigate through the entire list. Alright. Okay. So this is basically tag. And then security group. So a security group is really important for an EC2 instance. A security group is what decides basically what traffic should come inside the instance, what traffic should go outside the instance. It's basically like a firewall. Not exactly a firewall, but a list of rules which lets something happen. For example, right now only SSH is allowed. SSH basically means secure shell. So secure shell is a type of a TCP protocol which lets you connect to the EC2 instance via port number 22. Okay, so for now, basically this particular EC2 instance will be allowed to all the IP addresses. So if I want, I can change it to my IP. For example, if I provide my IP, it will only allow my IP, that is my particular personal computer, to access this particular EC2 instance. But if it is in custom or if it is in anywhere, so this basically will allow any system across the world to connect to my EC2 instance. But not everybody can connect. You can only connect to the instance if you have the private key to decrypt the public key which will be available in the instance. So now you would be confused by the key pair. So that's what we're going to cover next. So I'm going to just provide just this one SSH. So I'm going to review and launch. Okay. So everything else is provided. I hope you guys understood the steps. So just follow through and you can create an instance within a couple of minutes. So now when you click on launch, it won't launch the instance. It will ask for a key pair. Okay. So now I'm going to create a new key pair. And so I'm going to name it as, I'm just going to name it as tutorial key. All right. I'm going to download it. So the key pair is downloaded. Okay. So now you can launch the instance. So why did I download a key pair? You might ask, what exactly is the purpose of a key pair? So now I've downloaded this key pair called tutorial key. So now this particular key pair will have two keys. One will be the public key and one will be the private key. The instance we are going to launch will have the public key inside of it, and the private key is the one which we have downloaded. All right. So now when you're logging into the instance, not if you provide public access to anyone could log in into the instance if they have the public IP address, but that should not happen. So we do not want that happening. So in that case, what you're doing is only I would be having the private key, which I just downloaded. Only I have the private key. Nobody else has it. Even though they know the public IP address of my instance, even though my instance is open to the world, anybody could try to log in. But if they don't have the right private key, nobody else could log in apart from me. All right. So that's why we need a key pair. It's for security purposes and it's to log in into the instance. Okay. So now let's launch the instance. So now first it basically create all the dependencies. Once the dependencies are created, the instance will be launching. So now we can view the instance. As I told you, first it would be in a pending state. So in a pending state, then it will come to a running state. So then you would be seeing here status check. So the status checks will become 2/2. So that basically means the instance is successfully running. So now the instance over here, you can see the public IP address has been provided. The private IP address has been provided. So the public IP is what you will be using to connect with. The private IP address is the IP address which is particular for the EC2 instance. If there is another service within my AWS account trying to connect to my EC2 instance, in that case it can use the private IP address instead of the public IP address. Okay. All right. So now we can see the instance is running and status check is initializing. So let's just wait until this completes. Sometimes it will so you can see the status checks are running, system status checks and instance status check. So it will just check if the instance is running properly, if there is any issues. If there are no issues, that it will just show 2 out of 2. That's it. Okay, so then there is a security. So this is where you see all the security rules, the security group which was created. Networking, again, so networking provides you more information about every single networking detail, the public IP, private IP, public DNS. So public IP address and the public DNS is the same. So it's basically this DNS name will search for this particular IP address. That's it. It just redirects to this IP address. So you can see it's the same thing. And so it's an internal DNS name, and then what VPC has been attached to it, which subnet has been attached to it, and what is the availability zone. So in North Virginia alone, there are 6 availability zones. That is 1A, 1B, 1C till 1F. All right. Yeah. So basically, this is launched in the 1B availability zone. Okay. Okay. So next storage has been created. It's been attached. Status checks. Let's just refresh this. Okay. Then monitoring. So this basically will provide you a little bit of insight to the instance. So it will show what is the CPU utilization. So the instance is yet to start running, right? So that's why it's not showing any data. So once it starts running, it will show the CPU utilization. It will show whether the status checks have been succeeded, network in, network out, what is the packets, how many packets came in, how many packets went out of the particular server. That's the internet usage. And if there is any data which was read, there was any data which was returned, so all of that will be written. Okay, got it. So now you can see 2 out of 2 status checks have been passed. Okay, so now I just want to show one thing. So first let me open this particular IP address. So I just wanted to show that there is no website running or web page running in this particular EC2 instance, because I just launched it and I am just opening that particular IP address so that you would know there is no web page running in this. Okay, so there is nothing running in this, that's why it's still loading. It won't show any web page. Okay, so I'll be launching a web page. That's why I'm saying when I launch a web page, when I run this exact same IP address, it will show a web page. Okay, okay, so now let's connect the instance. The instance is successfully running. Okay, and then over here you can see there are 3 options. You can reboot the instance, you can stop the instance, and terminate the instance. I told you what each of these things does. And if you stop the instance, then also you can terminate the instance, or you can start the instance back and start using it. And there are other actions you can connect to it. So again, the connect option. So these are the same things which are provided over here. All right. Okay. So now let's connect to the instance. So there are multiple options to connect to an instance. One is the EC2 instance connect. So when I click on it, it will open another tab in the browser, and we can we can basically access the instance directly from the browser itself. And there is another option, session manager. So we are not going to use this. Okay, we weren't able to connect to your instance. Common reasons for this. So basically I have not installed these agents, so I'm not using this. So we're not going to go ahead with this. Connect your instance without SSH keys or bashing a host. Okay, so we are not going to use the SSH manager. And then we have the SSH client. So SSH client, which is what I told you, Putty is in SSH client. There are other SSH clients as well. So if you have those SSH clients, you can start using them. Okay. And then there is one more, which is EC2 serial console. Again, I do not have this particular setup. So either we can go with EC2 instance connect, or we can go with SSH client. So I'm going to show you both of these, how to connect with both of these, because I have an SSH client in my local PC, which is automatically enabled in my terminal. So as a Mac, so I can just search for the terminal and connect directly to it. Okay. And so first I'm just going to connect it over here. So you don't have to do anything else. You can just click on connect. It will automatically open a new tab, and it will automatically establish connection to the instance. You don't even have to provide the private key over here. Okay. So whenever you launch an instance, the first thing I would suggest you to do is update it. So as this is an Ubuntu instance, it would be apt-get, it would not be yum. So if it's another Linux instance, if it's Amazon Linux, then it would be yum. And also the so I'll tell you that when I'm connecting it with the SSH, what would be the default login name. So the default login name for an Ubuntu system would be Ubuntu itself. So this one. If it's any other Linux system, the default login name would be EC2 user. So this would be the default login name for any other EC2 instance. If you're launching Amazon Linux, then you'll have to use this when you're connecting with via SSH. So one more thing I would suggest is, do not connect it via browser and start working with it, because it's a little buggy. I would suggest you to connect with the SSH client itself. All right. So one thing I want to do is, so for example, let's say there are no files in this drive. I'm just going to create a 1.txt file, so that when I connect it via the SSH client, you would know it is the same instance. That's it, nothing else. All right. Okay. Just going to close this. So now let me open the terminal and let's connect to it. All right. So I'm just going to make it a little bigger and increase the size. All right. Okay. So now we have opened this. So now to connect to this, we'll have to use the SSH client. So the SSH client, this is the example. Basically, we can use this directly and connect to it. So I'm going to just use this. So one small correction would be that this could be the IP address, or this could be the DNS name. For example, let's say I'm pasting this. All right. So this could be the DNS name, or this could be the IP address. So one thing is that the tutorial key.pem file is not located in this particular location. All right, this key is not known by other names. Yeah, so I'm just going to give no for now. Okay, so the thing is, this particular key which I downloaded is in the downloads folder. It's not in this particular folder. So we'll have to go to that folder in order to access it. So now before doing that, I just wanted to show you. So SSH minus hi or I hyphen I, and this would be tutorial. Yeah, so basically what I was saying about is, so we have to figure out where the key is. So then we can basically connect to it. So we can, again, as I told you, so this is the DNS name. If we go to the instance, alright, so this is the IP address. We can use the IP address or we can use the DNS name. So what that basically means is, so instead of this, you can provide the IP address. That's what I mean. But you can still go with the DNS name. So I'm not going to change it. I'm just going to copy it. And one thing is that SSH hyphen I, so tutorial key.pem. So this is hyphen I basically denotes the key, and we are providing the name of the key. And then Ubuntu is the username at what is the IP address. So that's what you are providing. So it will basically search for the server and it will use this particular key to connect to it. Okay, pretty simple. Now I downloaded it, so it would be in the downloads folder. So I'm just gonna see, and yeah, so it's in this folder. I'm just gonna paste. Okay, so now this particular key is in this folder. I know that, so I'm just gonna go with it. So I've hit enter, and now you can see the authenticity of host. The IP address has been provided, can be established, and the key fingerprint is provided. The key is not known by other names. Okay, so yes. Okay, so now you can see this has been added to the list of known hosts, unprotected private key file. So that is fine. We can just change the permissions of the tutorial key. Yeah, so the key's permission has been denied. So nothing else. We just have to change the permission of the key. Okay, so over here you can see, right, chmod 400. We can just run this command and we can make sure it's available. So that's it. I'm just going to paste this and done. So now let's run this again. So now it has been successfully connected. So the instance has been connected. You can see Ubuntu at the IP address has been provided over here. Okay, so now if I do an ls, it should show the 1.txt file which I created in that browser, right? So it's the same instance, we just connected it with the browser. Now we are connecting it with the terminal. Okay, so if I do an ls, you can see the 1.txt file is available. So simple. So we have created an instance and connected to the instance via the local terminal. So this is basically one of the biggest things in AWS and one of the most easiest things to start with. So you have successfully created your own server and you have connected to the server in your local system. Okay. So now the next step we're going to do is we're going to create and we're going to configure a web server inside of this particular server, and we're going to run it publicly. So over here, right now, as I told you, there is no web server running. So we're going to launch a web server inside this, right? Okay. So now, so there is a web server. We can either use Apache 2 or we can use engines. So I'm just going to go with Apache 2. I'm going to install Apache 2, and so it would be a sudo apt-get install Apache 2 and -y. If there is any question which is asking yes or no in between, it will automatically provide the answer as yes. Okay, so we are installing Apache 2. So this is a web server which will be configuring and creating a complete web server for us, in which we can put our HTML pages, or we can put in our, what is that? Yeah, so we can put in our PHP pages, and that will work fine with this. All right. So that's what we are trying to do over here. And once done, we'll have to do one more thing. That is, we'll have to allow this particular web page in the AWS console. So we have provided only access to SSH, right? So the instance could only allow SSH, but in this case, we need to allow another access. So we need to allow another protocol which would be listening to this particular web server. All right. Okay. Okay. So the web server has been successfully installed. Alright, so the location of this particular web server in this particular server would be in a location called /var/www/html. Alright, so there is an index.html file available over here. This is the index.html file which will reflect when I'm going to refresh this page. but it won't reflect now because we've not allowed the port number 80 and the protocol HTTP. So once we allow that, this particular web page will be shown over here. Okay, I'm going to go to instance management and go to security. So we'll have to allow the port number over here in inbound rules. So to allow it in inbound rules, we have to open the security group which is attached to the instance. So I'm going to open the security group and edit inbound rules. So I'm going to click on inbound rules and add a rule. So here it could be custom TCP, and you can just provide the port number as 80, or you can basically select the HTTP and you can provide anywhere IPv4, or you can provide my IP. So you can connect it from your IP. So I'm connecting to the instance from my IP address, right? So then it will only show that particular instance, particular web page from my IP address. So I'm going to use anywhere. So okay, so I'm allowing anywhere over here, and I'm going to save the rules. So done. So now HTTP protocol has been allowed. So now if I refresh this particular web page, this particular IP address, which is the IP address of my server, this web page index.html should be shown over here. So I'm going to just refresh this. So it's just taking some time to load. So I'll just close this and let's open it again. We'll go to the instance. We go to networking. Yeah, so now we can see the Apache 2 default page has been loaded over here. Okay, it's pretty simple. So this particular page, index.html, is shown here. So we have successfully launched a web server and hosted a simple web page over here. So now what I'm going to do is I'm going to do one more thing. I'm going to basically create, so this is a web page. So what I'm going to do is I'm going to basically create another file, let's say 1.html over here, and we are going to use that. So I think this particular page is kind of still loading. So what I'm going to do is I'm going to launch another terminal. Okay, and I'm going to make it bigger. And then open downloads. Okay, so I'm going to connect to the instance once again. Okay, so we've connected to the instance. So now let me open the same drive. So we'll have to add a slash here because we are in a different directory and we are taking this from root. So that's why we'll have to add that. All right. So okay, so now index.html is available over here. So now let's do one thing. Let's add sudo 1.html. Okay, so I'm going to just provide something like hello world. This is 1.html file. All right, and I'm going to save this file. So I'm going to save this as 1.html. It's been saved. Now I'm going to exit. So now you can see 1.html file has been created. Let me just check. So hello world, this is 1.html file. So HTML file has been successfully created. So now let me go over here again. So this basically searches for the index.html file in the /var/www/html directory. So in the HTML directory, it's searching for the index.html page. So now if we write 1.html, then it should fetch the 1.html page. Over here you can see, hello world, this is 1.html file. So this is very simple web page hosting. So that's what we have done here. So if you want your website to be running as the default page, in that case, you would just have to remove this particular index.html page and replace it with a new index.html page. And that's more than enough. So when you put the IP address, it will automatically run. So, okay, so this is basically the very simplest part. All right. So now, this part. So I'm going to show you one more demo, which is going to be AMI. That is, we're going to copy the AMI and we're going to launch the instance so that it has the same web page, Apache 2 Ubuntu default page, and this 1.html page already available inside of it. So we are not going to configure anything. We're just going to launch it and we're going to see if that instance has this page is available. Okay, so to start off with that, we have to first create an image of this instance. That is, we have to create a copy of this instance we have created over here. So instance state, so this is the instance state. Now if you go to actions, there will be an option called images and templates. Okay, so here you get an option called create image. So you have to click on create image, and you have to provide an image name. I'm just going to provide it as copy of scalar. All right, and then if you don't want any reboot while you are creating this image, you can provide this, but it's fine, let the instance reboot, no problem. If you want to add another volume, you can add it, or it will automatically create a default volume, and it will use the snapshot of the instance which we already have, which is the scalar instance. It will use a snapshot of that and basically copy the entire configuration into this, so that all the configurations we've made, all the software we've installed, all the files we've created, all of those will be available in the new instance which we'll be creating using the AMI, which we are creating right now. Okay, got it. Okay, so now done. So we provided the name of the image. That's more than enough, and we're going to create the image. Okay, so image has been created. So to see the image, you have to go under images, AMIs. So now you can see it's pending. Alright, so this is the instance which we have, guys. So I'm creating an AMI, and I'm going to use this AMI to launch another instance. And that instance, I'm not going to log in into the instance. That instance is already going to have all the files which you already configured in this particular server, this particular instance. So let's say if you want to create an instance and want to scale up and down accordingly, so this is how you do it. You create a copy of the server which you have configured, which has all the software, which is all the code files, which is all the data which is required for your application to run, and you create a copy of that, and you use the copy to create multiple servers, so that there could be more servers created of the same configuration again and again. So now again, the thing is, if you want to change the configuration a little bit, in that case you can just change the configuration in one server, create a copy of it, and use the copy to again create similar servers. So this is how it works. You don't have to log in into every single server and configure every single time. You just have to create the server once, configure it once, create an AMI, use the copy to create a similar server. Got it? So it's that simple. So it will take some time to basically come back, basically come as available, and it's a private AMI because I'm creating the AMI within my AWS account for my personal use. So it would be private. If you want, later you can make it into a public AMI which others can use. Okay, if not, it's fine. So for now, let's let it be a private AMI. Okay, and so this is the AMI ID, and this is the source, which is my account, the owner account, and yeah, so pretty much that's it. So only thing we'll have to wait is for it to become available. Okay guys, so now the AMI has been available. Okay, so the status has been changed from pending to available. So now we can use this AMI to create a similar instance of the instance which we created and configured. So it's pretty simple. Just select the AMI, click on launch, then it's the same steps. Okay, just choose the instance type. I'm going to choose the same instance type, t2.micro. Configure instance details, I'm going to leave it to the same. Add tags. So this is the storage. Again, I'm going to leave it to blank. I'm going to just leave it like this. I just need the same thing. Tags, I'm going to name it as AMI instance or copy of scalar. Next. So here, I'm going to use the same security group which we just created, launch wizard 52, I guess. Yeah, which has HTTP and SSH both. So I'm going to use the same thing because we are not going to log in into the instance and launch a web server and then configure it. It's already been configured. We'll just have to allow HTTP, and once the instance is running, the web page will be already running in the server, in the instance, right? Okay. So now let's launch. So now, second thing is that you don't have to create a key pair every single time you launch an instance. If you have a private key in your system, you can just use the same key pair. Over here, I've created as tutorial key, right? You can just use the same key pair in order to connect to any instance you want. So the public key will be available in various instances. So make sure only you have the private key because it's pretty important. If anybody else has the private key, they could connect to the instance. So keep your private key with yourself, and that's it. So then you can just launch the instance, and once the instance is running, then it will already have the web page running inside of it. So this is the web page which we have over here, right? Okay, so this particular server should have the same web pages running because it's the copy of this particular server. Okay, so I'm just going to copy the public IP. So it's in pending state, but yet I'm just going to paste it and keep it over here. So once the server is up and running, it should show the Apache 2 default page over here, the Ubuntu default page over here. Okay, so it's running. So status checks are not done yet, but sometimes even though it's showing initializing, it will be already done. So I'm just going to refresh it and check once. Okay, so the instance is running, guys, and you can see it's a completely different IP address, and this is a different IP address, and it already had the Ubuntu default page available inside of it because it's a copy of the instance we created. So this is how an AMI works. The AMI will have the complete configuration, the software, the applications, the files, everything which is inside of an instance, and we create an AMI of that instance. It will create a complete copy which can be used to create more instances, basically replicating the same instance. Alright, so now this instance should also have the 1.html file. So it also has the 1.html file inside of it, guys. So this is basically it for this particular demo for the EC2 tutorial. So I showed you how to create an instance, how to create an AMI, and how to launch an instance with the AMI which we just created. So this is basically it. It's pretty simple, right? And you can also go through, you can also follow through with this particular tutorial, and you can also start with AWS. So it's pretty simple to start with. Anybody could start with it. And if you want to launch or deploy your own website, you can just use the server. It's really cheap. You can just use this server in order to host your web page or your website. Okay, so that's it for this session, guys. Thank you. So that's it for this session, guys. I hope you understood and it was informative. If you have any questions, please leave a comment down below and we would love to help you out. And also, if you like the video, please subscribe and share. Thank you. Hey guys, welcome to the AWS VPC tutorial, and in this particular session we'll be learning VPC comprehensively. So I'm Kodishwaran and I'll be teaching you the concepts in VPC, what is VPC, the different components in VPC, that's the most important part. So internet gateways, NAT gateways, NACLs, and other components which are available in VPC, everything will be covered in this particular tutorial. So this would be a pretty long and extensive tutorial, so make sure you watch the whole thing so that you get the entire service. Okay, and before moving on with this session, please make sure to subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. And also, if you have any queries, please leave a comment down below and we would address all of your questions. So now, without any further ado, let's get started. So guys, let's start off by understanding what is Amazon VPC. So Amazon Virtual Private Cloud enables you to launch AWS resources into a virtual network that you defined. So in the AWS cloud, you basically have to define a virtual network, which is basically an isolated network in your own AWS account. So now this virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using the scalable infrastructure of AWS. So basically, when you're using AWS, there are millions of people, millions of companies using AWS. Right? So in this case, what happens is you would have to isolate your resources from the others' resources, or you would have to isolate your resources in your own account from other resources in your own account. So for that case, you can have a VPC, a virtual private cloud, which creates an isolated network inside the AWS cloud. So even though it basically resembles a traditional network setup, you can still use AWS's architecture in order to scale up or scale down your infrastructure. And also, one of the main common use for Amazon VPC is it's the networking layer of Amazon EC2. So if you do not know what EC2 is, go ahead to our previous tutorial on Amazon EC2 and learn about that, and then come back to this tutorial so that you could get a better understanding of what EC2 is, because when we are looking into the demos, in that case, we'll be using EC2 to demonstrate certain aspects of VPC. So in that case, you would have to know what is EC2 and how to create an EC2 instance. So for that, you can go ahead and look into it. Okay, so now this is what VPC is. Okay, so now let's just look at the key concepts in VPC before we move on. So first of all, VPC, Virtual Private Cloud, a virtual network dedicated to your AWS account. So again, it's dedicated to your AWS account, and also it will be dedicated to a particular region. So there are many regions in AWS which you can choose from. So under each region, there would be a default VPC available. And then you can create more VPCs. About that we'll see later in the session. So now, so it is basically dedicated to your AWS account. It is not shared with anybody else. And then a subnet. So under a VPC, you can have multiple subnets. So a subnet is basically a range of IP addresses in VPC. So let's say your virtual private cloud VPC allows around 64,000 IP addresses. So now you can create a subnet which allows around 4,000 IP addresses, and so that subnet allows 4,000 IP addresses, and you create another subnet which allows 10,000 IP addresses, but they cannot overlap because they are individual subnets. And the subnet 1, which has 4,000 IP addresses, the range of 4,000 IP addresses, will have a set of IP addresses which we can assign. So if you launch a instance, EC2 instance within subnet 1, it will have an IP address within that IP address range which has been provided. And then same thing if you go with subnet 2, which has 10,000 IP addresses, which has a different range of IP. In that case, if you launch an instance within that, it would have a different IP address, which would be within that particular range of IP addresses. Got it? Okay. So next is route table. So it's a set of rules called routes that are used to determine where network traffic is directed. So again, this we'll also learn later in the session. Internet gateway, a gateway that you attach to your VPC to enable communication between your resources in your VPC and the internet. So as I told you, the VPC makes sure that it isolates your resources in your VPC from the outside world or from any other VPCs in the AWS network itself. So how would a communication happen? How, let's say you are opening your instance and you want to download something from the internet. If the VPC doesn't allow that, in that case, you would not be able to download any applications. Okay, so for that, you can use internet gateway. So an internet gateway is attached to that VPC. So once it's attached to the VPC, any resource within the VPC will be able to access the internet. So that basically is an internet gateway. And then a VPC endpoint. So it enables you to privately connect to your VPC, support AWS services and VPC endpoint services powered by private link without requiring an internet gateway and NAT device VPN connection or AWS direct connection. So a VPC endpoint is another concept, another tool in VPC. So in this case, let's say you have another service, another AWS service, and you want to connect to your service within the VPC. But let's say in this case, if you want to connect within your own AWS account, in that case, it would be much better to connect privately rather than connecting publicly over the internet, because that would be unsafe. Right? So if you want to connect privately, for that case, you can use a VPC endpoint. You can create a VPC endpoint for your resource, which can be used to connect to the resource. So let's say you want to access S3 from your EC2 instance. S3 is a storage service. So let's say you want to access the storage service from your EC2 instance. One way you can do is from the AWS CLI directly via the internet. So if the internet gateway is attached, and if you have given permission, if you have configured your AWS command line interface, you can access S3 from your EC2 instance. But if you have not done that, in that case, let's say you create a VPC endpoint for that S3 bucket. Okay, so now using the VPC endpoint without going through the internet, you can connect to the S3 bucket directly via your just the VPC endpoint. Nothing else is required. All right. Okay, and then there is CIDR blocks. So CIDR blocks are called classless inter-domain routing. So this is the Internet Protocol address allocation and route aggregation methodology. So when I was talking about subnets, I said there would be a range of IP addresses, right? So to provide that range of IP addresses, you would have to use a CIDR block. A CIDR block decides from what IP address to what IP address would be the range of that particular subnet. So it has its own methodologies, which is again a completely separate major topic. So we'll be learning about CIDR blocks as well. I'll be giving you the basics of all of these concepts. So that's what we'll be learning. All right. Okay. And then default and non-default VPCs. So if your account was created after 2013-12-04, so it comes with a default VPC. So if it was created before 2013, so in that case, you would have already created a default VPC by now. It's been so many years. But if you have created, most probably most of you would be creating your account after 2013. So in that case, your account would already come with a default VPC and a default subnet. So once you create your own AWS account, AWS themselves create a default VPC and a default subnet within the default VPC for you. So that's what they do. So if you have a default VPC, you don't have to specify any subnet when you launch an instance. So in the previous AWS tutorial, AWS EC2 tutorial, you can see that when I'm launching an instance, I'm not going to specify any VPC or subnet. If you just launch it in the default VPC, it will launch it in a random subnet, whichever it chooses. You don't even have to provide your preference on which subnet you want to launch it to. So you can do that without even understanding what VPC is. You can get started with EC2, Elastic Compute Cloud, without even understanding what VPC is or what default VPC is. So later you can get a better understanding of what VPC is. So that's what we are doing right now. So again, if you've not watched the EC2 tutorial, please go watch it, do the demos over there, and then come over to this particular tutorial. All right. Okay. So you can also create your own VPC and configure it as you need. So this is known as a non-default VPC. Subnets that you create in your non-default VPC and additional subnets that you create in your default VPC are called non-default subnets. So basically any VPC which we are creating is called a non-default VPC, and in the non-default VPC we'll be creating certain subnets. Okay, so those subnets are non-default subnets. That's the only difference between default and non-default. Default is created by AWS, and it will be already available when you create an AWS account. Later, if you are going to create and configure your own VPC, that would be a non-default VPC. Right? Okay. So now VPCs and subnets. So I already gave you a brief about what a VPC is. So virtual private cloud is a virtual network dedicated to your AWS account. I already told this. So now it is logically isolated from other virtual networks in the AWS cloud. There are going to be a lot of virtual networks, right, in the AWS cloud. So maybe in just your account, you might have 4 to 5 VPCs. So let's consider all the customer base in AWS. So in one particular region, there can be, let's say, hundred thousands of VPCs. So now your VPC will be completely isolated from all the other VPC unless you have made a connection with another VPC. Okay, but until then, everything will be isolated. Your VPC, the resources within the VPC would be isolated from all the other virtual networks in the AWS cloud. So you can launch your AWS resources such as EC2 instances inside your VPC, and VPC will make sure your EC2 instance, that is your resource, is isolated from all the other instances and all the other resources and all the other VPCs. So when you create a VPC, you must specify a range of IPv4 addresses for the VPC in form of a classless inter-domain routing block, CIDR block. For example, 10.0.0.0/16. So this is the primary CIDR block for your VPC. And also a VPC spans all of the availability zones in the region. Okay. All right. Okay. So now let's come to the first point again. So here you can see that they're asking us to specify an IPv4 address range. So when you provide this IPv4 address range, that would be the complete IP address of this particular VPC. So the range of IP addresses. So the range would last from, what is this, 10.0.0.1/16. So it would go to, so it is 16, right? So 16 in the sense 10.0 would remain stagnant. It would be the same. Only the last 8 bits will change. So this total 10.0.0.0.0. So let me just make it clear. So these, right? So the total is 32 bits. And they've provided the subnet mask as 16. So when it's 16, that basically means the first 16 bits will remain unchanged. Okay. So now that basically again means only these bits, these 16 bits can be changed. All right. So in that case, so what happens is, so the range of this particular IP address would be 10.0.0.1. So, okay. And so that would be the starting IP. And the ending IP would be 10.0.255.255. So there are so many possibilities within that particular IP address range. Okay. So this is what you'll have to know. Okay, so yeah, so this is how you provide an IPv4 address. And so also when you create one, it will automatically show you how many IP addresses are possible within that particular IP address range. Okay, and then there is VPC, availability zone A, B, and C. Okay, so in a region, there are, let's say you've created a VPC in a region. So let's say I've created a VPC in the North Virginia region. And if the North Virginia region has 3 availability zones, the VPC will span across all the availability zones. If that particular region has 6 availability zones, the VPC would span across all the 6 availability zones. That is, if I launch a EC2 instance in availability zone A or availability zone C, it doesn't matter. I can still launch them within the same VPC, even though they are in different availability zones. So availability zone is a logical divide in an AWS region. Okay, so that's basically what availability zone is. There will be multiple data centers, so that let's say you can have your application running in multiple availability zones. If one availability zone is down or has some issues, you can basically redirect the incoming traffic to your application to the other application which is running in another availability zone. All right. Okay, so this is basically what VPC is. And then coming to the next point, so this particular following diagram shows a VPC that has been configured with subnets in multiple availability zones. So 1A, 2A, and 3A are instances in your VPC. So over here you can see 1A, 2A, and 3A are instances in the VPC. Okay, and one more thing you have to know is, so as I told you here, so let's consider this is the same VPC. So 10.0.0.0/16. All right, so we are creating 3 subnets within the VPC: subnet 1, subnet 2, and subnet 3. And over here you can see subnet 1's IP address range, that is the CIDR block, has been provided as 10.0.0.0/24. This is 10.0.1.0/24. Again, same thing, it's 10.0.2.0/24. So the thing is, the IP address range you're providing for your subnet cannot, so it will be within the IP address range of the VPC, but it cannot be the same as the IP address range of your VPC. So if your IP address range of the VPC has been provided as 16, so you cannot use the same subnet mask as 16. It should be more than that. It should be 20 or 24 or 30 or something like that. Okay, so in this case, 10.0.0.0/24. So this basically means that the first 24 bits will remain unchanged. Only the last 8 bits will be changed. Okay, because total 32 bits, it's 24 bits. So the first 24 bits will remain unchanged. The last 8 bits can be changed. All right. Okay, so same thing goes here. One of the address, let's say 10.0.0.1, it would be 10.0.0. Let's say 10. So that can be an IP address. So here again, so the first 3, that is the first 24 bits, will remain unchanged. So all of the IP addresses will start with 10.0.1. Yeah, so that will basically be the distinction between subnet 2 and subnet 1. So subnet 3, again, it will, all of the IP addresses within the subnet will start with 10.0.2, and the rest will follow. Okay, so this is basically subnets. And about route tables, we're not yet there. We'll talk about later in this particular session. And yeah, so these are basically the subnets, and over here you can see there are 3 instances launched, right? 1A, 2A, and 3A. So now you can see the IP address of the 1A instance. Okay, so it's 10.0.0.5. So as I told you, it would be within this IP address range. So now let's see the IP address of 2A. So this is the private IP address, not the public. Public IP address would be totally different because it should be globally accessible, the public IP address, and globally unique. It cannot be a repeating IP address. So this is within the subnet, that's why it can repeat. All right. Then the private IP address of 2A is 10.0.1.5. You can see the first 24 bits are unchanged. Same thing coming to subnet 3, 10.0.2.5. So again, first 3, that is the first 24 bits are unchanged. All right. Okay, so these are subnets. Basically, it's a segregation, or it's a range of IP addresses within the VPC which you have created. All right, that's it. Okay, next is default VPC components. So default VPC components. So basically, I would just wanted to share with you guys what are the components in the default VPC, which AWS will create for us. So as I told you, once you create an AWS account, default VPC will already be available in your account when you start working with it. You can start with EC2, you can start launching instances directly because a VPC would be already available and you don't have to create any. So in the default VPC, what are the different components available? So the first one is obviously the VPC itself. So it will be provided by this particular address 172.31.0.0/16. So this particular IP address range, it allows 65,536 private IP addresses. All right, so these many IP addresses are possible in this particular IP address range. So now create a size/20 default subnet in each availability zone. So then they create let's consider North Virginia itself, the North Virginia region. So there are 6 availability zones in the North Virginia region. All right, so in the North Virginia region, they are creating, in each and every availability zone, they are creating a subnet which has the size as /20. That is, the subnet masking as provided as /20. Okay, and when it's provided as /20, it allows 4096 addresses per subnet. So out of 65,000, so let's say there are 6 subnets, so it would be 4096 into 6. So there would be these many IP addresses available in those subnets, in those individual subnets. So there would be an individual subnet for every single availability zone. Third, they would be creating you an internet gateway, so that if you create an instance in any of the subnets, that instance should be able to access the internet, or from the internet you should be able to download something over the instance. Okay, and then add a route to the main route table that points all traffic to the internet gateway. So what this basically means is, in the route table, in the main route table which has been created, they are adding a route which is targeting all traffic. So what it basically means is, all kinds of traffic from the instance can go through this particular route and reach the internet using the internet gateway. So it's routed to the internet gateway, so that particular resources, that is these instances which are launched within the VPC, get access to the internet via the internet gateway. So over here you can see, right, in the main route table, so this is the internet gateway connection. Okay, coming to the next one, create a default security group and associate it with your default VPC. Once the VPC, let's say you are creating one, you'll also have to create a security group eventually. But here they already have created a default security group and associate with your default VPC. So security group is created and attached with your default VPC automatically. And when you're launching an instance, you can still use the default security group. And then there is create a default network access control list, ACL. And associate it with your default VPC. So network access control list is more of rule. It's a rule set, like a firewall, where you can basically control the access, whether it's coming from a different IP address or whether it's coming from one particular range of IP addresses. Let's say you want to take off access to this particular VPC for a range of IP addresses. You can do that with network access control list. Or if you want to only allow access to a certain number of IP addresses, let's say it's an internal application, you only want to allow the IP of the company's network, the IP addresses of the company's network, to be able to access your particular application. So in that case, you can use a network access control list even for that. And finally, associate the default DHCP options set for your AWS account with your default VPC. So the DHCP options are basically the domain name, the domain names, complete host name. So all of that details would be in the DHCP option settings, and that the domain name for the VPC, everything will be associated to your default VPC once it's done. So these are the default VPC components, guys. So the thing is, when we create a VPC, we can manually create all of this as we want. So if we want an internet gateway, we can create an internet gateway and attach to it. If we want to change the route to in the route table, we can do that. If you want to create another security group and attach it to your VPC, you can do that. If you want to create an ACL, you can create that. If you want to create an NAT gateway, you can create that. So we can do a lot of things with VPC. So that's what we'll be doing in the demo. And before that, let's just figure out and finish up all the concepts so that we would know what exactly we are doing in the demos. Okay, next comes the internet gateways. So the internet gateway is a pretty simple concept. An internet gateway is a horizontally scaled, redundant and highly available VPC component that allows communication between your VPC and the internet. So now the VPC, as I told you, it's an isolated network. So now the isolated network, what if it needs, let's say, had to communicate with the internet? So let's say a resource within the VPC wants to communicate with the internet, or some entity or some third-party application from the internet wants to integrate with an AWS resource within the VPC. So in that case, you would need an external entity, right, to allow this communication to happen. So that communication is basically internet gateway. So internet gateway lets this happen. So internet gateway makes sure that the resources within the VPC are able to access the internet and vice versa. So an internet gateway serves two purposes. To provide a target in your VPC route tables for internet routable traffic. So it will create a target for your resources. So when a resource is trying to access the internet, it can use that route, and that route would be the IP address of the internet gateway, which can be used to route and communicate with the internet. And the second one is to perform network address translation for instances that have been assigned public IPv4 addresses. So for the instances which has public addresses, public IP addresses, for those particular instances, internet gateway can do NAT, that is network address translation, in order to make sure it communicates with the internet. All right. Okay. Coming to the next one, which is NAT gateways. A NAT gateway, again, from the name itself, it's a network address translation gateway. Okay, so you can use a NAT gateway so that the instances in the private subnet can connect to services outside your VPC, but external services cannot initiate a connection with those instances. For example, in internet gateway, it is both ways. That is, the resource in the public subnet can access the internet, and a third-party tool or a user from the internet can access the AWS resource within the subnet. So that's basically an internet gateway. Now coming to a NAT gateway, let's say you want to configure your resource. So what if you just wanted the connection to be one way, that is, only the resources in your subnet, in your VPC, needs to access the internet, but the entities of a third-party entity from the internet should not be able to initiate a connection with those instances in the private subnet. So that's where NAT gateway comes in. So NAT gateway, so from this diagram you can see, so this is the internet gateway, right? And this is the NAT gateway, which has the elastic IP address. And okay, so let's say, so this is, these two are subnets, okay, and these are instances. Okay, so you can see elastic IP addresses are provided for these instances, and there is no elastic IP address provided for these instances because these are private instances. Private instances only have the private IP address because they are not publicly accessible. Only if they are publicly accessible, they would have a public IP address. So elastic IPs in this case are public IP addresses. Okay, so now there is so this is basically the NAT gateway, right? And now let's say this 10.0.1.5 instance, this particular EC2 instance, wants to access the internet. So now it only has the private IP address. It cannot use the internet gateway because internet gateway only does network address translation for public IPv4 addresses. It does not do it for private IPv4 addresses. So that's where NAT comes in, NAT gateway comes in. So now this instance, while it's trying to access, it will be routed to the NAT gateway, and the NAT gateway would understand that, okay, this is a private instance, and it would basically translate the private instance's IP address in order to access the internet, and then it goes through the internet gateway and access the internet. So with the NAT gateway, the private instances can access the internet, but the third-party entity can only access the public instances which has public IPv4 addresses. They cannot access the private instances which do not have public IP addresses, which only have the private addresses. Okay, so I think it's pretty clear here what is the distinguish between internet gateways and NAT gateways, right? Okay, so when you provision a NAT gateway, you're charged for each hour that your NAT gateway is available. So once you create it, so if you leave it like that, for each hour it will get charged, even though if you're not using it, because it's not a service you can stop or start. It's just an entity which is created and it's available in the subnet. So if you're not going to use it after some time, after practice, delete it because you will get charged, and each gigabyte of data that it processes. So when the private IP addresses are trying to access something from the internet, let's say if they are downloading 2 gigabytes of data into the instance, so you would also have to pay for that particular network packets which are coming in. So that's what they are saying here. And finally, the NAT gateway replaces the source IP address of the instances with the IP address of the NAT gateway. Okay, I think this particular sentence makes it pretty clear. For example, let's say this instance 10.0.1.5, the IP private IP address. So this instance wants to access the internet. So now, as I told you, it will be taken to the NAT gateway, and the NAT gateway will do network address translation, translates the private IP address of the instance, and it attaches the IP address of the NAT gateway itself, which will be able to access the internet via the internet gateway. Alright, so this is basically how internet gateways and NAT gateways work. So now moving on to the next topic, which is network interfaces and elastic IP addresses. So network interfaces is a separate thing, elastic IP addresses are a separate thing. So now let's see what is a network interface. So an elastic network interface is a logical networking component in a VPC that represents a virtual network card. So usually in a regular hardware system, so every particular network would have, or in every particular server would have a network interface, or a network card. So in this case, it's a virtual network card. So what does this network card have? So that's what they're listing here, the attributes of this particular network interface. So again, every EC2 instance would have a network interface attached to it. So there would be a primary private IP address. There would be one or more private IP addresses if we want. There would be one elastic IP address associated to it, a private address. So then there would be one public IP address, one public IPv4 address. So if we enable this, there is an option called auto assigned IP address, public IP. So that is enabled, it will automatically launch an instance and provide it a public IP address. If it is not given, then it will only have the first three, that is the private IP addresses. Then later, if you want, we can attach another elastic IP address. So that doesn't come with the network interface by default. And then one or more IPv6 addresses. Again, if enabled, we would get IPv6 addresses. Security group, most probably at the beginning you would have one security group. Then if you attach multiple security groups, then obviously there will be more. And then a MAC address, and then the destination check flag, source or destination check flag, and finally the description of what that particular resource is. So these are the attributes which will be available in an elastic network interface in AWS, so in VPC. So this will be attached to EC2, and these are the IP addresses which will be available. These are the description. These are the different types of attributes which will be available. Okay, and then the next one is elastic IP address. So an elastic IP address is a static public IPv4 address designed for dynamic cloud computing. So you can associate an elastic IP address with any instance or network interface in any VPC in your account. So with an elastic IP address, you can mask the failure of an instance by rapidly remapping the address to another instance in your VPC. To put it very simply, let's say you have two instances, EC2 instances running. Both of the EC2 instances have the same application running inside of them. Okay, so now let's consider, so we have not attached any elastic IP address to this. So now this particular instance will have a different public IPv4 address, and the second instance will have a different public IPv4 address. So if, let's say, the first instance is the primary instance and the second instance is the secondary one, so the primary instance will be running all the time. If the primary instance is down or there's any maintenance going on, then the secondary instance would be running in behalf of it. So now if there's a failure in the first instance, the IP address of the second instance is completely different, so there would be a minor downtime for that particular IP address change to be made. Okay, but what if you can use an elastic IP address which is static? It won't change even when your instance restarts. Let's say you terminate an instance, elastic IP address will still be available. You can attach it to another instance, it will still be the same IP address. Okay, so what I'm meaning here is, if you attach that elastic IP address to that particular subnet or that particular instances, so if this particular instance fails, there would be another instance running, but the IP address of that instance also would be the same, because you have attached an elastic IP addresses, and that would basically rapidly remap the address to another instance in your VPC without any delay. So that's why we have to use an elastic IP address. But the thing is, if you create an elastic IP address and attach it to an instance, there is no cost to it. When it is attached to an instance, there is no cost to it. But if you do not attach it to any instance, there would be a cost. So you would get billed for it. So if you create an elastic IP address, either use it or delete it. Again, this is if you are practicing it. Later you can use it however you want. But obviously, if you're not using an elastic IP address, delete it if it's not integral to any of your services. Okay. All right. And the next topic is route tables. So a route table contains a set of rules called routes, and that are used to determine whether network traffic from your subnet or gateway is directed. So already we discussed about this, right, when we talked about internet gateway. So in route tables, there are various components. So the first one is main route table. When you create a route table, there would already be one. So the route table that actually automatically comes attached to your VPC when you create it would be the main route table. So if you see the default VPC, there would already be a route table available. You can create another one later if you want to, but that default route table which gets created when you create your VPC is your main route table. So it controls the routing for all the subnets that are explicitly associated with any other route table. So that is, it basically means if there is a subnet which is not associated with any other route table, it will control the entire routing for those subnets. Then there is a custom route table which you can create for your VPC. It's in your hand. Then destination, the range of IP addresses where you want traffic to go. For example, external corporate network with CIDR 172.16.0.0/12. So if you want the IP address range within this, so this would be an IP address range. So it's an external corporate network, and you want only the systems, that is the computers with these IP addresses to access your particular resources in your AWS VPC. Okay, so in that case, you can set it up like this by providing the destination with the appropriate CIDR block. And then the target, the gateway, network interface or connection. So whatever is the target. So for example, this would be the target, and this would be the IP address which you'll have to provide. Okay, in this case, the target is internet gateway, IP address is all traffic. Okay. And then comes route table association. So the association between a route table and a subnet, internet gateway or virtual private gateway. Again, so this is the route table. So it has been associated with the internet gateway. So that's basically is the subnet route table association. And then subnet route table, a route table that's associated with the subnet. So when you associate a route table, especially to a subnet, that basically means that is associated with a subnet. So that would be called a subnet route table. And there is something called a local route, a default route for communication within the VPC. Within the VPC, you can provide the IP address of the VPC and connect it to the VPC. That would be for all communication which is happening within the VPC. Okay. All right, guys. So now to understand even better what is a route, each route in a table specifies a destination and a target. So the destination is the range of IP addresses and the target is the target component in VPC. So in this case, the target component is internet gateway and you want to allow all traffic through the internet gateway. So that's why you are providing this particular destination. Okay, for example, to enable your subnet to access the internet through an internet gateway, add the following route to your subnet route table. So this is basically what they are telling us to do. You can also do this. So that's, again, I'll be showing that in the demo. The destination for the route is 0.0.0.0/0, so which represents all IPv4 addresses. The target is the internet gateway that's attached to your VPC. Okay, so basically the internet gateway is attached to your VPC and that would be the target, and the destination would be the IP address range, which is 0.0.0.0/0, which represents all public IPv4 addresses. So that basically means it provides access to all internet. Okay, so the next topic is VPC peering. So VPC peering is one of the main concepts in VPC. Again, it's a really easy concept to understand. So a VPC peering connection is basically a networking connection between two or multiple VPCs, mostly two, that enables you to route traffic between them privately. So if you do not want to use the internet, let's say you have two VPCs and there is an instance in VPC A and there is an instance in VPC B. So now the instance in VPC A has a private IP address. The instance in VPC B will also have a private IP address and a public IP address. Okay, so now let's say you want to basically make sure this instance communicate with this instance. You want to like establish connection, or you want to log in into this instance from this instance, or log in into this instance from this instance. So now if there is no VPC peering connection, in that case both of these instances should be public. Only then they can access each other, only then they can communicate with each other. But in this case, with the VPC peering connection, they can communicate with each other with just their private IP address without even having to go to the internet. So instances in either VPC can communicate with each other as if they are within the same network. So to establish that, you will have to do a VPC peering connection. It's pretty simple. You just choose a VPC as your requester, and another VPC would be the acceptor. So VPC A would request VPC B to get into a peering connection, and then once VPC B accepts it, the peering connection is established, and then all the resources in VPC A can communicate with the resources in VPC B via a private connection between them. Okay, so the same thing, you can connect multiple VPCs. So over here to the right side, you can see VPC A has a peering connection with VPC B as well as peering connection with VPC C. So you can have multiple VPC connections as well. So in this case, you can also create a peering connection between VPC B and VPC C if you want to. There is also multi-region peering, that is a VPC in one particular region, let's say North Virginia, can connect or can create a peering connection with another VPC which is in, let's say, Ohio region. You can also create a peering connection between VPCs in two different AWS accounts. So a VPC, I have a VPC and I have an instance, and let's say there is a friend of mine who has a VPC in his AWS account, and there is a database, and I want to access that database from my AWS account, and I don't want to do it publicly. I want to do it privately within the AWS network itself. So in that case, you could create a peering connection with that particular account, and then you can use your instance to access that database resource within their VPC. So that can be done using VPC peering. So this is one of the most important concepts, and also a really easy concept to understand, and also a really easy concept to start working on. Okay, so these are the different components, and these are the different topics in VPC, guys. So now let's just move on, and let's get started with the demo. We'll be starting off by creating a VPC. I'll be showing you what are the different components once you create a VPC. Then I'll be showing you how to create a subnet, that is a private subnet and a public subnet. And I'll be showing you how to create an internet gateway and attach it to the VPC, how to create a NAT gateway and attach it to the VPC, and then also how to create a VPC peering connection. And yeah, so these are the things we'll be covering in this particular tutorial session, guys. So now let's move on to the demo. So guys, now we're going to start off with the demo. So first, open the console. I hope you already have created your AWS account and already have done the EC2 demos. So right now we're going to straight up start off with the demos in VPC. So the first thing you'll have to do is again open the, so basically in EC2, I just wanted to show you guys. So as I told you, while you're creating the EC2, the second option is basically to select the VPC you want. And over here you can see there are security groups, elastic IP addresses, network interfaces. So these are concepts which we learned in the theory part. So these also combined with the VPC module. Okay, so now I'm going to search for VPC. So isolated cloud resources. This is basically the VPC service. So once you open VPC, again, there will be a dashboard which will show how many VPCs are available, how many subnets are available, how many route tables are available, internet gateways. There are no NAT gateways, no peering connections. There are 3 network ACLs. There are 92 security groups. Yeah, so no elastic IP addresses. So every single thing is provided in this particular dashboard, and also it will show that whether Amazon EC2 is working properly or not, because VPC is the networking side of EC2. Okay, without the networking side of EC2, you cannot launch an EC2 instance because you need a network to launch an instance, right? So here you can see you can either launch an EC2 instance or you can open the VPC wizard. So let's create a VPC. So that's the first thing we're going to do in this particular demo. So launch VPC. So here you get an option to launch using the configurations which they already have. So this will basically create a VPC and a public subnet inside of it already for you. So it's a ready-made setup. So you can do that VPC with a single public subnet, VPC with a public and a private subnet with a NAT gateway. can also be created without anything. You don't have to put any effort. You can just select this and it will create this exact same thing for you. And then VPC with public and private subnet, and also hardware VPN access. So when do you need this? Let's say you are in an on-premises setup. So now if you want to access your on-premises servers as well, so to access that you need a certain connection. And obviously your on-premises setup, it's not VPC. VPC is only available in AWS. So in this case, you would need a VPN connection, a virtual private network connection, which creates a secure connection between the on-premises network and the AWS cloud, which allows you to basically transition and connect to your corporate data center so that you can basically communicate with the servers in the corporate data center from AWS and vice versa. And finally, VPC with a private subnet only. So this is just for communication between the corporate data center and the AWS resources. There is no public activity. There is no internet activity in this case. So you can use the VPC wizard. Okay, if not, you can open your VPCs and click on create VPC. And you can see I already have tried long back. Let's just see this. Yeah, so again, you can see this is not the default VPC because I created it. So this is the default VPC. You can see default VPC. Yes. This is again another VPC. And again, this is not the default VPC. So to delete a VPC, it's the same thing. You can just select it and delete VPC. So if you delete a VPC, it will show what are the other resources which are associated to it, which will get deleted. So in this case, one subnet and one security group will get deleted. So if I give delete and click on delete, so it will delete the VPC, the security group, and the subnet associated to that particular VPC. So yeah, so it's that simple. So now let's start off with creating a VPC. Click on create VPC, provide a VPC name. So let's say VPC, and then you can provide a CIDR block. So I'm just going to provide a simple 10.0.0.0/16 so that it will allow lots of possibilities for me. So only these two would be closed, and then basically if I so I can change this as well. If I want to, I can change this like this. Okay, so it doesn't matter. Okay, so we'll create another VPC with a different CIDR block. For now I'm using this, and I don't want any IPv6 CIDR block, and I'm going to keep the tenancy as default. So what tenancy means is if you use a dedicated one, it will give you a dedicated VPC in one particular physical hardware. So you can run instances in your VPC on single tenant dedicated hardware. So that's the only difference. But if you choose dedicated, that will cost you even more than the default one. So the default one is basically common for everyone. Your VPC will be created in a hardware in which there are other people who also have created VPCs. Even though they are logically separated, even though they are logically isolated, even in that case, they are all in the same physical hardware, right? So that's the only difference, and also it will cost you more. Dedicated will cost you more. And then if you want, you can provide the tags. So I've already provided the name for it, and it automatically took it as the tag. So I'm going to use that, and I'm going to create the VPC. So that's it. A VPC has been created. Okay, so now let's just look into the configuration, which is here. So the CIDR block which we have provided, all right, and then DNS host names are disabled, DNS resolution is enabled. So a main network access control list is created, a main route table is created, DHCP option set is created, and yeah, so pretty much whatever we need is created. So let's look at the DHCP option set. Over here, as I told you, it will have all the information like the domain name servers, and all that. So the EC2.internal domain name, Amazon provided DNS. This is the domain name servers. All right. Okay, so this is DHCP, and then also the main route table. So as I told you, a main route table will be created. Later, if you want, you can create another route table and associate it with the VPC. Again, I'll also show you that later in the demo. So now this is the main route table. Yes. You can see which VPC it is associated with, the scalar VPC which we just created. Okay, so we can see the routes, and there is only one route, which is the local route. So we also looked into it. So the local route will allow communication between the VPC itself, And if you want to edit, you can just click on edit routes and you can add route. Yeah, so you can basically change it over here. So you can see instance, network interface, gateway, load balancer, endpoint, local. Yeah, so you can add a route and you get more options. So the thing is, you cannot remove the local target. You cannot remove the main route. The thing is, if you remove the main route, that will basically remove the communication between the VPC. So basically Amazon or AWS themselves do not allow that. So you can see the thing, right? There is no option to remove this particular rule, remove this particular route. Okay, later if you want, you can add routes. If not, it's fine. Okay, so this is the main route. Okay, and then there is a main network ACL. So again, as I told you, this is more like a rule set. So there are inbound rules, so all traffic is allowed, and outbound rules, all traffic is allowed. So there are certain things which you'll have to know in network access control lists. So the rule number will basically tell you what is the first rule which has to be executed. So if it's 100, then it will be executed first, then it's 50, it will be executed second, and if it's star, it will be executed at the last. So basically you'll have to know what is that hierarchy, or which has more power. So that will be provided in the AWS documentation itself. So we can just have a look at it. Network ACLs. So this is the documentation. And yeah, so optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of more or one subnets. Okay. Yeah, so here is the rule. So this is the default network ACL. And coming to the next part. So the network ACL has outbound rules 100 and 110 over here. HTTP and HTTPS are allowed out of the subnet. There's a corresponding inbound rule that enables responses to that outbound rule, inbound rule 140. So you can see, right? So according to the order you provided and according to the number you provided, that will basically determine the hierarchy, or it will basically determine when should what be executed. So for more info, again, you can check out the documentation. You can go through this entire thing. So you can see here, right? They've also provided comments. You can allow a certain port number from a certain IP address. You can deny a certain port number from a certain IP address. Yeah, so this is basically network ACL. Again, you can learn about the basics and all of it in the documentation itself. All right. Okay, so now going back. Okay guys, so we've created a VPC right now, but this particular VPC does not have any subnets. And let me just go to your VPCs. And now you can see, so we've created a VPC right over here. Yeah, so this is a VPC we've created. This is a VPC ID. The VPC is available. And over here, CIDRs, we can see the associated CIDR is this. We do not have any IPv6 address. And yeah, so pretty much we've created it. Okay, so the next step is creating a subnet. So again, to start off with, you can also use the VPC wizard, where you can create a complete, like a private subnet with a public subnet with a NAT gateway automatically. But it would be better if you learn by doing it manually, so that if you understand and do it manually, and if you know the concept and how it works, then you can use the wizard and create it whenever you want. So there's no issues with that. Okay, so the next thing, we have to create a subnet. Let me click on subnets. Okay, so now you can see there are already around 6 subnets. So all of these subnets are default VPC subnets. So why are there 6 subnets? Because in North Virginia, in this particular region, there are 6 availability zones. So if I click on this subnet, you can see this is for 1F, right? This is for 1B, for 1D, for 1E, 1C, and 1A. So these are basically for the default subnet. And over here you can see the IPv4 CIDR is provided as 172.31.48.0/20. Okay, so this basically means there are 4091 IPv4 addresses available. So also it should be actually 4096 total addresses, but the thing is, for 5 IP addresses would be blocked by AWS themselves. So like the first 0.03, 0.2, 0.1. So few of the IP addresses will be blocked and some of it will be already taken. So that will not be covered. So it would be -5. And yeah, so that's basically it. Okay. Yeah, so this is a subnet. So now let's start creating a subnet. So there is no separate way of creating a public and a private subnet. The only difference is when you create a public subnet will have internet access. It will be connected to the internet gateway. There would be a route to the internet gateway. A private subnet would not have a route to the internet gateway. That's the only difference between a private and a public subnet. Okay, the resources in public subnet would have access to internet. Resources in private subnet would not have access to internet. Only if NAT gateway is connected, they will have access to internet. But again, internet, there won't be communication or there won't be a two-way communication. There will be just one way. Okay, now let's create one. So the first step is to select the subnet, and I'm going to select the subnet we've created. All right, and I'm going to name it as scalar subnet 1. Availability zone, we can choose one if we want to. If not, we can just leave it. I'm going to choose US East 1A, and side of block I'm going to provide as 10.0 point. So let's say we can make it 1/20. So this is one subnet which I'm creating. So if let's say if this particular subnet's IP address overlaps or goes outside of the range of the CIDR block of the VPC, it will throw an error. For example, if I do this, yeah, so so now you can see the CIDR address is not within the CIDR address of the VPC. Why? Because the CIDR address of the VPC is 10.0.0.0/16. That basically means the first 16 bits will remain unchanged for any IP address which is within the VPC. So in that case, we can only change the last 16 bits. So that's why if we do 1 over here, so this won't be any problem now. We can create a subnet. Okay, so but before that, I want to create another subnet because I want to have a public and a private subnet. Okay, so to create another subnet, you can just add a new subnet over here, and I'm going to name it scalar subnet, or let me do one thing. I'm going to name it public subnet 1, and I'm going to name this private subnet 1, and that was 1A. This is going to be 1B, and this is going to be 10.0.20 and 24. So I'm going to give a different CIDR block. So you can see CIDR address overlaps with existing subnet CIDR. So basically, this particular CIDR block cannot overlap the subnet, cannot overlap the IP addresses of the other CIDR block. So for example, let's say if I make it 20, so again, it still overlaps. So we'll basically have to change a few things. So the problem here is the first, so if it's 20, right? So this basically means the first, how to say that? Yeah, so 20 bits. So in this 8 bits are there, right? So in the 8 bits, 4 bits remain unchanged and the other 4 bits can be changed. So now in this again, if I give 2, this basically means then the 4 bits will remain unchanged and 4 bits will change, but it will still overlap with the IP addresses in this. So what I'm going to do is I'm going to make it this 0. I'm going to make it 1. I'm going to make it 0. I'm going to make it 2. Let's make it 24. Yeah. So I'm going to make this also 1, 0. Yeah. So now basically this first 3 characters, that is the first 24 bits, will remain unchanged, and over here again the first 24 bits will remain unchanged. So that basically means they cannot practically overlap. The IP addresses will not overlap. So that was the only problem, and now it is resolved. So you'll basically have to select the CIDR blocks accordingly so that they do not overlap each other. Okay, so now I'm creating the subnet. Yeah, so done. So 2 subnets are created. Yeah, so you can see, right, the other subnets without the name are the default subnets one, and the other 2 are this. So I'm going to do one thing. I'm just gonna give the VPC ID and just gonna keep my subnets available to show them. Okay, it'll be much easier to navigate, right? All right, so public subnet, private subnet. We've created 2 subnets, guys, but the thing is, Still, it doesn't matter. Both are not. It's not a public subnet. It's not a private subnet yet, because over here you can see. So if I go to root tables, again even here I'm going to do one thing. I'm going to select the VPC. I think this is the VPC, right? Okay, so this is the one 017. So I'm going to just 085. So this is the VPC, yeah. Okay, so this is a route table. So if I go to routes, so only the local connection has been established. So in this case, you will have to establish a connection to the internet gateway, which will be attached to the public subnet, right? Okay. So now subnets are created, guys. So later we'll be making them public and private subnets. So to do that, first we would need a internet gateway. So let me create an internet gateway. Alright, so there is already internet gateway, but this is the internet gateway of the default VPC. So first we'll have to create an internet gateway. So to create an internet gateway, just click on that, and I'm going to just put scalar internet gateway, create internet gateway, and attach to a VPC. So internet gateway has been created. Now we'll have to attach it to our VPC. So I'm going to click on it. I'm going to select the VPC which we've created and attach internet gateway. So we've attached it to the VPC. Okay, done. Okay, so this is the internet gateway which we've created. It's been attached to the VPC of our choice. So now we'll have to go to the route tables, and in this case, scale a VPC. So this is a route table. We can go to routes. So subnet associations, again, we'll have to associate a subnet, right? So to make, so we've created the internet gateway. Now we are set to make the public subnet an actual public subnet, because the public subnet should have access to the internet, private subnet should not have. So to provide access to the internet, first thing we'll have to do is create a route which will allow all traffic via the internet gateway. So to do that, click on edit routes in the route table, in the main route table. I'm going to click on edit route, add route, and I'm going to make it all IP addresses 0.0.0.0/0 means all IP addresses. Target would be an internet gateway, and it will basically search for the internet gateways available, and the only internet gateway which is attached to the VPC of this particular route table is scalar IGW, scalar internet gateway. So I'm just going to select it and save changes. That's it. So we've attached the internet gateway to the VPC. So now the VPC has internet access. Now how to make the subnet a public subnet? So to do that, we'll have to associate the subnet to this particular route table. So we should not, so for example, so yeah, so we can do this. Yeah, so public subnet should be the only subnet which should be associated with that route table. Private subnet should not be associated with it. If it is associated with it, then that would basically mean it will also have internet access. Okay, so now going to route table and selecting the route table, going to subnet associations and edit subnet associations. So explicit subnet associations, subnets without explicit associations. So these are the only subnets which do not have any associations. So I'm going to associate them. So edit subnet associations, select the subnet which you want to associate and save association. That's it. So now we've attached, we basically associated this particular subnet and to this particular route table which is connected to the internet gateway. Okay, so now what I'm going to do is let's create a EC2 instance inside the VPC we've created. Okay, so we have a public subnet. So one thing we'll have to change is go to the subnet. So one thing you will see is if I click on this, you would see auto assign public IPv4 addresses is disabled. So we'll have to basically edit this into allowing that, because when we create an EC2 instance within the subnet, it should basically create a public IP address for it. Okay, so to do that, we'll have to change it. We've selected the subnet. Let's see if there is an edit option here. View details, action, edit subnet settings, and we're going to enable auto assign public IPv4 addresses. So any instance which is launched within the subnet will automatically have a public IP address. Okay. Done. Okay, so that is enabled. Now going back to the EC2 management console. So I'm going to launch an instance. So I'm pretty sure you guys know how to do this. If not, please check out the previous tutorial, because I'll be just rushing through this. Okay, so it's the same step. So I'm just gonna go ahead and create an instance. So the only step you'll have to know is this particular step, step 3. So in this case, you'll have to change the network. So network, first scale a VPC and the public subnet. Okay, and you can see there are 251 IP addresses available for the public subnet. Got it? Okay, and then so use subnet setting enabled. So in the subnet, the setting was enabled, so that's why it is using the subnet setting. That is, the public IP address is enabled. So when you create an instance, it will automatically create the public IP address for you. Okay, so these are the only things which we'll have to do. These are the only changes which we'll have to make in creating an EC2 instance, to create an EC2 instance in your VPC, in your subnet which you've just created. Okay, so one more thing which you'll have to know is the network interface. So it will automatically create a network interface. You don't have to do anything. If you have a network interface already, you can create it. If not, you can leave it. It will automatically create one. And also you can associate a elastic IP address to it. So I'm not going to do it right now. I'm just going to create an instance. Because I just wanted to show you guys, we've created a VPC, we've created a public subnet, we've created an internet gateway and provided the root. So now once we connect to it, it should let us download something from the internet. So basically the instance, right, which you're creating, the instance should be able to download from the internet. If it's not able to download from the internet, then we've not created a public subnet. It is not able to access the internet. Okay, so now next, add storage. I'm just going to leave everything in. So I just need SSH. I don't need HTTP or anything else. So I'm going to review and launch and launch. So I already have a key pair, which is it's tutorial key. Now acknowledge and launch instances. Yeah, so the instance is being launched, guys. So I'm just gonna so this is the IP address. So it will take some time to create it. So let it create, then we'll open the terminal and connect it and check if the internet is working or not. Okay, so now coming back, so we've created a VPC, we've created subnets, we've seen how to change routes in route table and how to associate a subnet to the route table. We've seen how to create an internet gateway. Okay, so now I'll also show you how to create an elastic IP address and how to allocate the elastic IP address once the instance is created. And so I'll also show you how to create a NAT gateway. So okay, so now let it create. It won't take much time. Yeah, so it is running right now. Let's first finish this part of this session and move on to the next part. Okay, so I'm going to click on connect. I'm going to click on SSH client. I'm going to copy this and I'm going to search for terminal. I'm increasing the size. Alright, so now the file, the key pair file, is available in the downloads folder. So that's why I'm going to the downloads folder and then I'm hitting enter. So if it's successfully working, then it'll basically log in into the instance which we've created within the VPC which we've created and within the subnet which we've created. So it's taking some time, so that I think it's still creating the instance. So it's still initializing, so maybe that's why it's delaying. So let's wait until it initializes, guys, so that we could just connect it instantly. Okay guys, so now you can see the status checks have been passed. So now we can start off with connecting the instance. So I'm just gonna click on this, click on connect, SSH client, copy the command and paste it over here. Let me just check. Oh, sorry, I'm not in the downloads folder. My mistake. Yeah, so what's the problem here? Yeah, so it's connected, guys. So it's successfully connected. I'm just going to clear the screen. Okay, so now we are in the instance. So now this instance should allow internet access, right? So that's what we've done. We've created an instance in the public subnet. And also internet gateway has been attached to the VPC, and we've also associated the subnet. So this particular subnet should allow internet access. So that's what we're going to figure out. So we'll see if it's able to update. So it's able to update, it's able to fetch data from the internet. So that basically means we've successfully created the VPC and a public subnet, and we've attached an internet gateway and provided internet access to the server. So we've successfully done that. Okay, so one part of the demo is done. So I'm just going to exit this instance. Okay, so let's just go back. Okay, so let this instance be, and let's go to the next part. So the next part would be basically NAT gateways, where we'll be creating a private subnet. So to create a private subnet, what are the things we need is we'll have to basically associate the NAT gateway to the public subnet, and the private subnet within the same VPC will access the NAT gateway in the public subnet, and that will do the network address translation of the private IP into the elastic IP which is attached to the NAT gateway, and then it will allow us to connect to the internet. Okay, so that's what exactly will happen. So that's what we're going to do. Alright, so the first thing we'll have to do right now is create a NAT gateway, and let's do that. Move to NAT gateway, create a NAT gateway, scalar NAT gateway, selecting the subnet. So the subnet should be the private subnet. Okay, remember that you will have to select the private subnet. Selecting the private subnet, connectivity type, select the connectivity type for the NAT gateway. The NAT gateway should be public, but you're attaching it to the private subnet. Okay, and then elastic IP allocation, you can associate an elastic IP or allocate one, or yeah, so basically you will have to create one, right? So I don't have an elastic IP, so that's why I was not able to select one. So for that, you'll just have to click on allocate elastic IP. It will automatically create an elastic IP and associate with the NAT gateway, because without the elastic IP, it would not be able to network address translate the private IP addresses into the IP address which just has been allocated to it. Okay, so now create NAT gateway. So NAT gateway has been created, guys. It has been connected to the private subnet. Alright, so NAT gateway has been created. We've connected it to the private subnet, but there is one problem, because it's not associated directly with the VPC. So it's associated with the VPC, but it does not associate directly with the VPC. So that's what we'll have to do right now. Okay, so I just realized, so one small mistake we've committed is that we've associated the private subnet. So that's not the case. We'll have to associate the public subnet, because the NAT gateway should be created in the public subnet, right? So it's available right now. So I'm just gonna delete it. Delete. So we'll create another one in the public subnet. Okay, because it should be available in the public subnet. Then we'll have to create a route which will let the private resources to access the internet via the NAT gateway. So that's what we're going to do. So I'm just going to create the same name and change the name a little bit. Scalar NAT gateway 1, and select the subnet. Subnet will be public subnet. So we already have an IP address which already got allocated. So I'm just going to reuse it and create a NAT gateway. So again, first the NAT gateway would show status as pending. Alright, so then it will become available. Okay, so let it get created. So the next thing we'll have to do is we'll have to create a custom route table. So we cannot associate the private subnet to the main route table, because that will make the private subnet a public subnet, because the main route table has an internet gateway attached to it. So for that, we'll have to create a custom route table. So I'm going to route tables, create route table, scalar route 1 VPC, scalar VPC, and then create route table. So we've created a route table, guys. Okay, so next we'll have to do is we'll have to associate a subnet. So in this case, the only non-associated subnet is the private subnet. So I'm going to select that and yeah, associate with custom route table. So subnet association has been successfully done. Okay, so now I'm going back to routes. So if the NAT gateway is created, we can create a route. Let's see. So it's still in pending state. Let's go to route tables, and also so we've allocated elastic IP address, right? So which got created. So that will be visible here. You can see that here. You can allocate IP address, you can release the elastic IP address, you can associate the elastic IP address to a certain instance. Right now, this particular elastic IP address has been associated with the NAT gateway. So if you want to associate it with an instance, you can just click on associate. Once you've created the elastic IP, then select the instance which you want to associate it to, and that's it. That particular instance will have the elastic IP associated to it. So let's check if it's been created again. Yeah, so the NAT gateway is created, guys. So the next step is to go to the route table and create a route. And so one more thing I wanted to do is, so this one I just want to rename scalar main route. The main route. I'm just going to leave space. Okay, so this is scalar main route table. This is the custom route table. So now subnet has been associated. So the only thing we'll have to do is change the route in scalar route 1. So edit routes, add route, all IPs. We'll have to select the NAT gateway. So this is the NAT gateway. We deleted this, so I'm going to select this and save changes. So we've created a route for the private IP address. So now let me just, I'll do one thing. I'll just give this particular CIDR and NAT gateway. So anyway, we're going to allow only the IP addresses from the private subnet to access the NAT gateway, right? So I'm just providing the same CIDR block as the private subnet to avoid confusion. So that's provided, and save changes. Okay, so we've created the NAT gateway as well, and yeah, so it's successfully created, and you can see this association also has been made. Okay, so I think it's already was created. I'm just going to remove this then. Okay, so done. NAT gateway has been created. So now the only thing we'll have to do is we'll have to create a private instance and try to access the private instance from the public instance. And then once we do that, then the next step would be to try to access internet from the private instance. So now the private instance should not allow internet. Let's say basically it should not allow internet if there was no NAT gateway available. So if there is a NAT gateway available, it should allow. So what I'm going to do is, to show that, I'm just going to remove this. So first let's create a private instance and connect to it, and let's see if internet works in that or not. And then we'll associate an NAT gateway, and then we'll see whether the internet works or not. So that basically will prove, that will be more of a proof of concept, right? Okay. So now I'm going back to the management console. I'm going to create an instance, which would be again Ubuntu, the free tier 1. Instance details again scalar VPC, but in this case it would be the private subnet. Done. So in this case you can see it's in disabled state. Okay, next. Okay, I'm just going to leave it like this. Next, review and launch, existing key pair, tutorial key, and launch instances. Okay, so we've launched the instance. So this instance will not have a public IP address, it will only have the private IP address. Okay. So the first thing we'll have to do is we'll have to log in into our public instance. So only via the public instance we can connect to the private instance, because they are within the same VPC and they can communicate. So even though they are in different subnets, doesn't matter, they are within the same VPC, they can communicate without any issues. Because you don't need internet to connect these two instances, because they are within the same logical network. So in that case, they could communicate, and they could these resources could connect with each other without internet access. So I'm just gonna connect to my instance again. I'm gonna go back. So the thing is, it will take some time because it's a new VPC and a new subnet. So usually when it's a new subnet, then the status checks will take some time, because that is the first status check happening inside that VPC, inside that subnet. So that's why it takes a little bit time. Okay. So why is this not connecting now? So I think it's the terminal issue. I'm just going to open another. Yeah, so it connected. So it was the terminal issue. I think it got stagnant. Okay. And yeah, so we'll just click on this. So now if we click on connect, again, it does not have a public IP address, so we cannot connect to it, but we can connect to the instance via the private IP, but only we can connect to the instance via the private IP via a resource within the same VPC. So we've already logged in to a resource within the same VPC. So we can connect to the private instance only from the resources available within the VPC. So that we can do. I'm just going to paste this. Okay, so one small thing we'll have to do is that we'll have to upload the tutorial key to this. So I'm just going to do one thing. So as I told you, the first thing we'll have to do is connect it to the private IP address. So connect it to the private instance. But the thing is, we do not have the PEM file. So the thing is, I copied the PEM file using a copy command and it has successfully worked. So I've already have the file. So the copy command would go like this. So I'll just show you guys. So it would be scp-i, and here you will have to put in your PEM file name of the public instance which you want to copy. Then here you will have to put in the file path. So this is the file path and the file name. It's actually tutorial key, right? Not tutorial, my tutorial. Yeah, so tutorial key. Okay, so then you will have to basically provide Ubuntu at the IP address 239.226.236. So what basically what this basically does is it accesses the instance, and it does not log in into the instance, it just accesses the instance. So I'm just going to put a sudo also, so once it accesses the instance, it basically will copy the file into the default folder. So you can also mention the default folder, like for example, where do you want to copy, home and Ubuntu. So this is where I want to copy the file. Okay, so then I can just put this. So this would be the command, guys, to copy the file. So you can just hit enter, and as I put sudo, it's asking for the password. I'm putting in the password. So so it's showing permission denied. So only thing you'll have to do is you'll have to change the directory and then copy it. That's it, it will work. And this will be the command. So if this doesn't work for you guys, what you can do is you can basically I'll show you something. FileZilla. So in FileZilla, you can basically download the macOS client. So this is the macOS client. So you can download this and you can connect the thing via this. Okay, so you can basically just download this, install it, and yeah, you can connect the instance to this and just upload the file via FileZilla. So this is one option, but I'm not going to show FileZilla in this because that's again a bigger topic. Okay, all right. So we already have the tutorial key.pem file in our public instance. So the only thing we'll have to do is connect to our private instance. I'm going to copy this and paste it. So now we are in the private instance. You can see that, right? So now we are inside the private instance where we connected it from the public instance. We cannot directly connect to the private instance because it doesn't have a public IP address, but we can connect it via the resource which is already within the VPC. So that thing we've done. So now there is no NAT gateway attached. So let's do one thing. Let's try to do this. So you can see, right, it's at 0%. It's not able to connect to the internet. Okay, so I'm just gonna stop it. Okay, so let this just be here. Let's just go over here again and let this be. Now let's do one thing. Let's now create this route to the NAT gateway. So add route, NAT gateway, choose the right one, save changes. So the route has been added, guys. Okay, it has been added. So now let's try to run the same command. Could not get logged. Okay, so let's try again. Okay, let's do one thing. Let's just log out. Okay, so now we are in the public instance again. So let's try to. So yeah, so we are in the public instance again, guys. So now let's try to connect back to our private instance. Okay, so now the NAT gateway is attached. The route has been created to the VPC, to the private subnet. It is associated with the route table. So now we can basically try to, and now internet is working in the private subnet. So we can just try, we can install sudo apt-get install apache 2. It's downloading, guys. So basically now we've established internet connectivity in the private instance as well. So we've established internet connectivity in the private instance, because you can see it's the private instance as IP address, right? So that's what we've done. We've successfully created an architecture. So what architecture we've created? This is the architecture we've created. Let me just open this. So this is the architecture which we've created manually. So there is a public subnet in which we have an instance. There is a private subnet in which we have an instance. In the public subnet, we have a NAT gateway which is associated with the private subnet via a route table. Public subnet is associated with the internet via the internet gateway, again via a route table. So this is the thing which we've created manually. So now if you select this, you can automatically create the entire architecture just using multiple steps. So you can basically provide the CIDR block over here. You can provide the VPC name, public subnet's name, private subnet's name. More than enough, it will automatically create everything for you. So but the thing is, if you don't do it by yourself, if you don't practice by yourself, you would not get the point. All right, so these things we've done, guys. I think you understood, right, how to do the public subnet, the private subnet, how to connect from one instance to the other instance, how to make sure if the internet is working or not. So everything we've done. So now what I'm going to do is I'm just going to terminate this because I don't need these anymore, and I'm going to close this. So the last part of this particular tutorial, the last demo, would be the VPC peering demo. So for that, we need to create a VPC. So let's just create a VPC using the VPC wizard. So I'm just going to select, let it be the same. I'm going to make this, and I'm going to make this, and I'm going to give preference as this, and that's it. So I'm going to create the VPC. So it created the VPC, it created the internet gateway, it created the public subnet, it created everything which we required for us. Okay, done. So now if I go to VPC, a VPC has been created. I'm going to name it as scalar VPC 2. So why did I create this? I just created this so that I can show you the peering demo. So going to peering connections. So we're going to create a peering connection between this scalar VPC and this scalar VPC 2. We're going to create a peering connection between these two VPCs. I'm going to go back to peering connection, create peering connection, and so name we can provide as peering practice. So the local VPC to peer with would be scalar VPC. So it's my account, another account. As I told you, you can also associate or connect to VPCs in another account, in another AWS account, but this is going to be my account. It's in the same region. You can also connect to a VPC in another region altogether, but it's in the same region. The acceptor would be scalar VPC 2. Okay, and then create peering connection. That's it. So this is more than enough to create, and then what you have to do is you'll have to accept the request. Done. So to send and receive traffic across this VPC peering connection, you must add a route to the peered VPC in one or more of your route tables. Okay, so let's modify the route table. This is the main route table. You'll have to go to routes, edit route, add route, same thing. So here it would be peering connection, peering practice, save changes. So this could be basically the IP address of that particular peering connection as well. I'm just gonna go back. And I'm gonna copy this and go back to route tables, scalar main route table, routes, edit routes, add route, add the IP, select peering connection, select the peering name and save changes. That's it. So now one more thing you'll have to do is, so this established one-way connectivity. Now one more thing you'll have to do is we'll have to basically do the connection for the other VPC. So this is what? Scalar VPC2. So this is the, we'll just check. Scalar VPC2 route. No, so this is the main route table of the scalar VPC2. I'm going to name it scalar VPC2 main route. Done. So in this again, I'm going to make a rule change. Edit routes. Peering connection, peering practice, save changes. So done guys, so that's it. So now if there are any resources in either of the VPC, so let's say there is an instance in this VPC and there is a database server in this VPC. So this instance could access the database server, and if there is an instance in this VPC and there is also another instance in this VPC, they can also connect. So basically like how we connected to one private instance from the public instance, same way we can connect to the instance inside VPC2 from VPC, or we can connect to the instance in VPC from VPC2. So vice versa, we can do anything we want. So these are the things guys. So we've learned about VPCs, we've learned about subnets, we've learned about route tables, we've learned about internet gateways, we learned about elastic IP addresses, we learned about NAT gateways, peering connections, and security groups we've already learned in the EC2 tutorial. And one more thing, what was the one more thing? Yeah, so the network interfaces. So we've learned a lot of things. I hope you guys understood what exactly was going on over here. So now what you can do is, so let's say I can just delete this, but it has a peering connection. So the first thing you'll have to do is delete the peering connection. So if I delete the peering connection, I think it'll ask me to remove the routes. Delete related route table entries. Yes. So now we are deleting the peering connection and also deleting the routes. So it has been deleted successfully. So now let's try to delete it. Yeah, so now we can delete it, and it will basically delete all the resources associated with it, so you don't have to worry about it. Done. It's all deleted. Okay, so now scalar VPC is there. Again, we can also delete this as well. I'm just going to click on it and delete it. So again, there is one issue because there is an elastic IP address attached to it. There is an NAT gateway attached to it. So the first thing we'll have to do is go to elastic IPs, and so yeah, it's attached to the NAT gateway, right? So first we'll have to delete the NAT gateway. Delete, and then go back to elastic IPs, refresh this. So it's allocated. I don't think we'll be able to dissociate it right now. So it has to be completely deleted. Only then we can disassociate. This is a network address card. It's connected to this NAT gateway. So is it deleted? So NAT gateway is deleted. Okay, so it takes some time, so let it be. So now let's just go to VPCs and try to delete it. Yeah, so it's still saying there is a network interface. So as there is a network interface, it's not letting us to delete it. So I'm just going to open this and let's delete the network interface. Okay, so again, the network interface is attached to the EC2 instance. So in that case, we can delete the EC2 instance altogether. So done. We have terminated the EC2 instances. Okay, so now going to network interfaces. So I'm just showing you how to clean up. So the network interface has been deleted. So why it was not allowing us to delete the VPC is because there is a resource within the VPC. So if we delete the VPC, that basically means we'll not be able to use the resource. So it cannot be done. So once you don't have any resources within the VPC, only then you can delete it. Now let's try it again. Delete VPC. So it still thinks it's in use. That's the problem. Yeah, so now we can delete it, guys. And so it will delete the public subnet, the security groups, private subnet, the internet gateway, and the route table. Delete and done. Okay, so we've created VPC subnets and we've also deleted them. And Elastic IP, as I told you, if you create an Elastic IP and do not associate it with anything, then it will charge you. So now the NAT gateway ID has been removed from here. That basically means it's ready to be deleted or released. So I'm just going to click on release. Done. So basically we've created everything and also cleaned up everything. So this is one of the important steps when you're practicing, because as I told you, if you just leave it like that, you might get billed. So to avoid getting billed, to just practice in the free tier limit, always clean up the resources once you're done with it. So guys, that's it for today. I hope it was helpful and informative. So if you have any queries, please leave a comment down below and we would love to help you out. And also if you like the video, please subscribe and share. Thank you.